Hello Cloud Gurus and welcome to the course AZ301 Microsoft Azure Architect Design. My name is Nick Collier. I'm a Cloud Solutions Architect working with large enterprises to deploy Azure solutions. I've also had the privilege of teaching thousands of students Azure certification, and I'm delighted to be your instructor for this course. If you joined us before for AZ300, then a warm welcome back. And if you're brand new to the Azure Solutions Architect certification, then welcome on board, and we're glad you're with us to undertake this fantastic journey to get certified in Azure at an advanced level. During this course, we will lead you through a series of sections, modules, demonstrations to prepare you for taking and ultimately passing the AZ301 exam. The sections are divided up as follows. Section 1 focuses on determining workload requirements. The entire focus of this is on gathering requirements and evaluating which products and services might fulfill that need. In addition, we look at how to optimize for costs and discuss monitoring solutions as appropriate. Section 2, Design Identity Management. Here we cover design principles related to identity management, authentication, authorization, risk prevention, and the monitoring of identity. Section 3, Design a Data Platform. In Section 3, we move on to designing a data platform. This includes data management, data protection, data flow design, and monitoring again focused specifically on the data platform. Section 4, Design a Business Continuity Strategy. In this section, we focus on designing for site recovery, high availability, and data archiving. Section 5, Design for Deployment, Migration, and Integration. In this section, we look at mechanisms for migration to Azure and how we would select the appropriate methodology to move those particular workloads. Section 6, Design an Infrastructure Strategy. By now, having taken a monumental amount of training in Azure, if you got this far, we look at an infrastructure strategy overall as it relates to compute, storage, networking, and monitoring, things you should already be familiar with. In addition to the lectures and demos covered in each section, there are also study guides which link to the key Microsoft material that you should also plan to read as you walk through the course. Azure is constantly changing, which is challenging and exciting at the same time. I personally couldn't be more excited to have you on board and guide you through your Azure certification journey. I'm sure you will just get a ton of value out of your time spent and be part of the amazing Azure wave that is here right now. Good luck, and please let us know if we can help you further in any way. Before we dive into all the content, before we jump into all of the content, let's take a minute to just go over some exam tips for you. Well, first of all, there's going to be between 40 to 60 questions in the exam. Some of those questions are worth more than 1 point, and make sure to just answer all the questions. There's no penalty for you taking a guess at some of the multiple choice questions in the exam. In addition, plan for about 180 minutes, about 150 minutes of that to answer questions, 30 minutes for various instructions that will be presented on screen, comments, reviewing, etc. Then for types of question, predominantly you should get multiple choice questions, but note that they do add new types in it now. There's list questions, hot area questions, active screen, drag and drops become a very, very popular one where they ask you to match certain statements to things on the, say, the right-hand side. You'll sort of drag things from the left to the right. Those are pretty common now as well. So no, it's not just going to be multiple choice. You do need to really understand the concepts, and that really brings us on to use cases. There's lots of information to absorb, compared to AZ300, that was very much a hands-on exam. Here we're going to have a lot of case studies where we're listening to requirements from potentially a customer that you might deal with in the real world and have to decide what's the right architecture to map to them. So the way I approach this really is focus on the key points. First of all, skim read the case study, get through it pretty quickly, then get to the questions so you can see what they're really probing you for, and then go back and read the case study again and dig in for that specific, pieces of information that you're after. If you took the AZ300 exam already or course, just again note, this exam focuses more on design and choice compared to kind of the hands-on focus that there was in AZ300. What that means is that the core concepts on compute, storage, and networking, we will repeat them in this course. So things like VMs, app services, etc. We'll review those. If you took AZ300, you can skim over some of those things. Otherwise, definitely review it because it will help you. There's a lot more questions on things like pricing, focusing on requirements and mapping those requirements to the specific technology choices. Pay a special attention to things like availability and recovery when you're covering those pieces around compute, storage, and networking, monitoring as well. And with that, that's kind of the exam tips for you. Good luck, enjoy your studies, and please let me know if you have any questions along your way. One of the core requirements and concepts of this exam, as you can tell, is in identifying requirements, truly mapping those requirements to the technologies. And so it's a bit of a catch-22. Yeah, we haven't gone through all the technologies yet, but Microsoft expects you to know how to identify requirements early on. So what I urge you to do is, as you go through this section of the course, come back to it again later on once you finish going through storage, compute, networking, business continuity, etc., and it will help to solidify that information. But what I thought I'd do is kind of talk through the approach that I go through a lot when I'm in the field and I'm working with very large enterprises with my team of Azure engineers, Azure consultants, business consultants, and how we go about identifying requirements. Well, the very first thing is we look at use cases. What are the business drivers? What's driving our need for cloud? What's driving our need for this new application, perhaps, that we want to put on top of Azure? We really have to understand the goals of the business and the application teams, and we use those to then formulate specific requirements. So often this is a whiteboard exercise. We'll have a workshop session with our customer, with the business. If you're doing this in your own IT department, you'll have a workshop session, perhaps a 1-day, 2-day workshop. These typically involve, and map out all those use cases on a whiteboard with them. As part of that, you'll look at any assumptions that are being made about these requirements. Are people assuming that we're going to use existing licenses? Are they assuming that we're going to use existing technologies that we've done before? Something that comes up a lot are things like automation tools. Do we want to continue to use things like perhaps Terraform, Puppet, Chef? Perhaps we've used some tools on premises that we want to bring to the cloud, or are we going to adopt some of the more native services? And we should also challenge those assumptions as part of this activity as well. Then we have critical success factors, and we try to align these to the specific business outcomes as well. For example, my application needs to be scalable to XYZ, whatever that is. That could be a number of users that comes on. That could be in 3 years, something's going to happen in the business where they're expecting an influx of users. And there's some critical success factors that you need to think about like this. Others could be, hey, I want to continue to use my existing operations team. I don't want to have to go out and train new talent to come in and work on this particular project. And so if you look at use cases, assumptions, critical success factors, look at them in parallel as you work through the requirements, it will really, really help you architect a really good solution. As you move along, then you look at the business needs. There's some areas that you can break down here, and Microsoft looks at it in these 6 pillars. One, we define those business objectives. So is this a 24/7 application? What is my RPO, RTO that is acceptable? Does the application need to be globally available? Then document the SLAs. What is the availability requirement that I've agreed on with the business here? Is it 99.9%? Is it 99.99, 99.95? Document it so you have an agreement, and then you can architect towards that SLA as you continue down. There will likely be questions in the exam on SLAs, and we do cover them a little bit more detail later on. In addition, look at functional and non-functional requirements. A lot of times people focus too much on the functional. Well, functional defines whether the application does the right thing. The non-functional requirements will tell you whether the application does those things well, and both are equally important. In addition, decompose by workload. So when you look at the business requirement as a whole, different workloads that fulfill that requirement may have different requirements for availability, scalability, data consistency, and disaster recovery. Maybe only a portion of the application needs to remain online in the event of a disaster, and then perhaps we can architect and optimize for cost a little bit more on that other workload that perhaps doesn't need to be up and running all the time. In addition, there's a couple more here. You do want to plan for growth as well. So what are the expected users, and how will you scale beyond that? And managing costs, this comes up over and over again. And at the very end of the course, I do go through an example of a cost calculator that I actually did for a client. It's been sanitized. There's no information there from the client, but it's a good real world example for you to see in terms of all the toggles and all the things that you can move around. And I encourage you to start to build out your own cost calculators for every application that you look at. There is the cost calculator on the Microsoft website for the Azure services. That's going to give you those costs, but you need to know all the things that you can toggle up and down, scale up, scale down. When I've got network traffic coming in versus out, there's different costs associated with that. So keep costs in mind throughout, your journey and anything you architect. In addition, there's the Azure Architecture Center. Be aware of this. There's example scenarios. There's lots and lots of information here. It will take you hours upon hours to read through this, but I encourage you to go through because there are design patterns, there are reference architectures, and there's a data architecture guide that I highly encourage you to go through as well. And if I just click the link here, it'll take us to Azure Architecture Center on the website. And you can see here, Azure Application Architecture Guide, reference architectures, the cloud adoption framework. I've spent a lot of time, working with teams around that. And here you can see this Azure Data Architecture Guide. When you go in there, it'll tell you all about traditional, relational database models, big data architectures, cross-cutting concerns, extending resource manager templates. There's a breadth of information here for you to go through. The associated study guides that should be available very shortly will also help you kind of, with these links so you know where to go. Now let's shift to compliance and security requirements. And first of all, you need to understand the shared responsibility model and how that shifts between on-premises, IaaS, PaaS, and SaaS services. So if you look at it, first of all, security is a joint responsibility. Cloud computing clearly provides many benefits over on-premises. And you can see that because if you look at the section in blue, on-premises, everything is responsible by the customer, basically, to take care of physical security, host security, network controls, application level controls, identity, endpoint protection, and data classification as well, because you own the entire stack. As you move from IaaS to PaaS to SaaS, you can offload more of those controls to Microsoft. So first of all, just take IaaS to begin with. Well, physical security is completely taken away because you don't need to manage it. Microsoft is manage it and meeting all the requirements as part of the security they have for their data centers. In fact, it's very difficult for even partner vendors to get that tier 1 status so they can even go into their data center. Different vendors like NetApp, etc., are sort of racking NetApp files in Microsoft data centers. They're one of the first tier 1 vendors that was approved, and they had to go through a rigorous security, screening and processing controls methodology to make that happen. In addition, as you move up, we look at like host infrastructure. That's like your VMware hosts, but these are now running in Azure, and your network controls. Well, you still see that some of that is your responsibility, and some of that is the cloud provider's responsibility. But as we continue to move up from IaaS to PaaS to SaaS, more and more of that we're offloading to Microsoft themselves in the case of Azure. Well, one catch though, you are always responsible for data. So even if you're using a PaaS service or a SaaS service, you're going to put data on there. You've got to classify that data. You're responsible for it. You need to know, whose data that is, what it's being used for, how it's going in and out of that system. You're always responsible for that. You're responsible for endpoints. So those could be VMs, they could be desktops, anything that's going to talk out from the service. You're responsible for those particular endpoints. You're responsible for the accounts. So, you're responsible for the keys, the passwords, all of those things there. And you're responsible for access management as well. And that includes making sure things like multi-factor authentication and things like that are implemented, because again, you're responsible for anybody that logs into these systems. Doesn't matter if they're SaaS, you still are responsible for the fact somebody gained access to that system. In addition, there's a shared responsibility, PDF file you can download from Microsoft. If you click this link and go in here, you'll see the shared responsibilities for cloud computing. There's a whole PDF that kind of explains that and what Microsoft's responsibility is and what your responsibility is as well. If we move on a little bit, there's also the Microsoft Trust Center. So this is in-depth information that you have access to. So this is FedRAMP, SOC, audit reports, data protection, white papers, security assessments that Microsoft does. They have the two teams that essentially, one does the attacking and one does the defending to continually, harden Microsoft services, and they make all of that publicly available, as well as some powerful assessment tools as well. So you may get asked a question around, where to get information, and the Trust Center, is the main place there. You won't be expected to know any of the assessments in detail, but you will need to know that they exist and where to get that information. In addition, that also leads you to Compliance Manager. So you may get a question on what tools can potentially help you around compliance. Compliance Manager is a place where a central location where you can manage compliance. It does proactive risk assessment. It will also do insights and recommended actions, and it prepares compliance reports for audits as well. So that's the kind of thing, again, when you're thinking of, hey, I've got to design an auditing strategy, which is one of the things in the curriculum. You could say, I'm going to use, Compliance Manager to provide, auditing reports, on specific, technologies that Compliance Manager can hit. Same as things like Azure Security Center is going to provide you certain elements of data. Perhaps your antivirus product has login and reporting. Then you've got Azure Monitor, Log Analytics, some of those things that we'll come into later. But think about it in the context of what am I required to provide for an audit. In addition, there's some other data protection resources. So if you go to servicetrust.microsoft.com and head over to Trust Documents, which I'll just click here as well, you'll get this page that comes up. And if we scroll down, you can see here all the audited controls. So you can see the Azure GDPR mapping, very popular one here. The compliance guides are all here. And I encourage you again, take a flick through a few of these because they will help you. There's some white papers, assessment reports, and here is that pen test and security assessment report that I mentioned as well. And Microsoft, again, routinely makes these available. They have to do that to ensure that their services are certified. Because again, because Microsoft is taking on some of that responsibility, we need to know that those systems have been tested and that there aren't vulnerabilities that they are exposing, even though you're responsible for your areas specifically. We also have blueprints. So if we go over to the blueprints page, also under servicetrust.microsoft.com, and here are security and compliance blueprints for Azure themselves. So if we go down, you can see here are some healthcare blueprints, HIPAA, high trust as an example, some government blueprints around FedRAMP. We've got PCI, DSS blueprints there. These are all there to help you. And in fact, if I just go over to one here, I've got the PCI DSS customer responsibility matrix. And this lists all the PCI DSS requirements that you're expected to account for. And if you scroll to the right, you can see it lists different ownership levels. So So is the customer responsible for this? Is it a shared responsibility? And in case yeah, 1.1.4, which is a PCI requirement, establish and implement firewall and other router configuration standards that include the following: requirements for a firewall at each internet connection and between any DMZ zones and the internal network. And I actually have an example of that later on around networking design examples and for you to look at. But if we look just at the requirement for the moment, we can see it's a shared responsibility. So Microsoft Azure employs boundary protection devices such as gateways, network ACLs, and application firewalls to control communications at external and internal boundaries at the platform level. However, the customer then configures these to their specification and requirements. Microsoft Azure filters communication when coming into the platform. So what does that mean? Well, Microsoft essentially is giving you the tools to say, hey, I want to put a network security group between these two zones. Does that then meet the requirement? Do I need to put a specific type of firewall, maybe beyond this one, like a Palo Alto? Microsoft also allows network virtual appliances to be put in place, and you can do user-defined routes to redirect traffic through those appliances as well. It says that application firewalls too. Well, a good example is you can put an application gateway with a web application firewall in front of your application as well, and that would also help you meet the requirement. So it's very important. Take a look at ones. Perhaps you're in one of these particular sectors. Take a look at the blueprint that applies to your sector, because it will give you a lot of data, across IaaS, across PaaS, and will tell you, anything that where Microsoft is already covering it and where you need to specifically go and tackle that control. With that, this concludes this area on security and compliance. And again, keep this in mind as you're learning about the different technologies. Know the ways to secure and harden your workloads as you go through. As we follow on from compliance and security, it's time to look a little bit more detail at service level agreements, also known as SLAs. Well, what is an SLA? Well, a service level agreement is an agreement with the business and application teams on the expected performance and availability of a specific service. So there's some general SLA practices that you can use to take effect. Well, for one, define SLAs for each of those workloads. If you remember in the identifying requirements piece, we talked about decomposing the workloads. Well, let's agree with the business and the app teams what are the SLAs for each of those workloads. There may be dependency mapping between workloads, so make sure to include internal and external dependencies as well. So these particular workloads may rely on an external service or an internal service in your organization, perhaps Active Directory, really good one. What is the dependency there? So make sure to document that and understand what that dependency is. In addition, identify single points of failure. For example, a workload might require 99.99% availability, but depends on a service that is only available 99.9% of the time. There's no way for you to guarantee, those SLAs. In addition, there's some key terms that you really, really need to understand, and you'll probably get questions on these on the exam. Particular, mean time to recovery. This is MTTR, average time to recover the service from an outage. So there's an outage. What's the average time it's taken the IT teams to get that service back online? Mean time between failures. So you have outages, and everybody has outages in their organization, but what is the average time between failures that's occurring, in that particular application? And that may force you to kind of redesign, rethink the design, rethink the availability strategy if you're getting, too many outages, on that particular application that the business can't sustain. In addition, you have your recovery point objective. So think about this: in the event of an outage and the application needs to be recovered, this is the interval of time in which data could be lost during a recovery. So for example, if we have a 5-minute RPO, it means up to 5 minutes of data could be lost. So perhaps when that backup kicked off, every 5 minutes the backup kicks off, but there's that time window between backups where there was no backup taken of the data, and so we've lost that data because we had to recover to the point of the previous backup. At the same time, we also have recovery time objectives. So this is the time requirement for recovery to be completed in before there is business impact. So again, this is our objective. If we say, hey, we have to recover this within 30 minutes, it means that's how long it should take to recover the service. If our recovery point objective is 5 minutes, again, that's the amount of data loss. Even though it takes 30 minutes to recover, we still might have lost 5 minutes of data because of the difference between the recovery point and the recovery time objective. Now, you may do better than that, but that's the objective that you're agreeing to with the business, and then you go ahead and you design and architect your particular services around those objectives. If we move now onto some SLA examples, let me tab over to my browser, and you'll note that Microsoft does provide legal service level agreements for all of their services. And if you look here for virtual machines as an example, you can scroll down. They provide details around all the SLAs, availability sets, availability zones, so you know what they're referring to from a legal point of view. And then here you go, you'll see your monthly uptime percentage and any service credit Microsoft is expected to give you in the event that there was an outage caused by them to your particular service. And those are all here and calculated, by VMs in an availability set, by VMs in availability zone, zones. If we scroll further down, single instance virtual machines, you can see that the the monthly uptime percentage just goes down because you're not planning on as much availability. If we scroll back up as well, we can go here to legal service level agreements, and you can see you can get them for all the different services that Microsoft provides. That's essentially their SLAs to you, their service level agreement from Microsoft to you for uptime and connectivity to those particular services. Before we end off on SLAs, it is important to understand composite SLAs as well. And that is, again, if you have like a SQL server with an SLA of 99.95%, and we combine that with a web app, but it's only got an SLA of 99.5%, then we ultimately have an SLA, in this case, of 99.94%. So it's going to be important to look at for any questions in the exam where they try to catch you out around SLAs and say, look in those use cases, those case studies for SLA requirements, and then look at the service that's being offered, and then you'll be able to kind of make that determination. It's usually that there's a single point of failure that doesn't meet your SLA, and then that's the critical component that's not going to meet your business objectives. And with that concludes this lecture on SLAs. Let's begin our journey down domain services now by looking at the three major options you have available when you're trying to deal with authentication in Active Directory. To begin with, we have the new service that Microsoft released with Azure and Office 365, which is Azure AD, also known as AAD or Azure Active Directory. This is the primary mechanism now and should be your first choice generally when trying to develop any new services and use their authentication mechanism. If Azure AD is supported, that is the way of the future. Then we still have Active Directory domain services. This is where you might install a Windows Server 2016 or Windows Server 2012. You might already have one running on premises, and you do a DC promo on that server, and it sets up your directory service. So if you're in an enterprise, you probably used to log in on your laptop and you authenticate. You're authenticating against Active Directory when you do this. Then we've got Azure Active Directory Domain Services, AADDS. Now this is a little bit different. This is where we actually have a managed version of Active Directory Domain Services. And we'll go into all three of these in a little bit more detail, but it's very important to be clear about which one you're talking about whenever you're dealing with Active Directory services in Azure. So let's take a look at Azure Active Directory in a little bit more detail. Again, that's AAD and has the icon depicted on the right-hand side. This is the modern AD service built directly for the cloud. It's often the same as your O365 directory. So if you have O365 already, you probably already have Azure AD and a tenant there. That's probably what you're going to use in your enterprise. You don't have to necessarily create a new directory service. It can sync with the on-premises directory service as well. It's very important, as you'll see when we cover AD Connect Sync shortly. Then we've got Active Directory Domain Services. So again, this is a Windows server with Active Directory Domain Services role installed on it. This is legacy Active Directory since Windows 2000. It's your traditional Kerberos and LDAP functionality that you might need, and it's deployed on Windows OSs, usually on virtual machines. So, it can be still physical in some environments today, but for the most part, most people deploy it on a virtual machine. Then we go into Azure Active Directory Domain Services, AADDS, and this is a managed version of the predecessor we just looked at. So Active Directory Domain Services, if we want that fully managed for us, Microsoft will build that domain controller and maintain it. That's what Azure Active Directory Domain Services are. It allows you to consume domain services then without the need to patch and maintain domain controllers. So that's the single best benefit of this, is maintaining a whole directory services infrastructure can be quite a bit of work. Yeah, that's taken care of for you. The one thing to note, this does allow then domain join, group policy, LDAP, Kerberos, NTLM, all of that is supported. Again, you don't have to manage it. So this is especially good for people that aren't familiar with Active Directory Domain Services. They can simply go in and set up AADDS and get that functionality provided to them as a PaaS service in Azure. To begin our journey down identity, let's take a quick look at Azure AD as a whole. And you might have seen this image before, which you can find at the link below, where Microsoft has a pretty good write-up on Azure AD fundamentals. But to begin with, Azure AD is really becoming the center of the identity world. You can kind of see it there in the middle of the picture. On the left-hand side, we have on-premises, because people traditionally had Windows Server Active Directory, sometimes known as Active Directory Domain Services, on-premises, other directories and things that they may have historically used. A lot of those directories are on-premises, and now in the public cloud, SaaS-based world, we've got all these other solutions running out there, whether it's ServiceNow, Salesforce, etc. And, identity sprawl was just becoming a big problem. People had identities in their business and then had that same identity in another business. Take an example, when you onboard somebody from a customer and you create a new user for them, well, what if you could just trust the identity that they've already got and the authentication mechanisms that they're already using? And so Azure AD ultimately was a solution to that. How do we sync up with our identity on premises, as well as, enable collaboration from a consumer and a business perspective with identities, with other businesses that we deal with and consumers that we deal with. And at the heart of it also is three things: simple connection, self-service, and single sign-on. In fact, if we look at the Azure AD features in a little bit more detail, aside from being that enterprise identity solution, that single identity to keep, users and groups and everything all in sync across your enterprise, that's point number one. Adding single sign-on provides the ability to have single sign-on to apps and services. We don't have to go sign on again and again every time we want to access something. If there's applications we access, we've been given permissions to access them. We've already signed in when we logged in with our laptop, and maybe we use some kind of Face ID and other authentication on top of just a password. That's kind of there for you. And then we've got multi-factor authentication, as I was kind of just alluding to there. It's one thing to have a password. That's something I know. What about something that I have? Maybe that's a cell phone where I get the text message and I can key in that code. Maybe it's some biometrics, things like that. That just enhances sigurity. So when we think of single sign-on and multi-factor, they're both great things because I've got multiple ways to authenticate. And then once I'm authenticated, I'm signed on, and now I can access all my apps and infrastructure services that I need. And finally, just that self-service empowerment to the users. Nothing more annoying than getting password reset calls day in, day out. We can empower users to do self-service password reset, but also empower them to, access the apps and the services they need. They can go to like a My Apps portal and request what they need. And so all of this comes together and is ultimately why Azure AD is so important, and particularly as it relates to Azure. You're using Azure AD potentially for Office 365 and other things already. When it comes to Azure, now we're able to use that same identity solution and give it permissions in the Azure world. And so you'll see in the upcoming demo, we'll create a new Azure AD tenant and then go from there, show you how to create users, groups, etc. Before we end off this lecture series, we do need to understand the different editions that Azure Active Directory pricing comes in, and you can use this link on the top of the screen that you can see we're already in, and it will also be noted in the accompanying study guide as well. But it comes in 4 editions: free, basic, premium P1, and premium P2 that you can choose between. Now, the big differences between them that you need to be aware of: first of all, the free version has a 500,000 object limit. There's no object limit in the basic, premium P1 and P2 versions. If we scroll further down, under single sign-on, you can note that the free version only allows 10 apps, as does the basic one, 10 apps per user. And the P1, there's no limit, and the P2, there's no limit. So as soon as you get into the premium ones, single sign-on can go more than 10 apps is the way to kind of think about that. If we scroll further down again, you'll see that the free version does not give any of the group-based access management provisioning, self-service password reset, company branding, all of that. None of that's available in the free version. And now let's scroll down. You'll see the section called premium features. And you've got things like advanced group features, self-service reset, change, unlock with on-premises write-back. That's that password write-back we talked about in the tutorials. Device objects we talked about in the tutorials. Multi-factor authentication. See, all these features we were going through are mostly premium features. If we scroll further down, and definitely become aware of this list, but I want you to be aware of what's different in P2. And so we have things like identity protection. So this is where Azure is actually using threat intelligence to help protect your identity. Privileged identity management is the big one. And this allows us to give perhaps roles that we want people to impersonate when they want to elevate their credentials. So for example, perhaps we've got an administrator role in Azure, but we don't want to just give that out to everybody as standard. We give them a normal user role that they can't do too much with. And when they have a task that needs a role that gives more permissions, as you probably saw in the RBAC section of the course, well, privileged identity management allows that person to say, okay, I want to be this higher level role, do my work, and then when I'm done, it sets me back to my standard role. And so that's a key one there. In fact, those two are in particular are key: identity protection and privileged identity management, as well as if we need to integrate with third-party MFA partners as well, would be another good one to remember for the exam. In the exam, you're going to get a lot of story questions, and they'll generally be around these particular limits. So I'd say look at the object count in particular, and then know the differences between premium and the standard versions, and then know the difference between premium P2 and premium P1. As you saw from the previous module, there are a lot of directory services to think about, and often we already have something on premises. We probably have that on-premises Active Directory controller running on Windows Server 2012 or 2016, and we don't really want to create a whole new source of truth when we move in towards Azure Active Directory. Perhaps we already have started some of this when we do No365, but if we're starting out fresh, we need to make sure they remain in sync, and that's where Azure AD Connect really comes in. And so Azure AD Connect has a number of components. First of all, it has synchronization services. This component is what's responsible for creating the users, groups, and other objects in Azure Active Directory. It's also responsible for making sure identity information for your on-premises users and groups is completely matched in the cloud. What we don't want is a complete mismatch there, because then everything gets out of sync and gets very, very complicated. It also has an option for Active Directory federation services. This is optional. And federation really allows us to configure a hybrid environment using an on-premises ADFS infrastructure. And this can be used by organizations to address more complex type deployments, such as domain join SSO, or perhaps we have third-party MFA solutions. MFA is multi-factor authentication that you'll hear about soon. Perhaps with smart card solutions, things like that we need to integrate with, or we might need to use Active Directory federation services. And then finally, we have health monitoring. This is called Azure AD Connect Health, which you'll see in the third module in this section of the course. And this provides robust monitoring and provides a central location in Azure for you to view all your health activity and making sure that your domains are all in sync and there's no issues. It helps now to take a look at some of those AD Connect sync features in particular. And first of all, we have the concept of filtering. And this is used when you want to limit which objects are synchronized to Azure Active Directory. By default, all users, contacts, groups, and Windows 10 computers only are synchronized. And you can change this filtering based on domains, organizational units, or other attributes if you want to. We then have the concept of password hash synchronization. And this synchronizes the password hash in your on-premises Active Directory up to Azure AD. So the end user can use the same password on-premises and in the cloud, but they only have to manage it in one location. Since it uses your on-premises Active Directory as the authority, you can also use your own password policy that you decide to implement in your on-premises Active Directory. And this comes up a lot when clients are sometimes using password policies that are in, say, Active Directory domain services from Azure. That's the managed Azure AD domain services, to be specific. It may not give you the same password policy features. Whereas when you use an AD Connect sync, if you've got a password policy on premises, that will carry over to Azure AD. We then have the concept of password writeback, which will allow your users to change and reset their passwords in the cloud, and this will write back to on-premises. We have the concept of device writeback, which will allow registered device in Azure AD to be written back to your on-premises Active Directory, so it can be used for conditional access. We have prevent accidental deletes, which is turned on by default, and this protects your cloud directory from numerous deletes at the same time. So by default allows 500 deletes per run, and you can change the setting depending on your organization size. And finally, great feature, obviously, automatic upgrade, enabled by default for all the express setting installations, and this ensures your Azure AD Connect infrastructure is always up to date with the latest release. You don't have to worry about going ahead and updating any of that. Now, before we wrap up, make sure you understand the different password sync options, and there are three major ones. So we have password sync, and this is where we're ensuring that user passwords are the same in both directories, Active Directory domain services and Azure AD. An alternative is we have pass-through authentication. This is where we authenticate, and instead of Azure AD authenticate, it actually passes that request onto the ADDS server, gets the approval, sends it back to the user that way. So essentially a single source being ADDS. And finally, we have ADFS, which is using Active Directory federation services to fully federate across ADDS and Azure AD, along with other services. So perhaps you might have ServiceNow as an example, as a SaaS service a lot of people use for ticketing, things like that. Perhaps that's using ADFS and it's federated with your Active Directory domain service. So just make sure you understand these three. And with that, this concludes this part of the module. Now that we have a good understanding of the Active Directory services and how AD Connect works, let's take a minute now to just look at the design decisions associated with authentication. And let's have a very quick review of the cloud authentication options first of all. Well, you have cloud only, which means if you exist completely in Azure and perhaps you don't have any on-premises infrastructure to worry about, you could completely start with Azure AD. But most of your questions are going to focus more around what do you do in a hybrid identity scenario where you have on-premises as well. And for on-premises, you have a couple of options in the cloud authentication mechanism. You have the password hash sync plus seamless SSO, or pass-through authentication plus seamless SSO. So password hash sync, so this is the simplest way to enable authentication for your on-premises directory objects in Azure AD, because the users can use the same username and password that they use on premises without having to deploy any additional infrastructure. Some premium features of Azure AD, like identity protection, do actually require the password hash sync no matter which authentication method you use. So even if you do use pass-through authentication, but you want to turn on things like identity protection, you do need to have password hash sync. Then we have pass-through authentication. So this is a simple password validation for Azure AD authentications, but it uses a software agent that runs on premises. And so at sign-in, your authentication is passed through to that agent, which in turn, validates, with your domain controller. So the validation doesn't happen in the cloud here. It actually happens, on premises. In addition, you also have your federated authentication option. So when you choose, this method, Azure AD hands off the entire authentication process to a trusted, separate authentication system, such as on-premises AD Federation services, and they will validate the user's password. And this can provide, a lot of additional advanced authentication requirements, smart cards, things like that are examples there. And it could be, again, ADFS or third-party providers. But let's take a look at hybrid identity with password hash sync in a little bit more detail, first of all. Well, essentially what you can see here is that, a user's coming in and wants application access, maybe to a SaaS application, maybe to one of the Azure services, where RBAC controls are applied. And so they basically need to authenticate with Azure AD. So the user goes ahead, says, hey, I want to sign in. And that authentication happens, right away, in the cloud itself. So the user can sign in and authenticate right there. The way that happens, though, is that periodically, every 2 minutes, the Azure AD Connect agent is doing a directory query with Active Directory, and it syncs up those password hashes for the identity up to Azure AD, and that's how the authentication can happen completely in the cloud. Now, if we look at this in a little bit more detail, we have some considerations here. So the effort, this is the least effort required out of the two options between password hash and pass-through authentication. It's part of the AD Connect sync process, as I mentioned, that runs every 2 minutes. So very easy to set up. You just have to install AD Connect and you're basically good to go. From a user experience, you can deploy seamless SSO, eliminating any unnecessary prompts after the user signs in, so they can just sign in once and then they're authenticated with all of the Azure AD services that are associated with that account. And then from a business continuity aspect, this is great too, because this is highly scalable as the cloud service itself scales with Microsoft data center. So Azure AD is highly available by design. You can rely on Microsoft's SLAs there. You can, if you want to, though, deploy an additional AD Connect server in staging mode in a standby configuration. So in the event something goes wrong with that AD Connect server, you could quickly get another one up, but not critical. You're still going to be online while you get that machine up and running. From a consideration perspective, though, the only thing is there's no immediate enforcement, in on-premises account state changes. So you can consider, if you're doing a bulk set of updates on premises and maybe you're disabling a whole set of users, maybe just do an immediate sync after that to make sure everything gets synced up successfully. So, Azure AD is aware of that. Then we move on to pass-through authentication. So it works a little bit differently. The user still goes in, and signs in from their perspective. It feels the same, but what actually happens, though, is it passes the authentication through to these authentication agents that run on premises and have to be connected to your Azure, so your Active Directory domain controller itself. So they need, no boundaries with their network access. They need to be able to connect to AD on premises whenever they need to. The identity is still synced, so Azure AD Connect is doing that identity sync and does the directory queries to do that. But when we actually do the authentication itself, that is passed through. And naturally, there's some considerations with that as well. Now, naturally, there are some considerations here from an effort perspective. You do need one or more agents installed on existing servers, and it's recommended that you have 3 to make sure from a business continuity perspective you're okay, but there is an effort to installing and maintaining those. You must have access to on-premises AD controllers, and those agent servers need outbound internet access. So make sure that you consider the security implications of pass-through authentication on those agent servers that need to run, and you don't just put them out in a DMZ or something like that. In addition, from a user experience, same as the other authentication, deploy seamless SSO, and it's going to feel great for the users. For business continuity, just mentioned, you recommend to deploy those 2 extra pass-through agents for redundancy. Now you can also deploy password hash sync as a backup method. So even if you want to mainly focus on doing pass-through authentication, maybe you've got some requirements on that, you want to enforce some policies or things perhaps on premises immediately and, have that take effect as soon as they sign in. That's one of the considerations, because pass-through authentication enforces on-premises account policy at the time of sign-in, but you could deploy password hash sync as a backup method as well. And then last but not least, we have that Azure AD hybrid identity with federated authentication. So again, the user is still going to go into AD, but they're going to get redirected. And when they get redirected, they hit a federation proxy, which runs typically in a perimeter. So if you're using ADFS as your federation service, you'll have federation proxies that run in the perimeter, and then on premises, you have your ADFS servers. ADFS is what's basically checking in with AD and saying, hey, let me do the authentication check here. It's basically checking those identities and passwords and making sure everything's good. But Azure AD Connect, same thing still going to have it running. It'll do a directory query to AD to make sure those identities are synced up, so everything knows about each other. But this is, again, you might go over to a third party to actually, do that sign in and authentication, and, you can customize pages and sign in pages and things like that as well. With that, how do we begin choosing between all of these, different authentication methods? And Microsoft kindly provides this diagram, and we'll start start from the top and go through a few scenarios here. So first of all, do you want Azure AD to handle sign-in completely in the cloud? So first of all, if the answer is no to that, then you've got to decide is, do I want to integrate with an existing federation provider? If I do, then I'm basically going to be down the federation, methodologies on the right-hand side. If the answer to, do I want Azure AD to handle sign-in completely in the cloud is yes, then I've got to decide, am I able to get all the security policies I need? So do I want to enforce user level Active Directory security policies during sign-in? Well, those policies come from on-premises. So as soon as I choose that option, I go to the right, and now I come down the tree that's going to hit pass-through authentication plus seamless SSO, or password authentication plus seamless SSO with password hashing. Now, why are both of those there? You might ask, well, if you want to use identity protection, one of the services in the P2 license, which is checking for leaked credentials out in the dark web, you do need that because Microsoft needs to be able to look at those credentials in order to basically scan for them. So that's essentially what that particular option is there. Now on the left hand side again, if we go back, do you want to enforce user level Active Directory security policies? If the answer is no, then I have to decide is, do I have a sign-in requirement not natively supported by Azure AD? Well, as long as the answer is no, I really should go password hash sync plus seamless SSO. Simplest method, easiest one to install. I install my AD Connect, I choose password hash sync, and that's the route I go. If I do have some sign-in requirement not natively supported, then I do have to sort of look at the federation options. And then again, the question, whenever I want to determine if I need to use password hash sync even with federation, you can see again, do you want sign-in, disaster recovery, or leaked credential reports? And it says leaked credential reports where Microsoft has to scan for you, and using that identity protection service, they can let you know if your users have been compromised. And that just requires that password hash sync. So that's the thing to look for all the time. If you want identity protection, you're going to need password hash sync. If you have certain customizable requirements that are not natively supported, you're probably going to be looking at federation. If you want to enforce on-premises policies that you have in your Active Directory that aren't in Azure AD, you'll probably just go through pass-through authentication, and then you can use those on-premises policies. And ideally, if you can just keep it simple, just go with password hash sync plus seamless SSO. But this is a big decision. It's really, really important because it's a decision that you will make that is very hard to change later on. It affects the way the users log in and all the services they have available. So it's important to try to really think through this, and I can guarantee you will get questions around choosing these methods on the exam itself. Managing access is naturally one of the most important things in Azure. Given that there's so much infrastructure that we're putting out in the public cloud, we need to find a way to secure it and lock it down so only the right people can access it and have the appropriate rights. And the way we do that is using RBAC, also known as role-based access control. And in Azure, the way it works is we have Azure Active Directory. So we create our users, our apps, our groups. You saw in the previous module around service principals, we can give an app a permission set as well if we want to. And then we scope it. So we assign the apps, the users, the groups to specific objects in Azure with a specific role. And the way that works as well is there's a number of built-in roles in Azure. So for example, we have owner. This one has full access to all resources, and this also includes the right to delegate access to others. Then we have the contributor role, and similar to owner, the only difference being that it can't grant access to other people. So it has all the permissions in Azure. If you gave the contributor right to somebody in the subscription, they could still do everything in Azure, but they couldn't give new access out. Then we have the reader role, and this is often used by monitoring tools and other third-party tools like that as well, where they can view existing resources but cannot perform any actions. Perhaps you've got a managed service provider that just needs read access to your environment. That's where you might use the reader role for that. And then there's a whole host of other roles, and you can click the link here. In fact, we've got a summary on this page, and you can see there's a whole bunch of roles for things like automation operator, backup reader, etc. And so Microsoft has created this subset of roles to kind of match a lot of the things that you might do in your department. Virtual machine operators is a good example. You might just want to have a VM admin from an operations side, have a role on a specific resource group so they can manage those VMs. That's a great example there. But if you select this link, and you can see if you scroll down, we have all those roles listed out. And if you select one of them, we'll just select contributor, and it will show you all the various actions and not actions available for that role, which we will get into a little bit later on. But know that this page exists for you. The next thing is, how do we define how the roles work? And you may have seen briefly on that page, there's a concept of actions. So the roles include various actions that people can perform. Essentially, they define what type of operation you can perform on a resource type and what actions you cannot perform. So there's not actions and actions you're actually granted. Write enables you to perform put, post, patch, and delete operations on a resource. So think of it from a REST-based stance. You can make REST requests against the resource providers in Azure. If we've got write access, we can do all of these kind of updates and posts and etc. And read enables us to perform just get operations. So we can do any get operation against any of those resource providers. You can use PowerShell to get the latest roles, so they're certainly available on the Microsoft website, but I encourage you to know this command, which is get Azure RM role definition. You can simply type that in PowerShell against your subscription, and it will tell you all of the roles available to you there. Now, the resulting user rights is always a combination of the user plus the role. So just think of it in this context. We've got our user, we've got our role with its various actions, and the resulting rights obviously overlap somewhere in the middle there, depending on what you scoped for that particular user. Now, if none of the roles work for you in Azure from the built-in list, you can go ahead and create custom roles. And essentially, these are just roles with your own actions and not actions available to you. Each tenant can have up to 2,000 roles associated with it. Like I said, it uses the same actions and not actions, and you've still got assignable scopes that you need to define in the custom role. So as opposed to when we you'll see in the demonstration, assign a role to a specific area, when you define the custom role, which is a JSON template, you do give it an assignable scope as well. So this could be subscriptions, individual resources, or resource groups that you'll allow this particular custom role to be assigned to. And if we look at one of these in Visual Studio Code, you can kind of see the layouts that we have here. So on the top, we've got our name of our role. So I'm going to call this one, for example, Skylines VM Operators. We give it a description. So in this case, this one can monitor and restart virtual machines. And if you look through the actions, all of them come from the resource provider. So things like Microsoft.storage/star. So that's everything in Microsoft Storage. We've got read access, everything in network, read access, everything in compute, read access. And in addition, we're given the options to start and restart virtual machines in the compute section as well. Then you've got some others there like authorization, subscription read access, insights, alert rules, and diagnostics and support. And this is because, it's not just the virtual machine. We decided we wanted the user to be able to monitor as well, so they need these additional pieces. There's no not actions in this example, and you can see that concept there of the assignable scope. In this case, it's just a particular subscription that this role is allowed to be assigned to. So hopefully that gives you an overview of the roles in Azure, and I encourage you to kind of just put this in practice and do this in the upcoming demo. In this demonstration, we're now going to go about implementing role-based access in our Azure environment. So let's head over to the Azure portal. And in the portal, the first thing we need to do is go over to Azure Active Directory on the left-hand side, and let's just look at the users that we have. If we select users, and you can see I've got 2 users there plus a built-in user. So Nick Collier, Brett Bosick, these are 2 member users in Azure Active Directory. If we go back, we can also see groups. And if we want to, we can create a new group and include various users in that group. So this way, if we want to apply permissions to lots of people, we don't need to go and do it on an individual basis. We can create a group type. So we'll choose a security group, give this a group name of Skylines Readers. So this is readers only, and choose the membership type as assigned. And in this case, I'm just going to select Brett as the user I'm going to assign to this group. So that's done. Go ahead and create that group. Takes a few seconds and that's completed. And now we want to go about assigning permissions to that user or group to resources. And we can do this at a couple of levels. So first of all, we'll go to subscription by typing subscription at the top and select, in this case, my pay-as-you-go subscription that we're using for these demos. And you'll see this tab appear on almost every service in Azure, which is IAM, Access Controls, Identity and Access Management. And if we go in there, you can see we already have our users there and we're owners on the subscription already. So we're not going to fully create the read rights because, like I said, we're already owners. But if we select Add, and we can choose the role. So in this case, if I wanted to choose Reader, I could simply select that. Or if I wanted to choose one of the other built-in roles that we talked about in tutorial, they are all here ready for you to use, but we're going to choose Reader on this occasion. And then I can assign access to an AD user group or application, but no, I can also assign access to a virtual machine if I want to. And then I simply choose the people I want to assign access to. So I could choose them by name, and you can also see that the group appears there. So I could simply select Skyline Readers and assign read access to the subscription to everybody in that group. And that's basically it from a scoping point of view. You can go and do this if I discard from the subscription level. And let's say I want to go and do this at the resource group. I can simply select a resource group, pick SL Identity, and again, you've got that tab, Access Control. Go in and click Add on the top. And again, same screen appears. I can select my role, Reader if that's what I wanted, and choose who I want to assign it to or the group of people that I want to assign it to. And that's pretty much all there is to it. Like I said in the tutorials, if you want to, you can create a custom role, and then if we cancel out our permissions, we would see those roles appear in our roles list. And then the same thing, we would just assign the custom role much the same way as we do a built-in role. It will just show up in the list now that we've created the custom role. And with that, this concludes this demonstration on role-based access. Let's now look at one of the security features that we highly recommend people implement in their organization, and it's known as Privileged Identity Management, also known as PIM for short. And the way it works is as follows. Essentially, you have your users in your environment and they access various things. They could be accessing Azure AD for user administration. They could be accessing Azure resources in your subscription. There's a whole bunch of things, SaaS apps, Office 365, etc., that are all tied to that identity. Well, the key thing with a privileged identity is this is a user that essentially has some admin roles. They're a privileged user. They have a lot of access and essentially create a risk for the organization. And so privileged identity management is a way that we can manage these privileged users, put some control around them, put some visibility around them so that we know what's going on with those users. Now, the key features of Azure PIM are as follows. It gives us visibility into users with privileged access. So the first time you turn it on, you can then do a discovery to see, well, who in my organization has a lot of access? Who should I be concerned about? This can be for Azure resources or Azure AD. So we always make that distinction. Azure resources are things in your subscription where a lot of RBAC roles are applied, like subscription owner. Azure AD is things like our global admin, for example, that has a lot of rights to administer our directory service. We can enable things like on-demand administrative access. We can view administrator history, so that includes not just what they accessed, but the rights they gave out and things like that as well. We can set up alerts, and finally, we can also do something which is really cool, which is require approvals via workflow. So when somebody requests additional access, it can go to a workflow. Perhaps a certain person in security has to approve that access, review it, check the reason they submitted, and then things can move forward. Now, the PIM process is as follows. Essentially, again, you've got your user that has some level of access by default, but we don't give them that full subscription owner or global admin rights initially out of the gate. They have to go through an activation process, and we can decide what's required as part of that activation. For example, they could be required to authenticate via multi-factor authentication. So a token comes to the phone that they will authorize, or perhaps they'll get a text message, etc. They could also go through an approval workflow. And this means, again, we could send that, requirement onto a manager or somebody in security for approval to say, yep, okay, I'm going to authorize this. And we can also put time restrictions on this. So this might just be, hey, I need access for a couple hours to do some work in Azure AD as a global admin. And then once I've completed that, that access can be removed. But once the activation process is completed, essentially I have my activated user ready to do their work, either, in Azure with RBAC roles or Azure AD, as potentially a global admin or some other role that they might need, in Azure AD. Now, there are some PIM requirements you need to be aware of. Well, first of all, you do need an Azure AD P2 license. Now, if you are following this through and trying to do this yourself and you've got a trial account, you may have some different mileage depending on, any restrictions on your account. But let's just say you have a normal trial account. You will be able to select to start a free trial in the portal itself. And then it will prompt you for these two options, enterprise mobility and security. That includes the P2 license, as well as additional features that Microsoft will let you try out. Or you can just do a free trial for the Azure AD Premium P2. Either way is fine. You can click the more information pieces there, and that will, give you more information on those different licensing models. But essentially, this is licensing that is related to Azure Active Directory that you need to be concerned with. Now, you might be wondering, well, who needs a license? Because you don't have to assign a P2 license to every user, but essentially anyone that's going to be assigned the privileged role admin that you'll hear more about, anyone that's going to be signed as an eligible admin, so if they want to elevate into a role, anyone that's basically going to use just-in-time access or direct time-based assignment, or users that need to approve and reject PIM requests. So even if a user maybe doesn't need to elevate permissions, but they're on the approval workflow, then they will require the P2 license. So just something to keep in mind there. Now, when we look at the roles, there's two new roles essentially that you need to be aware of. You have a privileged role administrator. That person can manage role assignments in Azure AD and everything to do with privileged identity management. And then we have the security administrator as well, and they can read security information, reports, configuration, etc. Now, it's key also to remember here, when you start this off, you have to be a global admin in order to set up PIM, which you'll see in the subsequent demonstration. Now, that global admin will become the security admin and will inherit the privileged role admin role as well. Now, this account that enables PIM is the only account that can manage PIM unless you give it out to other global administrators. So it is really important, not to basically just create the PIM role and then forget about it in your organization. You want to make sure that you give this out to somebody else so somebody else can manage PIM as well. And only privileged role administrators can manage Azure AD directory role assignment of users. So it's a very important role. We got a global admin today, and now we're sort of adding this new role around PIM. We have to make sure we manage the people that can manage privileged role administration as well. Now, you've heard me mention a few times this concept of assigned roles, and we have directory roles or resource roles. Well, why do we draw this distinction? Well, the directory roles are Azure Active Directory roles. These could be your global administrator. These are roles pertaining to Azure AD, and they can be eligible or permanent roles. So an eligible role, again, is a role where somebody can elevate into that permission, or a permanent role is, you sign the role and you make it permanent or potentially even time-based as well. Now, the resource roles are Azure RBAC roles. These can be your built-in roles, such as subscription admin, virtual machine administrator, contributor roles, etc. They can also be custom roles that you've defined in Azure RBAC that you want to allow users to have, and then you can have users elevate into those particular roles as well. Very common one is obviously the subscription admin. A lot of times people turn on PIM, and the very first step is to see, well, who has access to subscription admin. Same with the directory role. How many global admins are out there? These are the roles that you really want to get your hands around very, very quickly. Now, on the Microsoft documentation for privileged identity management, they do have a recommended process that you follow when you're starting out with PIM. And that's essentially these 4 stages. Stage 1, 24 to 48 hours. You want to take care of the critical items that you need to do right away. These are things like that subscription admin, global admin, doing an audit of accounts, getting some visibility into what's going on in your environment. Take care of anything critical where you think, hey, I've got some major security holes here. Then we move on next 2 to 4 weeks, mitigate the most frequently used attack techniques, maybe starting to expand the number of users that you give privileged identity management to, start organizing groups of users that you think this applies to. Stage 3, 1 to 3 months, continue to build visibility and build full control of admin activity throughout your organization. And stage 4, 6 months and beyond, just continue building defenses to further harden your security platform. And this is just something, again, just to think about. A large enterprise, you might turn this on and find, okay, I've got lots and lots of subscription admins, lots and lots of global admins. I need to remediate those. I need to update all my processes around my enterprise to make sure that this is something that's built into security administration, user administration, help desk, etc. And so think about the process as more of a journey and something you will go through, to set up PIM and run it successfully in your enterprise. And with that, that concludes the lecture on privileged identity management, and I encourage you to try it out and check out the demonstrations. In this demonstration, we're now going to go about configuring Azure Privileged Identity Management, and we'll begin in the Azure portal. So in the Azure portal, I'm in my Azure Active Directory section. If you're not familiar where to get there, again, just click Azure Active Directory on the left, or if you didn't favorite it, just go ahead and click All Services and type Azure Active Directory. But you can see I've already got my trial enabled. I've got Azure AD Premium P2, and this is on my domain, azexamdemo.onmicrosoft.com. So I'm going to go ahead and look at my users first of all, and we can see in here that I've got Bill Adama, that's my test user I'm going to use later on, and then my account that I'm basically signing into this Azure AD with. Well, first of all, I do need to make sure that I've got a location in the details for my particular user. So if I edit my user and I scroll down, I should have a location option. So you see the usage location, and I have to go in here and make sure that I have set this to my location. Otherwise, it won't let me continue on with assigning the license. So I've got my P2 enabled on Azure AD, but I do need to assign the license to my account, and that's why I'm making sure that that usage location is listed there. If I go to licenses now, it will let me assign an Azure AD Premium license. You can see I don't have one assigned yet. I click Assign. I choose the product. I'll choose Azure AD Premium P2, click Select, and then go ahead and click Assign. Licenses have been assigned successfully. If you didn't have the location set, you would have got an error at that point. So if it does come up, that's why you're getting it. So now that license is assigned, I've decided, okay, I want to enable privileged identity management. Well, to do that, we click All Services and we type in privileged, and it'll already pop up, Azure AD Privileged Identity Management. You can favorite it now as well if you want to, as we'll be coming back to it, and click that, and this opens up the quick start for privileged identity management. And to get started, I have to click Consent to PIM on the left-hand side. It'll now do an assessment and tell me in order for me to do PIM, I do need to open up multi-factor authentication to verify my identity. So I'll go ahead and do that. And it'll prompt you for various things as part of the MFA setup, because you need to set that up on your account if you haven't already done that from previous work you did on MFA. So I'm going to go ahead and fill this in and then come back to you once it's all completed. Okay, and after I've completed MFA, you can see status checks completed, and I can now click consent to basically continue that on, and we just click the play consent button at the top here to consent to privileged identity management. Now again, make sure you are doing this in a trial account. If you're actually doing this in your enterprise, you need to definitely talk to the team that manages your environment. This is purely something you do want to be careful doing and know what you're getting into before you continue. And now we can see some things on the left-hand side like my roles, requests, application access, approvals, and review and access. And then I can manage my Azure AD roles. Remember in the lecture we talked about Azure AD roles and Azure resources. Those are the two different areas we can manage there. And then I've got my audit history and any support I need from Microsoft at the bottom as well. So let's say I want to do something around Azure AD roles. I can click Azure AD roles here, and I can basically see I can assign, I can activate, approve, and audit. But before I can do anything, you'll see on the left-hand side, sign up PIM for Azure AD roles. Now if I click this one, this now signs things up here. If I click play, click yes, and now I can manage Azure AD roles with privileged identity management. And you'll see it's discovering privileged role assignments such as global administrators in your tenant. So now that's completed. On the right, you can see eligible roles. Nothing there right now. If I click active roles, you can see I've got security administrator permanently assigned, global administrator permanently assigned, and the privileged role administrator permanently assigned to myself. Now, if I go back to Azure AD roles, I can see I can assign eligibility to different users. So I could say, let's look at the global administrator, see the members, and I can choose who I want to assign that to. So I can add a member to this as well at this point. So we'll choose our role for Bill. So Bill Adama, this is our test user. I can select Bill, click OK, and I've now added Bill to that role. So if I refresh, I can see Bill Adama, but you see the difference here. My role is permanent. Amy's role is permanent. We were already global admins, and I've got Bill Adama, who is now eligible for that particular role. And if I click the three dots on the right, this is where I can make it permanent if I want to, or remove that assignment. Same for the other one. I could go to Amy's role now, and I can change it from permanent, because she was already a global administrator, and make her eligible instead, or remove that. So you can see a lot of power now, because now we're at the point where I'm saying these are the users who are eligible for global admin, and you can see it at the top. These are global administrator members that I'm looking at right now. I can go back a level. I can look at all my Azure AD roles. Here they all are. Again, all their Azure AD roles are available to you, and you can decide, who can elevate into them or who gets permanent access to those roles. So again, the difference between eligible and permanent is what you need to understand there. Now, before we move on, there's a few other things just to be aware of as well. If we go back to the overview for Azure AD roles, you can see I've got this concept of my view again that we saw early on, my roles, my eligible roles. Again, I've got permanent roles, so I'm in the active roles category as permanently assigned security admin, global admin, privileged role administrator. But I've got an admin view as well, because I am the administrator of privileged identity management, and I can see additional information here around the roles and views and directory, activation history, etc. On the left-hand side, if I go down a bit more as well, I've also got this wizard, which is a really good place to start out, because first thing you can do is discover the privileged roles, convert members to eligible, and then review changes to your members in privileged roles. So if we do the first one, discover privileged roles, this will actually do a scan and say, okay, here's our global administrator, security admin, and privileged role administrator roles. And you can see there's 2 permanent assignments to global admin, 1 eligible. That's because Bill Adama is eligible. Nick and Amy are permanent right now. So I can click this global admin, and on the right hand side, it will show me, exactly who has that permanent, assignment and who is eligible. And then I can take some action on that. So I can click next on this one and convert those members to eligible if I want to. So I don't want them to have global administrator all the time. It's telling me straight away, hey, these are the people in your environment that have global admin. And let's say I want to take Amy, click next, and convert her to eligible. It'll ask me to review those changes. Go ahead and click OK. And that's the same process that we did manually, but the wizard makes it really easy to go through and do it in bulk, especially when you're just getting started as well. Another thing to be aware of are all the settings that you can apply to the different roles. So if I click the settings button on the left-hand side and choose the roles, so if I go in here, select roles, and then say choose global admin, let's just find it here, there we go, global administrator, you can see that I can tweak various things like maximum activation hours if I wanted to, send emails notifying admins of activation, incident tickets, multi-factor authentication. Some roles require that to always be enabled, so it'll be grayed out, and then require an approval. So approval is really interesting because I can click enable, scroll down, and then select an approver that needs to approve, who can basically activate or authorize that activation of the role. And then I simply select them from my Azure Active Directory as to who those people are. You can also use groups as well there. But that's basically it for right now for the setup. In the next module, we will look at how we go about assigning RBAC permissions as opposed to just Azure Active Directory roles that we've been looking at here. In this demonstration, we're now going to look at assigning resource roles with privileged identity management. So we'll continue on in the Azure portal. And in the portal, I'm back in Azure Privileged Identity Management. And on the left-hand side, I'm now going to select Azure Resources as the area I want to manage. So when we select that, the first thing you'll see is nothing below when it comes to resources. No resources are found yet because nothing is being managed by PIM. So what we have to do first of all is discover resources by clicking Discover Resources at the top. and then it'll show us our subscriptions in our account. So I can select this one. This is my Visual Studio Enterprise subscription, and I can go ahead and select Manage Resource. And this will basically put management of the resources, all the child objects in that subscription under PIM, and I have to confirm to do that as well. Again, make sure you're doing this in a trial or know what you're doing, or you're working with someone in your enterprise to basically do this. And now it says onboard resource succeeded. So if I go back to the main page and click refresh, it's already there actually, Visual Studio Enterprise, and you can see 102 roles and 4 members there right now. And I can go ahead and click this one. And just like in the Azure AD side, you'll see various options on the left-hand side. I've got my tasks, my roles, pending requests, approve requests, review access, and then manage. So again, I've got roles, members, alerts, access reviews, role settings, and I can do audits as well at the bottom here. Now, if I click roles, first of all, this is where we manage the various roles that we assign out. So again, if I click my contributor or owner role, you can see here they've got 2 active assignments in the owner and 1 in the contributor. We'll go ahead and select the owner role for right now. And I can actually add a member to this role. So if I click add member, I can select the role, which is owner. Now I select the member, and I can choose, we'll pick Bill Adama again here. So there's Bill Adama, our test user. I'll select him. And now I choose the assignment type. So you need to understand the difference between these. I've got the eligible type and the active type. So let's start with eligible. So eligible is when they elevate into that particular role. And then I can choose the allowed eligible duration. What is the maximum they're allowed to do that for? And that's where I choose my start and my end time for that particular assignment type. That's a little bit different when we select active assignment. If I choose active, you can see the maximum allowed assignment duration is 1 month. Now we can go ahead and change that in the settings. I'm not actually able to make this a permanent assignment, as you can see here, but that is something we can look at, and I can show you where you modify that. But we can choose your assignment starts and assignment ends. So I previously selected a longer date in here, and so that's saying, well, that violates our maximum allowed assignment, which is 1 month. But now if I go back to, if we look at January 21st here, that's going to work, and I can put, user needs access for contractor work on project XYZ. That's just your justification there, and that's where I basically am assigning a time-based assignment for Bill Adama to that particular role. But I'm not going to assign that yet. I'm going to close out of this for right now, and I'm going to go back to role settings, which you can see here. There's two ways to get to this. I can click role settings right here, or I can go back to that main screen and choose the settings for the role. And you can see here I can edit the settings for this role. So here's my owner role, and I can choose things like allow permanent eligible assignment. I can allow permanent active assignment. This is where I can choose what we're allowing in those options. If I choose not to allow permanent, I can also choose this active assignment, 1 year, where we say it kind of just automatically goes away, and requiring multi-factor authentication on active assignment as well if I want to. Same on activation. So these are all things I can tweak. I can add an approval, select this, then select my approvers. Plenty of options here in terms of the role. So just consider that. You've got settings for each role. If we go back to the roles themselves, I'm just going to jump back a few blades here. Again, here's all my roles, which I got to from the left-hand side. Click in roles here, and I can select them in here and give various access to members into these roles. Or I can go to role settings. That's the other place where I can get into the settings for my role. So again, it's going to come up with my roles here in a second. Click the owner role. And this is where, again, those same settings that you saw from the different pane, it's the exact same thing. Role settings and assignments are the key things to keep in mind. But if we go back, let's go ahead and give Bill an eligible assignment. So if we go back to not the role settings, but to the roles themselves, where I want to manage them, and I want to add a member to the owner role. And again, I can click add member right at the top here, or I can click the role first of all, and then add member from there, and it will simply put in the role for me automatically. You see it select a role, it says owner there. Now I click the member. Let's go ahead and choose Bill Adama, click select, and choose the membership settings. And I'm just going to say this is an eligible activation that we want to do. Yeah, so we'll click OK, click add, and now we know that Bill can amplify his rights to become an owner when he wants to. I can also look at the active roles. So if I click active roles here, I can see that Amy Roush is there. Subscription A, if I click this one here, is actually a permanent role, basically assigned to subscription admin. So this is a group-based assignment that we have here, and that's where my nCollier account is basically in there already, and that's a permanent assignment, currently that exists. I can also look at expired roles if I wanted to as well, and again, I can choose between eligible and active roles that have expired. So a lot of visibility into what's going on in the environment itself. Well, this now concludes our demonstration on PIM for RBAC roles, and in the next demonstration, we'll log in as Bill Adama and show you some of the ways he elevates his rights. this demonstration, we're now going to build upon what we did in the previous demos and activate a role using Bill Adama. So we'll switch over to the Azure portal. And you can see here that I'm actually logged in now as Bill Adama and logged in separately into his account, and everything is ready to go. Well, if we go over to Azure Active Directory first of all, and we look in here, we'll see that a lot of things are just kind of grayed out, for Bill. And that's because he's not a global admin. He's eligible to become a global admin, but right now is simply not one. So the way we elevate those rights is we go to All Services and we go over to Privileged Identity Management. And once we're in there, we can see My Roles on the left-hand side. And we can see eligible roles, Global Administrator is one under Azure AD roles. If we go to Azure Resource Roles, we should see that the owner role is eligible as well. And I can choose to activate either of these, and we'll start with the Azure AD role. So we'll click Azure AD roles, look at our Global Administrator, status not active, no pending requests, simply click the Activate button on the right-hand side, and you'll notice the first thing, we have to verify our identity before proceeding. And that's because multi-factor authentication is required for that global admin role. So we'll go ahead and set up MFA just like we did before, and I'll fast forward here as we do that. Okay, that verification is successful, and now I have the option to go ahead and click Activate, which I will do. Click Activate there. Choose my activation duration. Remember, the settings only allow a certain maximum time for activation, and that's something you can tweak back in the settings as part of being a privileged role administrator. But for right now, I'm going to say I'm going to activate for 1 hour. I could start this 1 hour a little bit later on if I wanted to. So I could start it in the future. Perhaps I'm going to do some work at 8 p.m. that night. I could say, okay, 8 o'clock, I want to start, and I want to make sure that access is ready for me. That's where I do that. So great feature there. But for right now, I'm just going to say, nope, I just want to activate it right now for 1 hour. I have work to do that requires global admin, and then simply go ahead and click Activate there. And it now is activating the role. So you can see it's processing the request and activating the role. It'll validate that it's successful, and then I'll get a activation complete once everything is completed. Okay, and all of that is completed. Now I do have to sign out and sign back in to start using my role. So I'll go ahead and click Sign Out. Sign back in as Bill Adama. And now if we go back over to Azure Active Directory, we can see everything is available to me now because I am now a global admin. And if I go ahead and select users on the left and select my name, Bill Adama, click Directory Role, we can see right now that role is Global Administrator. Okay, so that was for Azure Active Directory roles. Well, what about those Azure subscription type roles for resources running in Azure? Well, again, I click All Services, choose Privileged Identity Management, go to My Roles. In fact, if I look at my Azure AD role, you can see right now that it's showing this role as access until January 20th at 4:06 p.m. If I click Active Roles, you'll see that there as well. And I can also choose to deactivate manually when I'm done. If I go over to the Azure AD Resource role now, again, we'll see I'm eligible to become the owner for that subscription. So I will click Activate. Choose the start time again, the scope being that particular subscription. How long do I want it for? Again, this is controlled by the settings for that particular RBAC role. So let's say I just want it for a couple hours. I need to do Azure work that requires owner permissions. I click Activate. And slightly different process. Your request is queued for activation. And once it's completed, if I go back here and refresh under Active Roles, we can see that I'm now the owner of that subscription, and I can deactivate it when I need to as well. Now, if I log back out and log back in and choose subscriptions, I can now see that subscription. In fact, it just popped up to tell me the remaining credit, but I can now see it, tied to my account, and I can go ahead and build resources. I can build, virtual machines and other things now. In fact, we'll just show by doing a storage account very quickly. And you can see there that I'm actually able to do it now. If I didn't have permissions elevated, I would simply get one of the error messages saying that I don't even have a subscription in this account right now, because this is actually the only subscription he has rights to, so it wouldn't let me provision any resources at all. And with that, this basically concludes the demonstration and hopefully gives you a great overview of PIM, how to set it up at Azure AD roles, RBAC roles, and then activate it with the user as well. As we move into the various storage and database services available to us when we're building applications and utilizing public clouds such as Azure, we first need to understand the different data types available. And there are three primarily that we're going to go into, which are structured data, semi-structured data, and unstructured data. And just by reading them, it kind of makes sense to some degree, but let's dive into them in a little bit more detail. Well, first of all, we have structured data. So this adheres to a schema. All the data has the same field or properties. So for example, it's stored in a database table with rows and columns, things you're pretty familiar with like in SQL, and it relies on keys to indicate how one row in a table relates to data in another row of another table. You've probably been familiar with like primary keys, etc., that you use in SQL to kind of connect different data sets. And it's referred to as relational data as well, also known as relational database when you're thinking of, say, SQL. If we move on to semi-structured data, a little bit different here. Semi-structured data doesn't fit neatly into tables, rows, and columns. You basically are using things like tags or keys to organize and provide your own hierarchy for the data. And this is often referred to as NoSQL or non-relational data. If we move on to unstructured data, this is pretty much what it is. No designated structure whatsoever, no restrictions on the kinds of data it can hold. Good example, blob storage. It can hold PDFs, JPEG, JSON, videos, put whatever you want up there, Word docs, Excel, etc. It's just objects you're thrown into an object store at this point. And the big thing about this is enterprises are struggling to manage and tap into the insights from all of their unstructured data. I've worked with a lot of customers in the financial industry, I've worked with a lot of customers in the medical industry, and they just have a breadth of data there. And sometimes it's like a gold mine to them. If they can just tap into all this data they have, connect it all together, they can draw insights from that data and start to help them make good business decisions. So that's the big challenge. All of these different types of data. Now, what are the right services and storage types that you need to use when you're doing various applications? Let's now take a look at Azure SQL Services, also known as Structured Query Language. If you're not too familiar with SQL, it's been the primary database methodology for a while. This is our relational database methodology, and typically, your DB admins in any enterprise will understand, SQL as they will often call it. So we have Azure SQL to begin with. This is our relational database as a service. So instead of you having to build a virtual machine and then install SQL Server on top of that machine, on top of Windows, although there are Linux versions available now as well, this is provided to you as a service. It essentially uses the latest stable version of Microsoft SQL, and you can create new servers, or you can actually migrate existing databases from, say, IaaS SQL, SQL that you might have on premises running on physical servers. You can migrate that into Azure SQL using the Microsoft Data Migration Assistant. Now, there are some key features of Azure SQL Database you should be aware of. Well, one, predictable performance, and it's measured in database throughput units, also known as DTUs. That's how you often build, and also how the performance is measured for SQL. High compatibility, supports existing SQL client applications. The only thing I would say on that, there are sometimes incompatibilities, and you'll learn more about SQL managed instances, another version of SQL that Microsoft's made available. But for the most part, it is highly compatible with existing SQL workloads. You just might have to tweak a few things. Sometimes there's some schema edits and things like that people have to do, and simplified management. I think this is the big thing. Not much to manage. Managing SQL servers on premises has been a very challenging and often expensive task over the years, and this really simplifies the management of that. Now, there are three tiers available. We have basic, standard, and premium. So basic is for small databases with a single concurrent user, small DBs, 5 DTU in size, small scale apps, dev test. Standard is for medium-sized databases that must support multiple concurrent connections. So it's a good option for cloud applications with multiple operations, workgroup or web apps, and 10 to 100 DTU. Premium, these are large databases that support large number of concurrent connections, so lots of people connecting simultaneously, high transaction, large users. We're in the 100 to 800 DTU here, and this is really mission critical applications when you're in this tier. Now, we do have a new option in Azure, which is SQL Managed Instances. I say new because I didn't see them specifically called out on the exam, but Microsoft does say, not inclusive in their curriculum. But if we look at Azure SQL Managed Instances, just like Azure SQL, they are managed SQL servers, but a little bit different. These are basically trying to mimic SQL on premises or legacy SQL that you might just be running in a VM in the cloud. So they have higher compatibility with legacy workloads. So just be aware, people call this SQL MI for short. This might come up now and then, now that it's gone GA, and a lot of people are moving towards it. There's a big fan base here because, again, highly compatible, very easy to move into, works just like my SQL server that I'm already running my application in. Now, in addition, there are some other third-party databases in Azure, some managed options. So for MySQL and PostgreSQL, there are managed options. When we say managed, they're managed, provided as a service. They've got built-in HA, predictable performance, pay-as-you-go, auto-scaling, all the things you would expect from a managed service in Azure, just not specifically SQL. This is MySQL and PostgreSQL that are available as well. In addition, we have some non-managed options, so like Windows Azure VMs hosting MySQL installations, ClearDB, on Linux we have MySQL as well. Non-managed because essentially you just buying something from the marketplace that has everything pre-installed, but you have to manage, that application, the patching, the maintenance, etc. for the underlying database engine there. It's not managed for you in Azure. So that's basically the Azure SQL type options in a nutshell. Azure SQL being the one you're likely to get the most questions around. It's definitely a direction Microsoft is pushing people when it comes to relational databases in the cloud. The real nice thing about Azure SQL, being a fully managed platform as a service from Microsoft, they also have a number of options for you to tweak performance and cost. And you need to understand the different pricing models that are available to you. And depending on the model you've chosen for your Azure SQL database, you'll be given the choice between vCore, also known as virtual core based purchasing. And within that now, there's actually a serverless preview option as well. You can choose between provisioned compute or serverless compute. And the other option is DTU, database transaction unit based purchasing. We're going to cover both of those in a little bit more detail here because they are really, really important and you might be asked to make some design decisions around them. Well, let's begin with our vCore pricing model. Now, this model lets you basically purchase in a way that you can independently scale your compute and storage resources. It allows you really to get close to matching on-premises performance, and that's because you'll basically be choosing the latest generation hardware if you want, or a previous generation, which you'll see momentarily, and you can also optimize for price as well. And as I mentioned, you can choose that specific generation of hardware. But if we look at the vCore generations, there are two currently available. There's Gen 4, and this allows up to 24 logical CPUs. It's based on the Intel Haswell family of processors, and a vCore equals one physical core today, and you get 7 gig per core, and you get attached SSD as well. If we look at the Gen 5, it's up to 80 logical based CPUs. This is based on the Intel Broadwell family. You can see that even though the processors are slightly slower, they're 2.3 gigahertz, you're still going to get overall much better performance. vCore equals one logical processor though, so this is really, really important because with the Gen 4, you're getting a one physical to virtual core mapping. Here you're getting one logical processor, so hyperthreads. So often on cores, they will allow 2 hyperthreads per core, so that's a little bit different here. You get 5.1 gig per core, and you get fast eNVM SSD access there. So you've got to basically size up a little bit differently. You're probably going to be adding more logical CPUs when you're in the Gen 5, so it is the latest Intel processor technology there, but you will need to account for the fact that these are logical processors, not physical processor mapping that you're going to have there. And now there are a couple of tiers, or 3 tiers to be precise, that you need to be aware of as well. There's a general purpose tier, and this is the one you'll use for most business workloads. It's your budget orientated, balanced, scalable compute option that you have there, and that currently allows the Gen 4 and the Gen 5, and it is actually available in the serverless compute option that's in preview as well currently. Then you've got business critical, so this is for applications with high I/O, offers highest resilience, to failures by using several isolated replicas, and then last but not least certainly is hyperscale. So this is most business workloads with highly scalable storage and read scale requirements, and that's basically the vCore pricing models in a nutshell for you. Key thing there, know between Gen 4, Gen 5, particularly know about the difference between a physical map into a virtual core versus a logical processor map into a virtual core. Now, moving on from vCore to DTU service tiers. The service tiers in DTU-based purchase model are differentiated basically by a range of compute sizes with a fixed amount of included storage. They have fixed retention periods for backups, and they have a fixed price. So all service tiers in the DTU-based purchase model provide flexibility for changing compute sizes with minimal downtime. However, there is a switchover period where connectivity is lost to the database for a short amount of time, which can be mitigated using various like retry logic as an example. Now, single databases and elastic pools are billed hourly based on service tier and compute size. So it's an hourly billing mechanism there. The other thing to note is that SQL managed instances do not support DTU based purchasing. They focus more on the vCore based purchasing, but Azure SQL itself does support DTU service tiers. So let's run through these very quickly. Basic, standard, and premium. Target workloads could be development or production for either of those. It's not to say that because you're in the basic tier, that's not good for production. While the SLA, as you can see, is the same across all 3. Things start to get different when we start to hit backup retention. We're at 7 days for basic. We're up to 35 5 days for standard and premium. CPU, we have low only in the basic option. We go to low, medium, high, all options in standard, and premium we're at medium or high. But where things get interesting now and the premium tier starts to shine is when we get to IO. So IO throughput for basic and standard is 2.5 IOPS per DTU. IO latency, 5 milliseconds and 10 milliseconds respectively. So 5 milliseconds read, 10 milliseconds write. But in premium now, we get greater IOPS. You can see we're at 48 IOPS per DTU, and IO latency goes down to 2 milliseconds. So we get much better response time on that premium DTU service tier. We get some other features like column store indexing, which is really only in standard and premium. And we also get in-memory OLTP, which is online transactional processing when we get up to premium as well. That's basically supported there. Now we also have to take into account single database DTU and storage limits. So there's basically an option here of eDTUs and single database DTUs. So let's just focus on single database DTUs first of all. So for a single database basic, the maximum storage size is 2 gigabytes, maximum DTUs is 5. For standard, we go to 1 terabyte of maximum storage size, and now we go up to 3,000 maximum DTUs. And for premium, now we're at 4 terabytes with 4,000 DTUs there respectively. Now what you need to understand is there's also this concept of elastic pool eDTU storage and pool database limits that are there as well. Now elastic is really saying we're going to allow more automated scaling of the workload versus single DTU based storage that we really want to focus on there for single databases, I should say. So in eDTUs, we got basic, standard, and premium limits that we need to account for as well. So basic maximum storage size 2 gigabytes, standard 1 terabyte, premium 1 terabyte. Maximum storage size per pool, basic again, very low, 156 gigabytes, standard now we're at 4 terabytes, and a premium 4 terabytes as well. And now we get those maximum eDTUs per database as well, per pool, and maximum number of databases per pool. So we'll make this chart available to you. There's also a link here you can go to, which basically gives you all the details of the service tiers. So this is service tiers in the DTU-based pricing model, and you can compare them in more detail. The main thing to understand here is this basic, standard, and premium to begin with. Understand the difference between the single database DTU versus an elastic pool eDTU. So again, if we're using elastic pools there, we can take into account different options for the limits. And if you want to know how the benchmarks are created, not something you're likely to get a question on in the AZ301 exam, but certainly something that may be interesting to you to understand how they benchmark these and how they get these performance summaries, for DTU. All that detail is here as well. But that, in a nutshell, are your DTU service tiers. Again, make sure you understand the difference between vCore based pricing and DTU based pricing. vCore is likely where they want you to go now. That is the recommended option now. And within vCore, you need to understand the differences between the Gen 4 and the Gen 5 options. Now that you have a good understanding of Azure SQL, let's actually take a look at this in the Azure portal so you can see all these options in full effect. So here I am logged into Azure with my account, and I'm in an account. There's a few services already here, but for all intents and purposes, this could be any account you log into. And if I go ahead straight away and go to all services, and I'm going to choose Azure SQL from here. So type in SQL, and you can see I've got SQL databases. So I'm going to go ahead and select that one. And you can see I don't have any SQL databases currently in the subscription. I'm going to go ahead and click Add to create a SQL database. And this will bring up our wizard that we go through just like any other service. And so first of all, I need to choose my subscription. So I'm going to use my Visual Studio Enterprise subscription. You can obviously use your subscription that you've got, and then go ahead and create a new resource group for it. So I'm going to call this AZ SQL for my demonstration here, and that's just a resource group I'm going to put my resources inside of. And now I need to choose a database name. So we'll call this Skylines DB. And now I need to choose a server to put that database on. So I'm going to have to create one. I don't have any database servers here already. So I go ahead, I click Create New, and on the right asks me for my server name. So I'll call this Skylines Server in my example. It's available. And then I'm going to go ahead and put in my username and password. Now note, you do need to make sure to copy or keep this username and password safe so you can use it when you want to log in. But you can, if you need to, you can reset from the SQL Server page if you do lose it. But I'm just pointing it out now. So we'll just say Azure user for the moment. And then I'm going to go ahead and give it a password. And it verifies those match, and that's okay. And then choose the region we want to create that server in, which is where our database is going to run on. And I'm going to put this into US East, which is over here. And this part, yeah, not something we need to cover right now, but you can see allow Azure services to access server. So this is things, and I've encountered this with a client where we needed to allow Power BI to be able to access this. There could be other services that we want to access the server. This is where you check this box, and this makes it available, and basically allows some firewall and routing options on the back end to make sure that the service is available to other Azure services that you might be using, but not something we need to use right now. I'll go ahead and click OK. That's going to go ahead and put that information in for that new server. And then you see the option here as well of do I want to use a SQL Elastic pool? And we sort of briefly mentioned the DTU, the eDTUs in the previous lecture, but it's worth understanding just what Elastic pools are. Well, they're essentially this simple, cost-effective solution for managing and scaling your databases that have unpredictable usage demands. So the databases in Elastic pool are on a single Azure SQL database server, and they share a number of resources at a set price. Elastic pools in Azure SQL database will enable your SaaS developers to sort of optimize the price for a group of databases in, say, a prescribed budget, and then they can deliver performance while allowing for that elasticity. So think about it as, workloads that are changing, to seasonal demand is a good example, where you might want to use an Elastic pool, but we're not going to use one for right now in this demonstration. And here you can see I can configure my database with the different pricing tier options here, and you can see a number of options. We've got general purpose, hyperscale, business critical, basic, standard, premium. I can click here as well, and this takes me to that DTU based pricing. But if I go back to vCore based pricing, then I go to general purpose, hyperscale, business critical, which we covered in the lectures, and then I've got my compute tier. I mentioned that serverless is currently in preview. You can still choose serverless now if you wish to. That's only going to give you the Gen 5 option there under general purpose. But if I go back to provisioned, where it's actually going to provision the server, it's not going to be serverless. Here I have my compute generation of Gen 4 or Gen 5. Again, remember that Gen 4 up to 24 vCores, but it's mapping a physical processor to your virtual core. Gen 5, it's a logical processor mapping, not the physical core itself that we have there. If we need to go higher up from general purpose, again, we have hyperscale and business critical options available to us as well. And below that, once I've chosen, say, provisioned, and let's say I've chosen Gen 5, now I choose how many vCores I want to allocate. So again, I can do 2, 4, 6, 8, all the way up to 80 on that Gen 5, and I can choose my data max size. So you can basically toggle here until you get the sizing that you want, but obviously there is a price involved. So your cost summary, you can see Gen 5, here's my cost per core. Because I've got 2 vCores selected, I'm paying 2x of the 11325, and then I've got my cost per gigabyte. I've got 12 cents basically per gig there, and that's multiplied up based on my size. So yeah, it's my total estimated cost per month for the SQL server that I'm going to create. If I scroll back over to the left here, I'll click apply, and then this will take us over to the next screen here. If we click next to go to additional settings, I can now put in to use existing data. So I can say, no, I don't have any existing data at this point. I can choose to restore from a backup if I want to, or in my case, I'm actually just going to populate. Microsoft provides the AdventureWorks LT sample database here that we can basically use to populate it with some sample data as well there. And then there are a number of other features coming out here, like advanced data security, which is available as a free trial. This allows more data classification, vulnerability management. Microsoft's continuing to improve on all the security services available, and so those are there as well. Then if I go over to the next screen, I've got things like tags I can apply, just like we talked about, at various times throughout the AZ300 and 301 courses. And then finally, I can review everything and go ahead and create that database, and obviously database server as well. So I'm going to fast forward here while that completes. Okay, and as you can see, that deployment is now complete. So we can go ahead and go over to that resource, and you can see here, I've got my overview. This is my database itself. Here is my server name, so I can click this as well. This will take me to the server. So this is the underlying SQL server, and I can continue to add additional databases, pools, data warehouses on top of this underlying hardware that I've provisioned. But if I go back, or if actually I scroll down, I can click SQL databases here. I can see Elastic pools here, and that will take me back to the databases that I've provisioned. If I click Skylines DB, I can see here all the details again of that database itself. I get some monitoring data as well, so I've got some visualizations here for compute. If I scroll down, I can see my database storage that's being used there as well. And now going back to the left hand side, you can see I can also go to configure, which is where I can change the underlying performance options, vCores, etc. that I want to use. If I go back again to the database itself, I can also go to geo replication, And this allows me to select a region on the map from target regions to create a secondary database. And you can also do this by adding it to a failover group as well. So you just need to understand that geo-replication is an option there that you can use, and some of the scenarios and questions might be around global scale. Obviously, Cosmos DB is something you need to be aware of as well when that comes into play, but know how you can replicate your SQL databases as well, and Azure SQL is a great option for that. Last thing we'll just quickly hit before we terminate this demo here is just to look at the server again as well. So if I go back up to the server, you can see here that I've got manage backups under Skyline server, and you can see that I've got database backups happening here automatically, and when backups are completed, you will see them here. No databases have been backed up yet, but once they have occurred, they are there, and then I can basically restore them as well. I mentioned failover groups a second ago, and this is where you would configure those as well. And a failover group essentially is a SQL Server feature designed for automated replication, connectivity, and failover testing of your databases. So really effective option for doing recovery, site-to-site type recovery for a database. With that concludes this demonstration and hopefully gets you up and running with Azure SQL. We're going to now shift our attention to another key piece of the AZ301 curriculum, which is designing, auditing, and caching strategies. So you now know a lot about Azure SQL. What are the auditing and caching options available for you there? Well, let's begin with auditing. Well, to begin with, why do we need to audit? So we look at our SQL database and we can say, people are asking us to audit. Well, why is that? Well, one, it's to maintain regulatory compliance. You'll probably have compliance frameworks that you need to adhere to for data, for regulations, and that's a big reason. Big thing is making sure we know who accessed the data, what data we have, etc. It's also good to understand database activity, gain deeper insights into your data, which can then be used, from a business intelligence perspective as well. Now, what it does, basically, SQL auditing is basically it tracks database events and writes them to an audit log. So someone accesses data, someone deletes data. All of that are basically auditable events that we want to keep track of. So again, we understand the activity, we know what's going on in the database. It could also help us spot, malicious activity as well there. It utilizes OMS workspace, storage account, or event hubs, or a combination of those as well if you want to send the data to multiple different locations. Some people take that data, they send it off to an event hub, and then they send it off to some of their security tools such as like Splunk or QRadar, etc. If we look at SQL database auditing, this is what we can basically do with it. We can retain an audit trail of selected events. You basically define categories of database actions that you want to be audited. You can use it to report. So report on database activity using like pre-configured reports and dashboards that can get you started, and to analyze as well. So this is the third feature of SQL database auditing. You've got those reports, we can analyze them, we can find unusual activity, suspicious events, and trends. So it's not just about retaining the data, it's reporting on that data, giving you some insights into that data, and then analyzing that data for, again, useful information, but also unusual activity as well. Let's look then at some key things you need to know. Audit logs are written to append blobs in Azure Blob Storage on your Azure subscription. So that's how, when you create a storage account and you have your blob storage there, they are written to append blobs. All storage types, so V1, V2, so that's the general purpose, V1 and V2 are supported, as well as blob only accounts as well. All storage replication configurations are supported, so locally replicated storage, ZRS and GRS for globally replicated as well are also supported. Premium storage is currently not supported, and not really a big deal because you don't typically need high performant SSD disks for these, and storage in VNets is currently also not supported. So if you're using storage endpoints, they are currently not supported for SQL database auditing currently. Storage behind a firewall is currently also not supported, and I can tell you this is a common request that some of my customers have, so I wouldn't be surprised if this doesn't get updated very shortly as well. So just keep an eye on that when you're looking through the study guide. If we look then at one last thing you really need to understand is what's the difference between server level versus database level auditing policy. So as you saw in the Azure SQL demonstration, we can go in and we have configuration we can do at the database level, and we have configuration that we can do at the server level as well. Well, if we start with the server level, basically you create your auditing policy there, and this then applies to all existing and newly created databases on the server. Now, if server blog auditing is enabled, it will always apply to the database regardless of your database auditing settings. Now, if we do database level, this is policy for the specific database. Now, you can enable it on both the server and the database, but it does not change the server auditing. So both audits will exist in parallel, and you want to avoid this unless you have a use case for that specific database and want to send to, say, a separate storage account or need a different retention period. So keep that in mind, because ideally what you really want to do is just audit at the server level, or at least apply your policy, I should say, at the server level, and then that will apply to all your databases that are created on that server and existing ones as well. But if you have a specific requirement that's different and you're like, oh, okay, that doesn't make sense for me to put that across every database. I don't want all that extra data when really I've been told I really need to do some extra auditing on the specific database. Absolutely go ahead and do it on that database specifically. But just note, it's not going to stop the auditing and the logging that's happening at the server level. So again, you've got two policies happening in parallel and storing data in parallel there. But with that, that concludes auditing policies. And in the subsequent lecture, we'll go through caching, which is the other part you need to know. All right, let's now take a look at caching. Well, first of all, what is caching when it comes to caching, say, a database? Well, if we think about it, first of all, we've got our application, and typically we would go straight to the database to access the data, but we can basically put this cache in between, which then, is stored as data is retrieved from the database. Now, essentially, it's a common technique. You hear it all the time. We've got caching on processor, we've got caching in memory, we've got all different types of caching, but it's designed to improve the performance and scalability of a system. So instead of us sort of always going to the database for that particular data that we say reading from, if it's in a faster cache, we can access it from there. It's frequently accessed data on fast storage that's closer to the application. Because if this data is in that fast storage and it's located closer to the application, we're just going to get better response times. There's a common saying when customers, or I'm sure you see it too, when you go to a website, you want to access something, if it's really, really slow, you get really, really frustrated. And caching is a way that's obviously today, when you go to a web page, you typically have some cached images and things on your local machine, so it's not retrieving them from those servers remotely. Things are sped up because of that. So that's basically the key behind caching as a whole. Now, if we look at distributed application caching, we ultimately have two major things that we need to consider. One is private caching. This is used when data is held locally on the instance that is running the application or service. And you can implement both caching strategies, private caching, and the next one I'm going to talk about, which is shared caching. This is a common source that can be accessed by multiple application processes and machines. Now, essentially, you use a private cache where data is held locally on a computer that's running an instance of the application or service. You use a shared cache when you want a common source that can be accessed by multiple machines, multiple applications around that. Now, in both cases, caching can be performed client-side and server-side. Client-side caching is done by the process that provides the user interface for a system, such as a web browser or desktop application. So going back to the example, when you access a website, your web browser can cache. That's a client-side caching mechanism. Server-side caching mechanism is essentially a process that where there's like a server that's caching that's shared amongst other services that are potentially running remotely. So those are the two major types to begin with. But let's look at private caching in a little bit more detail. So if you look at this, you've got application instance A and application instance B. And the most basic type of cache here is like an in-memory store. It's held in the address space of a single process and accessed directly by the code that runs in that process. So if we think of application A, it's got a cache that is a snapshot of the data at time X. Application instance B has a snapshot of the data at time Y, because it's basically around the data that they've accessed. Application instance A retrieves data at time X and basically puts it into its memory. Application instance B, same thing, retrieves data at a certain time Y, caches it in its memory. Information in the database changes between time X and time Y. So the key thing we have to know is, well, when do we refresh that data, in the cache? And there's different, features and services around that specifically, which we'll talk about. If we look at shared caching, you can see it's a little bit different because they don't have their own cache in each instance. We have a shared cache service that we go to when we want to basically get that cache data. So this could be just a faster mechanism that we access that's basically caching the data from, say, SQL, but both application instances in this case see the same cache data. So the risk is lower here from a caching perspective. Again, we always want to make sure that we have the latest data. And that brings us on to, what are the considerations for using caching? Well, number one, deciding when to cache data. Caching can dramatically improve performance, availability, scalability. The more data you have and the larger number of users that need access to the data, the greater the benefits of caching become. That's because, caching reduces latency, and contention when lots of applications are trying to access the same data source. You want to determine how to cache data effectively. The key to using a cache effectively lies in determining the most appropriate data to cache and caching it at the appropriate time. Highly dynamic data needs to be taken into consideration, because if the data is rapidly changing all the time, it can actually impose more of an overhead on the cache system. Data expiration. So in most cases, the data is held in a cache as a copy of the data in the original data store. But the data in the original data store might change after it was cached. This causes the cache data to become stale. So you've got to decide, when does that data, basically expire in the cache. And then last, but certainly not least, is invalidate data in a client-side cache. So because data is in, say, your web browser's cache, that doesn't mean it's the right data. So how do we make sure that we invalidate data in a client-side cache? So again, you're getting speed and performance benefits here, but we have to make sure that you've got the right and the most accurate data at all times. Before we end off, the other thing just to consider is Microsoft does provide a service, which is the Azure Redis cache. And this is an implementation of the open source Redis cache that runs as a service in the Azure data center. So it provides caching for cloud services or websites inside VMs as well. So it's not just for PaaS services, and it can be shared by client applications that have the access key. So it's a shared cache mechanism for you there, and it offers an option as an in-memory database supporting both read and write operations as well. So very common, you'll see in a lot of applications today, people use a Redis shared cache to provide that balance, of performance and scalability that they need. Redis is a whole topic in itself. So if you do want to know more, highly encourage you to read more about it. There will be potentially some questions on it, but it's more likely like knowing when to use a shared cache in your architecture decisions that you're going to make. You're not going to be expected to know how to configure a Redis cache in the AZ301 exam. In this demonstration, we're now going to take a look at SQL long-term backup retention, which is also one of the things that Microsoft indicates in the curriculum that you need to know for the AZ301. So if we head over to the Azure portal and look at the SQL instance that we created in our previous demonstration, and here I am, I've got the Skylines server, the SQL server up and running. And again, I can look at my databases that are running on that server if I want to. But what I actually need to do is look at the backups themselves. So on the left-hand side here, I click Manage Backups. And as before, you can see I've got my backups here. Backups will take effect. But what I can do is click this one and say Configure Retention. And now you can see I've got my point-in-time restore configuration. That's my standard backup policy that I want to keep in place from 7 to 35 days. But long-term retention is actually below here. So you've got long-term retention, which isn't configured by default. And I can choose here between weekly, monthly, or yearly backups. And the key thing you really need to know here is you can go up to 10 years in backups. So if I go down to yearly backups and I say, okay, I want to keep 10 years, you can see my maximum there is 10, and I can choose, which weekly backup of the year I would like to retain for that 10-year period. And that gives us a great advantage because traditionally, when you wanted to do something like this, you'd often back up your SQL servers, you would put it on the tape, you'd ship them off to places like SunGuard that would sort of keep your backups in a vault, in a tape vault basically for you. And then if you ever needed to retrieve that data, you would request those, they would ship them back to you, and then you could recover them. But in this case, completely in the cloud now, all managed for you by Microsoft, you can get up to 10 years of retention. And this is where you configure it, and it's simple as a checkbox. And with that, that concludes this demonstration. Let's now take a look at another database service that's become very, very popular in Azure, and that is Cosmos DB, which you've probably heard a lot about already. And well, what is Cosmos DB? Well, first of all, just helps to understand this is a globally distributed database service. It supports schemaless data such as NoSQL, as we discussed in the data types, and it's used to build these highly responsive, always-on applications which have constantly changing data. So when I think of that, I think of, not to say that Facebook uses Cosmos, but Facebook is a good example of something global. Users all around the world are accessing it, they're changing data in it, but they probably want to access it more locally rather than everybody, say, coming all over the world and going to a US data center. Wouldn't make a lot of sense. Cosmos is a way for the database to be spread out around the globe, and there's some mechanisms to make sure that writes are consistent and the data, eventually gets synced across all those different services. Another example Microsoft gives on the Learn site is this image here. Developer frequently updates the catalog for an online training course catalog. That goes into Azure Cosmos DB. Global users and training developers, work against that Cosmos DB database. And again, they're distributed all over the world. If you want to see more of an architecture diagram of this is from the Cosmos DB site on documentation at Microsoft, and helps to think about it from the top here. So we've got mobile users, web browsers, other devices coming in through the internet. They might hit a traffic manager that tells the user, hey, you're going to go to West US, North Europe, or Southeast Asia. And then the good thing here is that if you look at the services under there, might have a web tier, a middleware tier, much like normal applications today. They can use load balancers, etc. But those tiers then basically talk to Cosmos DB. So in this case, the web tier hits the middle tier is what's talking to the database. And in each region, you see it just talks to Cosmos DB and it thinks it's in its region. But then behind the scenes, Cosmos DB is taking care of all the replication. And this concept of allowing people to natively, implement protocols for NoSQL APIs is a big, big benefit to this. Good examples of that are DocumentDB, MongoDB, Graph API, Tables API, etc. And this really allows the application to continue to remain portable and be vendor agnostic. And on top of that, again, everything is automatically partitioned for performance and storage capacity, in those various regions. So that's Cosmos DB in a nutshell, and really just know when to use it, and definitely dig into the Cosmos DB documentation on the Microsoft site if you want to, know even more about it and get more into the weeds with it. There's a lot of good tutorials there that sort of guide you through it. Okay, now that we have a good understanding of Cosmos DB at a high level, the thing you need to understand as well are the consistency levels that come with all that replication that's happening, across Cosmos DB, potentially across regions for you. And so there are 5 levels to take into account. The first one being strong. This is guaranteed write operation, only committed and visible on the primary after it has been committed and confirmed by all the replicas. So this is the strong consistency model, most predictable, intuitive programming model that you have there. This means that the reads are guaranteed to see the most recent writes to the database at all times. We then have bounded staleness. So bounded staleness consistency is the most frequently chosen by globally distributed applications that are expecting low write latencies, but also want those global order guarantees. So this allows you to configure how stale docs can be within replicas, and staleness means the quantity or version count a replica document can be behind a primary document. So how far behind can that document be before it just has to be updated for the latest version there. Then we have session. This guarantees that all read and write operations are consistent within a user session, as a very, very common method that is used there as well. Widely used for single region as well as globally distributed application. It provides write latencies, availability, and read throughput comparable to that of eventual consistency, which you'll learn about in a second, but also provides the consistency guarantees that suit the needs of most applications written to operate in the context of the user. So again, think of a user, think of something like Facebook as an example. That's like a user sort of session. A lot of that data is particular to that user. So that would be kind of a good example of session for you. Then we have consistent prefix. So this ensures changes are read in the order that matches the sequence of the corresponding writes. And then last but not least is eventual. So this is the loosest consistency model. Commits and writes operations against the primary immediately. Replica transactions are synchronously handled and will eventually be consistent with the primary. So think of it all the way from strong, where it's guaranteed, all the way to eventual. And really it's a trade-off between performance and consistency of data that you're ultimately choosing between that. Now, when you choose a consistency strategy, again, stronger consistency level, this ensures documents and replicas do not lag behind the primary, recommended for applications that require all replicas to exactly match the primary at any point in time, but it has that negative effect on the write operations. If you go for the weaker consistency level, this ensures the databases operate at peak performance or efficiency. Recommended for all apps that require high performance, read operations against a replica can return stale data. So if we go back to that list there, all the way from strong to eventual, you just need to choose the appropriate level that makes sense, for the task at hand. And in the exam, you'll likely get some use case type scenarios, most likely asking you just to choose between strong and eventual, but there's a good chance if you hear the word user in there, you might want to go for something session based from a consistency level. So just watch out for the word in the questions there. Make sure you understand all 5. Now we move on to a really, really exciting topic, which is IoT, also known as Internet of Things. And it seems like you can't move these days without hearing about another device that is connected to the internet that is sending data. And this ranges from everything from, Nest cameras in your home, your refrigerator, but the industry ramifications are pretty important today. And Azure has a whole lot of IoT services to help support the industry. Whether you're a farmer out there trying to, get more production out of your crops by having more data about, say, moisture and things like that. Whether you, basically a car manufacturer or an insurance company for automobiles, and you want more data about the cars to maybe change the way you construct insurance policies. Lots of industry challenges and changes happening as a result of IoT. And if we go into a little bit more detail about what Azure IoT means, well, Azure IoT is a collection of Microsoft managed cloud services, and they're focused on connecting, monitoring, and controlling IoT assets. That's kind of the core of everything there. And if we get into that a little bit more, IoT solutions are made up of one or more IoT devices and one or more backend services running in the cloud. So let's just look at some device examples. First of all, we could have the water sensors for farming. It's a good example. We could have pressure sensors on a remote oil pump. And we could have things like temperature and humidity sensors in an air conditioning unit, or, great examples of IoT devices that could be out in the field, sending data back. And ultimately, these IoT services in Azure are a place to send data back to. Now, let's break down those services a little bit more. Well, one, we have IoT Central. So this is a SaaS solution to help you connect and to manage all your devices out there. That could be pushing updates out to them, just knowing where they are, asset management, things like that. It's really around just managing and connecting your devices there. And then we have IoT Hub, which is a core service a lot of customers use now. This is an underlying service needed to facilitate the messaging back and forth between your IoT IoT application that's perhaps running in the cloud and the devices out in the field. And then we have IoT solution accelerators. These are complete, ready to deploy solutions that implement common IoT scenarios. And so for the exam for AZ900, you really just need to know how to describe IoT, understand what it is, where it fits in, to the picture as a whole. But you shouldn't be required to go into any more technical detail. You just need to know at a high level, what these services do. And, you might get some questions around when to use which one, and maybe some scenarios about IoT out in the field. Okay, so we've covered everything from database services to generic storage services, and we still have one more category in data service to cover, which are big data solutions. And it helps to just understand, well, what is a big data solution to begin with? And I think this diagram from Microsoft really sums it up, very, very well. To begin with, we have data that needs to be ingested. This could come from all sorts of sources. This could be images, CRM tools, line of business applications, IoT that we talked about in the IoT section, and then ultimately gets ingested, and that could be through some data orchestration and monitoring. Microsoft has a tool called Azure Data Factory. There's other tools that are available, in the market as well, but ultimately they're ingesting that data in and then storing it somewhere in a big data store, basically. Once it's in that big data store, then we can use things like Hadoop, Spark, machine learning algorithms to prepare and train the data. And then when the data is ready for complex analysis, things like SQL Data Warehouse, use Polybase, which is a tool under the covers to query the big data stores. And then Polybase uses standard, what they call TSQL queries to bring the data into SQL Data Warehouse. And ultimately, all of this is to provide some, apps and insights, on top of that data to give some meaning to it and help the business make good decisions based on that data, or use it, for other purposes that they need it for. But ultimately, let's look at the different services available. Well, to begin with, we have the SQL Data Warehouse. This is a key component of the big data solution. This is a cloud-based enterprise data warehouse, EDW, that you might hear about, and it uses massive parallel processing, so it can run complex queries across petabytes of data. So think lots and lots of data here. It stores data in relational tables, reducing storage costs and improves performance. Then we've got HD Insight. So if we look at HD Insight, this is fully managed open source analytics services, for the enterprises, and it uses the most popular frameworks like Hadoop, Spark, Hive, etc. So some customers might say deploy Hadoop on premises or may deploy it in the cloud on top of virtual machines. This is essentially a service that's created for you to kind of take away some of the pain of setting that up yourself. It has some good scenarios. So we have batch processing. So this is the extract, transform, and load process, also known as ETL. So ETL stands for extract, transform, and load. And this is a process where unstructured or structured data is extracted from all those heterogeneous data sources. It's then transformed into a structured format and loaded into the data store. And you can use the transformed data for data science or data warehousing. If we look at data warehousing, this is where you can use HD Insight to perform queries at petabyte scales over that structured or unstructured data in any format. You can also build models, connecting them to BI tools such as Power BI. Then we have Data Lake Analytics, and this is an on-demand analytics job service that simplifies big data. Instead of deploying, configuring, and tuning all the hardware, you pay only for your job when it is running, and you write queries to transform your data and extract insights. You basically write those queries yourself, and then you pay on demand when they run and execute. And so that, in a nutshell, are the core big data services that you'll need to know about. I'd say the big thing here is just understand that ETL is extract, transform, and load, and then understand the different services available here and where they might fit. Let's take a moment now to just look at the SQL Data Warehouse architecture in just a little bit more detail. And you can see on screen here, this is kind of the high-level architecture for SQL Data Warehouse as a whole. So it uses a node-based architecture, and applications basically connect and issue those TSQL commands to a control node, which is the first thing you need to really know about. So the control node is the brain of the data warehouse. This is the front end that interacts with all the applications and the connections coming in. The MPP, that's the parallel processing engine, the massive parallel processing, runs on the control node, and this is to optimize and coordinate all those parallel queries. So when you submit a T-SQL query to SQL Data Warehouse, the control node transforms it into queries that then run against each distribution in parallel. Now then you can see you have a number of compute nodes. So the compute nodes provide all the computational power. So this is the distributions map to compute nodes for processing. As you pay for more compute resources, SQL Data Warehouse remaps the distributions to the available compute nodes. Now the number of compute nodes can range from 1 to 60, and this is determined by the service level that you choose for the data warehouse. Each node basically has a node ID that is visible in the system views, and then you can see the compute node ID by looking for the node ID column in system views. views whose names begin with sys pdw_nodes if you're looking for that. Not probably essential that you know that, but just know that the range of 1 to 60 and know how the compute nodes work. Then we have DMS, Data Movement Service. So this is the data transport technology that coordinates data movement between the compute nodes. So some queries require data movement to ensure the parallel queries return accurate results. When data movement is required, DMS ensures the right data gets to the right location. And last but not least, you can see we just have a whole underlying set of Azure storage. SQL Data Warehouse uses Azure storage to keep all your data safe, and then it can also take advantage of all the features associated with the underlying Azure storage technology. So that's SQL Data Warehouse architecture in a nutshell for you. Definitely read the attached study guides for some more detail as well if you want to get deeper into SQL Data Warehouse, but definitely understand where it might be used in your process and the key areas of scalability there. Now again, you've probably heard by now about all these different data services, but what about the integration options? And if you're used to on-prem workloads, you might be used to SSIS, also known as SQL Server Integration Services, which we use for a lot of data movement, ETL jobs. But in Azure, they actually provide a service for this called Azure Data Factory that you need to be aware of. Now, Azure Data Factory is used to manage, extract, transform, and load, again, ETL and data integrations, basically. Now, it facilitates data-driven workflows, also known as pipelines, that carry out various tasks. First one being connect and collect. This could be connecting to relational databases, HDFS clusters, streaming data, things like that. Then we can move on to like transforming and enriching the data. And this could be using things like Spark, which we briefly mentioned earlier, data lake analytics, maybe using machine learning on top of that data as well. Then we move on to publishing. So this is like publishing to the web, interactive analytics. More common one is Power BI that you probably hear time and time again. And finally, it can also be used from a monitoring capacity as well. At the heart of it all though, if you look at it, connect and collect, then you transform and enrich, publish, and monitor. This is the heart of the Azure Data Factory. So just know about that, know how it works. It might be worth you just going into the portal and just building a data factory just to see how you kind of connect to a database, connect to workloads, maybe run some transformation jobs on top of those. In addition, you've also got Azure Analysis Services, not something that you're expected to know in great detail, but know that it exists. And then you've also got, from an analysis option, Azure Analysis Services. If you're used to coming from on-premises, you might be familiar with SSAS. Azure Analysis Services is the Azure sort of managed version of that as well. And that's to do like analytical analysis, data modeling, things like that on top of your data. So again, you might be asked to identify what service you might use. And the big ones for data movement would be Azure Data Factory. To replace SSAS on-premises, it would be Azure Analysis Services. So by now you're probably saying, okay, Nick, that's great. You've explained all about different data services. We know about storage services. How do I make the choices between these? And that's one of the key things for the AZ301 exam, is knowing how to choose between different data services. And that's going to be the heart of a lot of the questions you get. So let's walk through these. Microsoft kindly gives us this table that you're able to use. And let's just walk through these line by line to hopefully just cement them in your decision matrix as you're sort of going through the exam. Well, first of all, if you want a globally distributed multi-model database, which supports NoSQL with industry-leading performance and SLAs, the natural choice now is Azure Cosmos DB. Again, think global workloads, think things like Facebook user sessions, things like that. Those types of use cases would be Azure Cosmos DB. If you want to bring your SQL workloads and perhaps using SQL on premises, and you want a fully managed, relational database that provisions quickly, scales on the fly, and has that built-in intelligence and security, SQL database, Azure SQL specifically, is a great way to do that. Remember, you also have SQL managed instances as well if you want to replicate as close as possible to your on-premises infrastructure. If you want a fully scalable MySQL database, then there's Azure Database for MySQL. If you want PostgreSQL, there's Azure Database for PostgreSQL available there for you as well. So those are your kind of choices in the SQL arena. If you just want to completely host it exactly like you would on premises, there is the concept of SQL Server on virtual machines, and that's basically a VM that's run in SQL. You still have complete access to the VM. It does have things like automated backup and patching as well. Now, if you want to have a fully managed elastic data warehouse with security and scale, SQL Data Warehouse is the way to go. If you're trying to migrate databases from on-prem, say, into Azure, or from other Azure databases to another Azure database, you've got the Azure Database Migration Service. If you need to implement caching, you've got Azure Cache for Redis. If you want a simple NoSQL key value store, table storage is available to you there as well. We talked about Azure Data Factory as another method for moving data around, but if you want to actually explore data, there's also Azure Data Explorer as well. And last but not least, you also have a Mariah DB managed option available also. So these slides will be published. Look at the study guides as well, but just know when to use which database service. I'm going to go back to the main screen here and really say put an emphasis around Cosmos and SQL, and then know when a data warehouse, Hadoop and some of those other things come into play that we covered as well. Know that, hey, if I want to move data, it's Azure Data Factory. If I want to analyze data, it's Azure Analysis Services. And think about those ETL jobs. Think about the architectures. There's obviously a lot to cover here, and I encourage you to kind of read the associated documentation for these as well. Okay, so we understand a lot about different database services, but what about if we just want some information on Azure storage and some of the basic storage fundamental services that are available there? Well, to begin with, we have Azure Blob Storage, and Azure Blob Storage is really just unstructured storage for storing objects. Again, it's a big bucket that we just throw in our images, our videos, files of any type, basically. Use cases for Blob are streaming video and images direct to the user, backup DR of data, and things like archiving. On top of that, we have Azure File Services. So if we move on to Azure File Services, these give a lot of benefits if we want a file system, that we want an easy way to create file shares. So contrast that with Blob Storage from a second ago. Blob Storage is just, raw objects, images, videos, etc. A file share is really for Word documents, Excel, where we want to put like permissions and things like that on, much like we do today, probably in file shares that you have in your data center. And sometimes you ask IT to create a file share, or perhaps you admin those file shares today. That's the big difference here. They support SMB 2.1, which is unsecured, and 3.0, which is secured. You can mount them on Windows, Linux, or Mac. And Azure File Sync is a new service that's out, which can be utilized to sync file servers on premises with Azure Files. This is a really popular and welcome addition to Azure Files. Essentially, you can have your file share, on premises, and it syncs services up to Azure Files directly. So the file share that's actually in the cloud, and it's a good way, to make sure all your files are synced up, and you can restore them to other file services around the globe as needed in the event something, maybe even just happens to that file service. In addition, we've got table storage, also under the concept of storage accounts, which we'll hear a little bit more about later on. And table storage, you can see there, it's a NoSQL key value store, schemaless design, structured or unstructured data can go in here. And you access this using the OData protocol and link queries, WCF data service.net libraries. So you can see it there, account, table, entity, object. That is the relationship from the storage account. You then create tables, you got your entities, and then you've got your objects, which could be like name, address, species, location, etc. So essentially just, raw table storage for you there. And last but not least in this section, we have Azure Queue Storage, which is a service for storing large numbers of messages that can be accessed anywhere in the world. It's a reliable mechanism for storing and delivering messages for applications. It can be used to help build, flexible applications and separate functions, for better durability across very, very large workloads. Other thing to note is single queue message can be up to 64 kilobytes in size, and a queue can contain millions of messages up to the total capacity limit of a storage account. And again, you'll learn more about storage accounts, a little bit more detail, not as important the detail for the AZ900, but I think it helps to understand how they work, particularly, if you're taking this exam for somebody, say, in the field, or you're an IT admin getting into cloud computing, definitely helps to really, really understand storage accounts. And so what you can see now, just flicking back through all these, you've got table storage, queue storage, file services, and blob storage. All of these come under storage accounts, which you'll learn more about later. But at a high level, blob is for, unstructured data, just throwing it in buckets there. We've got file services for storing files that we would typically want to put permissions on. We've got table storage for raw table storage, schemaless design. And we've got queue storage for storing and delivering messages for applications. So a wide range of just core storage services available to you there. Let's get started with blob storage by taking a look at this from the storage account perspective. First of all, we have our storage account, and you'll need one that supports blob storage. In addition, we have our containers, which are inside our storage account. This helps us organize our various blobs and images and data files as we come across them. And finally, we have our blobs themselves, which go inside there. Now, you may be thinking, okay, what is a blob? How is this different? Well, blob is a binary large object. Think of it as your ones and zeros. These could be images, video files, random text files, or whatever they might be. But don't confuse them with files compared to like an SMB file share, for example, which has permissions and other things associated directly from a CIFS perspective. This is for storing large amounts of images, videos, etc. Now, if we look at the storage account types, we have three major types. We have GPV version 1, blob accounts, and GPV version 2. Now GPV version 2 is the main choice you'll use when you create storage accounts in Azure now, because it allows us to do page blobs, block blobs, so we can do all of our images, videos. We can also store VM disks in there as well. We can mix everything in a GPV2 account. GPV1 allowed us to store blobs and other disks as well, but a blob account was specific only for blob storage, and ultimately it was confusing for everybody, so that's going away, and GPV2 accounts are ultimately the direction going forward. You may be asking then, okay, well, what is the difference between a block blob and a page blob? So a block blob, again, is ideal for storing text or binary files. So again, those are those images and video files. A single block blob can contain up to 50,000 blocks of up to 100 meg each for a total size of 4.75 terabytes. So that's a single image. Ultimately could be 4.75 terabytes. Append blobs are also there, and they're optimized for append operations, example for login. Now you may see that difference between blob creation and append blobs, and that's just important from that perspective. Page blobs, on the flip side, these are for read-write operations. Think of your VM disks here. These are used by Azure VMs, and these can be up to 8 terabytes in size. Which leads us on to the next thing that we need to cover, which are storage tiers. We've decided now that we want to use blob storage and store a bunch of images, but what's the right tier to go for? Well, the first one we look at is hot storage. This has our highest storage costs, but our lowest access costs. So think of this for frequently accessed images that we might be utilizing in our application, or, maybe website content, things like that, accessed very periodically. And then we have cold storage. This has lower storage costs now, but higher access costs. And it is possible to move from cold to hot and hot to cold, as you'll see in some of the demos. But what you do incur is a storage cost penalty when you do that, because if you're moving from cold to hot, immediately you're going to pay those higher access costs for accessing the cold storage as you move it to hot. So even though you can move them around, it's best to aim to use the right tier of storage for your purpose. And if you look at cold, it's really intended for data that will remain cool for 30 days or more to be cost effective. Finally, we have archive storage as well. This has our lowest storage costs, but our highest retrieval costs. When a blob is in archive storage, it is offline, and so it cannot be read. And this is really because it's pushed off to tape or some other archive type storage that Microsoft uses on the back end. So if you decide you want to access something in archive storage, there is a period of time as that has to get rehydrated back so you can access it. Now, ultimately, just pick the right storage for your use case. And if you decide, okay, well, sometimes things go into hot storage and then eventually I want them to go to cold or eventually to archive, it is possible to enforce some auto tiering around this that will gradually move, unaccessed blobs from hot down to cold, down to archive, and there's various automation techniques in Azure that allow this to take place. Finally, let's just take a look at the decision criteria as we try to choose between blobs, files, and disks. Often this gets very confusing. So if we break it down, blobs themselves, this is for storing large amounts of objects. Again, images, videos, etc. We might want to access them from anywhere. Just lots and lots of images, videos, text files, etc. that might be accessed. Then we've got files. So think of these as more from accessing from multiple machines, jump box scenarios. Maybe you've got a remote desktop that somebody wants to store a root user profile on. That's a good scenario. And then finally, we have disks. So these are really associated with our virtual machines attached to the operating system. Think of this for like lift and shift scenarios. When we're moving from on-premises, we might be doing disk expansion for application installations, lots and lots of read-writes. That's when we would ultimately use disks themselves. Now that concludes the overview, and I encourage you to check out the subsequent demo, especially as we kind of build blob storage accounts and move images around. You'll get a lot of feel for everything that we've covered thus far. In this demonstration, we're now going to cover creating a storage account via the Azure portal. So let's flip straight over to Azure. Here we are in Azure, and the first thing we're going to do is on the left, just go ahead and create a new resource group. So select resource groups, select add at the top, and type in your resource group name. So in my case, I'm going to use SL-storage. Choose your subscription and the resource group location. Again, this is just for metadata for the resource group itself. You can still put your storage account in any region you like. And go ahead and create that. The reason we do this and create our own resource group here is we can put all our storage accounts in there for demonstration purposes. Just delete the resource group when you're done, and you've ultimately wiped everything out straight away. So within a few seconds, that should be created if we hit refresh here. And there we go, SL-storage. Now we're going to that resource group, and let's go in here and create a new storage account. So go ahead and select add, type in storage account. You'll see it'll come up there, storage account, blob, file, table, queue, because that's what we can store in there. And go ahead and select that, create. And now we'll get the blade for creating our storage account. So first of all, let's go ahead and give it a name. So in my case, I'm going to use SL-storage demo. And as you can see, this is a publicly addressable namespace that we need here, so it has to be unique. Then we choose the deployment model. For everything in this course, we'll ultimately be using the resource manager model, as you've probably seen so far. And then we get onto the storage account type. So if we go ahead and hit the drop down here, we can see we have storage, storage v2, and blob storage. And ultimately now everything we do, we're going to use a storage v2 account. Now you notice some of the options change below. If we go back and choose storage gv1, we don't get that option for the tier straight away. I'm going to switch back to it again. And you can see that we get a default access tier. And this is because we can set a tier of storage at the storage account level, which will apply to all the objects underneath it. Now we can still change the individual blobs to have their own access tier, but this is quite a nice feature because we can say, okay, everything we want here, we might want cool, we might want hot. In my case, I'm going to choose hot, and everything underneath it will apply to. Then we can choose our performance. So we've got standard and premium, much like when we talked about virtual machine disks. We can choose SSD type storage or standard spinning disk. In our case here, we'll just go for standard for the purposes of this demo. Next, we need to look at replication options, and we have the same four that we covered in the virtual machine section. LRS, which is locally redundant storage. This is 3 copies locally in the same data center. We have ZRS, which is zone redundant storage. This is in preview currently. Still 3 copies, but in a zone-based region, so a couple of data centers in the same region. Geo-redundant storage, which is GRS. This is 6 copies across multiple regions. And finally, RA-GRS, which is read-access geo-redundant storage that allows us to replicate to another region and actually read data there. It's basically warm and ready for us to access. In our case here, we'll simply select LRS. Next, we choose our access tier, as we already discussed. We're going to use the hot tier. And then we have options around secure transfer. If we open up the information on this one, this allows us to enforce encryption options for when we access in data from the storage account. For the purposes of this demo, we'll just choose disabled, choose your subscription, and select the resource group we just created previously. Finally, scroll down, select your location. In my case, I'm going to continue to use North Central US, and choose disabled for virtual networks. This option, which will be covered in the networking section, is around virtual service endpoints, and that allows us to say, take a storage account, and instead of exposing it over the internet, we can expose it directly through a virtual network. And this is a way for security teams to buy off on the fact that, we have blob storage out there that's only inside of the Azure private network itself. With all those options selected, go ahead and click Create, and then we'll fast forward here. It should take about a minute for your account to be created, and we'll transition to once that's completed. As you can see, after a period of time, the storage account is now created, and we can go ahead and select it. Once it opens up, you can see the performance that we chose, which is standard, the replication set to LRS, and our account, which is set to GPv2. And then at the bottom, you can see our various services. So we've got blobs, files, tables, queues. If we wanted to go ahead and upload blobs, we could go into the blob section, create our container, and upload it from here. But you'll see in a subsequent demo, as we use Storage Explorer, how you can upload lots of blob images and manage your storage account from there. And with that, this concludes this demonstration. Alright, time for another demonstration, and now that we've created a lot of our storage accounts, whether we did it via the portal or via PowerShell, it's now time for us to be able to browse that storage and maybe upload objects, etc. to it. And so we're going to use the Storage Explorer client to do that. In order to begin, you first need to download the client, which you can find on the Azure website. If you head over to azure.microsoft.com/en-us/features/storage-explorer, or just Google Azure Storage Explorer, you'll be presented with this page. There's a Windows client, a Mac OS client, and a Linux client. Go ahead and download Storage Explorer free by selecting the link at the bottom after you selected your OS, and once that's installed, we'll continue with this demonstration. Okay, so once Storage Explorer is installed and you'll immediately be prompted to run it, go ahead and do that, and you'll be presented with the screen. You have a number of ways that you can log in and browse your storage. You can simply add an Azure account directly. You can use a connection string or a shared access signature that we'll learn about later on in the module here, and you can always use your storage account name and key as well. But in our case, we're just going to sign in by selecting sign in on the bottom here, and this will sign us in the usual prompt to sign into our Azure account. Okay, once that's added, simply select apply, and then you can see all of the various storage accounts. So in our case, we created a SL storage demo, first of all via the portal, and then we created one via PowerShell. So we can expand these out here and see what's inside them. Again, we really don't have anything in them at the moment, but you kind of get the idea there. Now, what we can do is add some files directly to this. So we can take some images, for example, and then go ahead and select the blob container section under your storage accounts. If we right-click there and click Create a New Blob Container, call this one Images. And on the right-hand side now, we see we have this upload option, so we can go ahead and select that. Click Upload Files. Now I'm simply going to select a folder full of files. I've got an image sample on my desktop, so I'm going to select all of these, select Open, and go ahead and select Upload. And what you'll see is this begin to start here in a moment, and on the bottom, if we expand this out, We can see the group of images it's uploading, how many are complete, and you can see they're appearing in the top pane there as each one is uploaded. And so you can see the flexibility. It's just like managing a file share on your own machine where you can, create images, delete images, etc., create new folders. If you want to get a URL from them, if you want to rename them, you've got these whole series of options available to you on the top there. The other thing as well is if we go over to the Azure portal and look in our same storage account, so SL Storage Demo, we also have an option there, Open in Explorer. So if we go ahead and select this and click yes, you'll see it'll switch apps and open directly in Storage Explorer as well. So this is another quick shortcut. If you're in the Azure portal and you want to open up in Storage Explorer, you can simply do that and it'll take you right across there. And with that, this concludes this demonstration. All right, so we've discussed a lot around the different storage types that are out there, and we've created blobs and things in the various demonstrations, but how do we control access to them? And the first one I want to bring your attention to is access policy specifically to the container. And on the container inside of your blob storage, you can set the public access level. Now the default is private, so this is no anonymous access, nobody can access your images, etc. When things are set to private. The next one is blob, which I use for some of the demonstrations where we have anonymous read access for blobs only. And the third one is container, where we have public access for the container as a whole, so that's read access for the containers and the blobs. Now, if we go further into this, we can also get a little bit more granular with SAS, which is shared access signatures. We may not want to just generically assign permissions at the container level, so we can use this method, which is a query string that we add onto the URL of a storage resource, and this string informs Azure of what access should be granted. And we'll get a little bit deeper into the shared access signatures and how you construct them in a little while. But to go a little bit further, there's two types. There's account SAS tokens. These are granted at the account level to grant permissions to services within the account. And then there's specific service SAS tokens. These grant access to a specific service within the storage account. And it should be noted that these are all encrypted. They utilize a hash-based message authentication to keep everything nice and secure. So what does a SAS token really look like? And if we break it down, when you copy it from Azure and you say, hey, I want my SAS token, it's going to give you a very long URI. That's a unique resource identifier. And there's a couple of things to keep in mind here. So you've got your storage resource URI. So in my case, I've got slsasdemo.blob.core.windows.net. That's my storage account, my images container, and then image.jpg. That's my specific blob that I'm referencing. And then I have this giant string that's appended to it, which is my SAS token as a whole. And it helps if we go ahead and just break that piece down further. So to begin, let's start with our blob that we know we have our image.jpg. That's the first part of the entire URI. Then we have the storage service version. So this must be set to version 2015-04 for April-05 or later for it to work at the moment. That's the current as of the documentation. And then we have SS equals BFQT. Now it's very simple actually. If you look at the B, that stands for blob, the F is for file, the Q is for queue, the queue service, and T is for table. So these are the signed services which are accessible with the account SAS. Then we have SRT, in my case, equals SCO. So these are the signed resource types. So the S under SCO stands for service. So this is access to service level APIs. The C is for container, so access to container level APIs. And then finally, we have the object itself. So this could be the blob, or in the case of a table, could be the table, could be queue messages, etc. Then we go down a little further and we have signed permissions. So this is a bit of a mouthful here. We've got R, W, D, L, A, C, U, P. Well, let's break these down. So if we take the R, that's for read. So that allows us to read and essentially have read access to the object. The W is for write access. The D is for delete. The L is for list. A is for add. C is for create. U is for update, and P is for process. That's specific for queue messages. The same for update. That's specific for queue messages. If we go a little further, then we have our signed, expiry, and start. So the SE is the expiration date and time for this SAS, and the ST is the start time. Finally, we got signed protocol. So we're going to say in this case, we've got HTTPS as the signed protocol. And finally, as you can see, we have signature, which is SIG equals, and then the whole hash that we have after it. And that's really important because this is used to authenticate the request made with the shared access signature. So hopefully you can see, when you look at it as a whole, it's like, oh my God, what am I getting into? But now if you look at it, you can say, okay, this is really just breaking down. These are the permissions. This is kind of identifying what you can do on the object or what I can do on the container. And, the signature is what really authenticates the whole thing at the end. Now you might be thinking, well, that's great, but this could get a little bit cumbersome managing all of these shared access signatures that are out there. And so Azure provides something called stored access policies. And this is a method for control in SaaS. It's a group shared access signatures and provides additional restrictions. Now, the good thing is they can be used to change the start time, expiry time, permissions, or you can even revoke it after it has been issued. It is, however, only supported on service SaaS. So for blob containers, file shares, queues, tables, etc., but not on the storage account as a whole. And you'll see how we configure that in the subsequent demonstration. But hopefully overall, this gives you an idea of some of the ways you can manage access, but check out the demo and then hopefully that'll kind of solidify the knowledge you need for the exam here. Let's go ahead now in this demonstration and create and manage our shared access signatures. So let's head over to the Azure portal, and in the portal, we're going to use the storage account SLSAS demo. So we'll select that one. And in there on the left-hand side, you can see we have our access keys and shared access signature. So I'm going to show you access keys first of all. This is very important because you have two access keys associated with your storage account. And if you want to, at any point, you can regenerate your keys. Now, the reason they give you two is because if you need to regenerate your key, you can move everything over to key 2, make sure everything's working, then regenerate key 1. Because what happens is when you regenerate your keys, all those shared access signatures that we create will no longer work. Now, if we go over to shared access signature, we can now create one for, let's say, our blob store. So we can say, okay, we want to allow services for blob, but we don't want file, queue, and table. We're going to give full permissions to the resource. And if we scroll down, now we select the start and expiration date. So hopefully you saw in the previous module description around our shared access signatures, this is where it'll create that start and end time. And sometimes it helps just to create one an hour in the past for your start time, so you know it's immediately going to be accessible, actually even further, just depending on your time zone if you're worried about that. You next have a section on allowed IP addresses. So if we want to restrict access to specific IP addresses, we can do that here. This could be a single IP or it can be a range. Our allowed protocols, so HTTPS only is the most common. And then you can see at the bottom here, we have the signing key. So we can choose to sign this shared access signature with key 1 or key 2. And as long as we don't regenerate that key, this shared access signature will continue to work. So let's go ahead. Let's use key 1. Let's generate the SAS. And if we scroll further down, you can see our SAS token and our specific blob service SAS URL. So we could grab this token now. If I hit it there, go ahead and put it into one of our images that we have in already loaded. And let's go ahead and grab that image.jpg, paste our token there at the end, and our image comes up using the SAS token that we've created. But this can obviously be a little bit cumbersome because, you know, we've got to now manage this shared access signature. Would have created 10, 20, 30, 40, 50 of these. How do we sort of deal with that? And so the policies that I mentioned previously are a great way to do this. And if we go over to Storage Explorer, in Storage Explorer, we can right-click our container and we can select Manage Access Policy. So in the section, we can create a new access policy. We can give it a name. So let's call it Images 1 Day as an example. We'll start it today. We'll end it to 2018 in this example. I choose the permissions again at this point, and I select Save. Now, by itself, the policy doesn't actually do anything. What I need to do is when I create my shared access signature from Storage Explorer, I can reference that specific policy. So now if I go back over to the container, right-click it, and choose Get Shared Access Signature. At this point, I can drop down and select my access policy, and it's going to put in the start and the expiration time as well as the permissions that I selected in the policy, and I can go ahead and create that, and now I get that shared access signature, which ultimately is referencing, you can see there in the query string, the policy. And the good thing now is if I want to change the expiration date, I can simply go ahead and change the policy, and that's ultimately going to expire the shared access signature because it's relying on that policy. And with that, hopefully this gives you an idea of how you can control access to your containers, images, etc. using shared access signatures, but in combination with policy. The last thing we just want to cover briefly in this module is around encryption keys and Key Vault. And Key Vault is a service in Azure that you can use to store secrets and keys, etc. that you might want to use. And you could certainly take the key from the storage account, put it in Key Vault, and so when you want to access it, you open up the Key Vault, you get the key, and you use it from there. Now, for added assurance, when you use Azure Key Vault, you can also import or generate keys in hardware security modules. That's HSM. So on the bottom right of the screen on the slide here, what you see are the customer managed keys which can be put in Azure Key Vault. They can be used to wrap and unwrap the wrapped account encryption key for something like storage service encryption, which ultimately is used under the covers for the storage account. And you'll see a little bit more about that later on. But for the purposes of the exam right now, know that you can use Azure Key Vault to store your keys, and know that it is possible to bring your own customer managed key as well. One of the other things you need to know for the exam is your ability to use custom domains for your URL. So instead of saying, for our storage account, we may not want it to be blob.core.windows.net as the domain suffix there. In my case, I might want to use Skylines Academy and take me directly to the storage account. Say if I want to reference a specific blob, then I could have skylinesacademy.com/name of my container, like we had images, demos, and things previously, /my blob. Or perhaps I just want to be able to reference the container itself. And custom domains allows us to do this. And ultimately, you can do this for storage and CDN. So we can do it for blob.core.windows.net, or we could use it also for the Azure edge.net domain. And there are two ways ultimately to do this. At the end of the day, we're creating a DNS record with our DNS host provider that we're mapping a CNAME record there. And there's two ways, like I said, you can do, your domain directly. So in this example, we can map skylinesacademy.com to say SLDSC demo, which was one of the storage accounts we had previously, .blob.core.windows.net. This method is the simplest, but it results in a brief downtime because Azure has to verify the domain registration. Now, there is another way to do it, but it involves an intermediary step, and it's the use of the AS verify subdomain. So I could say take verify.skylinesacademy.com, point it to asverify.sldSCdemo.blob.core.windows.net. No, that's a bit of a mouthful, but once that step's completed, you can then create a record that points directly to sldSCdemo.blob.core.windows.net. But there's no downtime now because we've already verified using that subdomain. So we've used verify.skylinesacademy.com temporarily, make sure Azure kind of recognizes our domain, does all the verification, and then everything's good to go from that point of view. So you just need to know that there's two options here for the exam. And you may be asked, how do you, eliminate downtime? And the answer is to use the AS verify subdomain. And, you may see a few questions on that. Let's now shift our attention to business continuity, and this is all about keeping the business running, keeping the applications running. We do have outages periodically in IT, and what are the things that we can do? What are all the levers that we can pull in order to make sure that our application stays running in the event of these outages? And first of all, let's just start to look at some of the DR, disaster recovery considerations that we really need to think about. Well, one, what if there's an Azure complete regional outage? So that's in the event, perhaps you're in North Central and something catastrophic happens and the whole region exhibits a failure. Microsoft actually had a problem in South Central not that long ago where there was a region issue with the power, and that region did go completely down. Customers who had a plan in effect failed their data and services over to other regions, but customers that didn't have that plan and everything had to run in that region experienced that outage. All the services were restored once Microsoft got the data center back online, but something you absolutely have to consider can actually happen. Next, we have an Azure service outage, and this is considered a single or multiple Azure services, i.e. this could be Azure SQL that's experiencing disruption in availability. During these outages, the service could be down across all regions, resulting in reduced or complete, loss of functionality of the application. Now, in the event of a service outages, alternative services, perhaps on premises, or perhaps you were using a PaaS service and you move to an IaaS service as your backup. There are multiple ways to deal with that, if in the event that you do need to plan for it, or you just accept the SLAs that come with that particular service and plan accordingly and accept the specific risk, which is actually what a lot of customers do. Then we have an Azure-wide outage. So the possibility of this, is pretty rare, but would result in the complete loss of functionality across all your Azure services. So you could plan a recovery strategy that you could still potentially run on premises or in another cloud in the event that happened. But obviously this hasn't happened yet, but something you still need to consider, and think about when planning for your workloads. Then we have individual workload issues as well. So, what we've talked about so far are what can affect Azure as a whole and the specific Azure services as a whole. But what about your individual workload? This could be your specific virtual machine gets compromised and needs to be restored from a backup. This could be something where you haven't configured your individual workload correctly, and perhaps, the performance starts to get degraded because too many users are hitting that service, and now that service falls over. So think about this in the broad spectrum, from, hey, Azure could go down, a particular Azure service could go down, we could have this Azure-wide outage, or, hey, I just got an individual workload that is part of an application and that is having an outage. So those are the four main areas to think about as you think through disaster recovery. If we look then at some of the ways we can tackle this, well, we have region pairs to begin with, which really protect us against those Azure region outages. And Microsoft has the concept of region pairs, so they know that, hey, when we do maintenance on one of our data centers, we're not going to do anything to the paired region at the same time. Good example, this is West US and East US, North Central and South Central, East US 2 and Central US. There are multiple paired options available that should meet your requirements. In Europe, there are pairs, in the China region, there are pairs, multiple options available for you there. But essentially, Microsoft, again, isn't going to do maintenance on these two at the same time. So the chances of them, impacting that region because they, introduced a bug, in say West US, it's not going to propagate to East US until they come around, weeks later to patch and update that specific region with the maintenance they need to do. So plan accordingly. What you don't want to do is choose your two regions as a non-pair, because then you could be in that situation where you're impacted because both regions are being, having maintenance performed on them at the same time. Then if we look at some of the business continuity strategies as a whole, well, high availability is one. So this essentially is we run another instance of our app in case of a catastrophic failure. That can be globally highly available, and we can talk through some of those scenarios shortly. Or it could be as simple as, hey, I've got two VMs in a data center. I want them to be in different racks, and there's something called availability sets for that. Or they're in the same region, but I want them, to be in separate data centers in that region. That's availability zones. So multiple options, for high availability there. Then we have disaster recovery. So this is saying, hey, okay, I'm running these applications in this data center. They're going to run hot the whole time, but perhaps I want a secondary standby where I can fail over maybe it's my virtual machines, maybe it's a mixture of VMs and PaaS services. I want to fail them over to another region. Perhaps I've got that region pair, I'm in North Central, and in the event of an outage to North Central, I want to be able to fail over. Well, site recovery or disaster recovery with something like Azure Site Recovery is a good way to go about that. And then going back to those individual workloads, or perhaps I've just lost some files or data, there's still backup. That when we think of highly available disaster recovery, those are, great, but they don't necessarily give us the option just to restore a file or something like that. They're more concerned with the availability of the service. Backups still are relevant because in the event of some kind of corruption, we can essentially restore from backup. If we look then at this high-level view of, an application architecture, where we've got here Azure Site Recovery for a service that's running in Region 1, and then in Region 2, we have a disaster recovery site. And if we look at Region 1 to begin with, this kind of includes a whole bunch of services that you could potentially use to ensure high availability of your application. For one, we have a public IP on our two web front-end servers here, and they have a load balancer associated with them, so traffic's going to come in and be spread across those two servers. They're in an availability set, which you'll learn more about when we cover the VM section in more detail, but that essentially means that Web 1 is on one set of servers, Web 2 is on another set of servers in the Microsoft Data Center, and so those racks in Microsoft aren't going to be patched at the same time, so we've got some availability there. As we come down, we hit a load balancer again. When the web servers want to talk to the app servers, again, they are in an availability set, so they are not on the same running host. In the event of a failure to the host, app 1 might go down, but app 2 would be available, and app 1 would be spun up on another underlying host. Same thing with the database servers, and in addition, you can see we've got two database servers. They're in an availability set, but they also have replication enabled, so the data is being replicated. And finally, we can see the disks there. They are also being replicated across, which we'll come on to in a second, to the second region. So in the event, we had a storage outage here, we would be able to bring the data back online. So all of this, comes together and gives us this 99.95% SLA because we have VMs running in availability sets and we have replication of data. Well, what happens in the event of that entire region outage? Well, for one, all our traffic is coming through the internet and hitting a traffic manager first of all. So we're not going directly to region 1 to this public IP. First, we come to a traffic manager and traffic manager says, hey, yep, the current online region is this one, go to this public IP for your traffic. And then the user goes directly to that particular region. In the event they can't hit that region, when they hit their traffic manager and everything's failed over to region 2, traffic manager is going to point them to this other region. And essentially what we have here is Azure Site Recovery is going to replicate and take care of all the recovery workbooks, and you'll learn more about Azure Site Recovery very shortly, and take care of making sure we can fail over to another region in the event we need to. Now, when you think about the other region, you do still have to think about your network and subnetting and everything over there as well. So what that means is, when you're designing your networks, you've got your VNets, subnets, any shared services, anything else that your application depends on, you do need to worry about that as well. And so, we'll cover networking again to recap it. Obviously, hopefully you know a lot of it from AZ300, but you still need to design those networks, design that subnet space in region 2, and you might get some questions around that on the exam. But look at this as a whole, because I think this is a great picture, great view in terms of, how a full site recovery solution might look, particularly for some VMs, and these are the kind of things you'll get questions on. In order to fully understand ASR, let's take a quick review of the business continuity strategies. Well, for one, we have high availability that you probably heard about in the AZ100 or just when you're looking at virtual machines. And that's where we use availability sets or now availability zones, so we can make sure we have another instance of our application running in case of a catastrophic failure. In addition, we have the concept of disaster recovery, and this is where ASR really fits in because we can run our apps in a secondary data center if failure occurs. And this is also the same technique now that can be used for migration, because if we're able to recover it somewhere else, it's also a way we can migrate it somewhere else as well. And finally, we have backup also in the event that we need to restore data, perhaps the files become corrupted, or perhaps we do want to restore our data into a new machine in another data center or another Azure region. Backup is a fundamental way you can do that as well. But if we look more specifically now at Azure Site Recovery, also known as ASR, that's an acronym you should become familiar with. There's a number of key features. For one, you probably know it as an on-premises to Azure recovery tool or migration tool. It allows us to take VMware workloads, Hyper-V workloads, and replicate them to Azure for recovery or migration. It does Azure to Azure recovery as well, so we can take our workloads from a primary region in Azure and replicate them to a secondary target region. This allows for the case of a complete region failure. If we have an application that has to be highly available at all times and we want it to be recovered elsewhere, we can set that up also. One of the features I love most about it is just the automation and orchestration integration. So there are recovery plans that you can build that dictate, say, the order in which services come up, but also you can run scripts or you can integrate with Azure Automation to access additional things that you want to run after services come up. These could be re-IPing, it could be just running something around services that you're starting up on your OS. Those are all things that are possible. And finally, there are RTO and RPO targets. There's this concept of continuous replication for Azure, and that's from VMware and Hyper-V as well. If we look at ASR replication frequency, there are 3 you need to know about. You can do 30 seconds, 5 minutes, or 15 minutes for your replication frequency. So every 15 minutes, it will replicate that data up to Azure as an example, but you can go as low as 30 seconds. For VMware to Azure recovery, let's look at what this means, because this is the most common scenario, and the scenario you definitely need to be aware of for the exam as well. We've got our VMware hypervisor running on premises. If you saw the Azure migrate module that we covered, that showed you that, we could have loads and loads of VMs out there that we've sort of assessed and want to migrate them because we think, okay, there's a cost benefit or some good use cases to do that. Well, ultimately, we need to get them to Microsoft Azure, and that's what the VMware to Azure recovery or migrate option is essentially, allowing us to do. Well, the process for that is as follows. It converts the VM to a VHD, it uploads it to Azure, puts it in a recovery vault, and that's where you complete your migration. So very simple process in itself. You're taking a VMware virtual machine, which is based on what's called a VMDK file. We're converting that to a VHD and then running it on Azure Compute now instead of the Compute, rack-mounted servers that we would run in our data center. The migration process that you need to go through and do need to understand for the exam as well is as follows. You do need to prepare Azure, prepare VMware, and then set up recovery. And we will walk through all those steps in the subsequent demonstration so you can understand. So for preparing Azure, you need to understand the following. You need to verify your account permissions in Azure itself. So can you create a VM in a resource group? Can you create a VM in the selected network that you're going to connect this VM to? And can you write to the selected storage account? And again, we'll go through those in the demonstration. You'll create a storage account. You'll create a recovery services vault, and you'll set up that Azure network. Those are the prerequisites that you do need to have in place before you begin, and those are all on the Azure side. On the VMware side, we need VMware permissions also, which we do reference on the next slide, and you can also see referenced on the link below. We need to prepare an account for mobility service installation, so that allows us to install the agent in the machine. We need to verify compatibility, so you do need to make sure there's a whole support matrix, from Linux VMs, Windows VMs, all our post failover configuration. We just need to understand what's going to happen when we move our machine over to Azure. It'll replicate, it'll probably come on fine. In some cases, you just need to try it to see, but you do need to have a plan for that recovery as well. And that really is around this preparing connectivity to your Azure VMs as well. Once you've recovered a VM in Azure, can you connect to it? Do you have hybrid network connectivity set up back to on-premises if that's something you need to do? Can my users, perhaps point to site VPN into Azure to access those VMs? Or do I have a jump box of the public IP? Those are scenarios that you need to understand, when you're thinking about your environment and how you're going to get those VMs over from VMware to Azure. Here are the account permissions. We're not going to go through all those in detail in the course here right now, but definitely take a look at this. It'll be referenced in the study material as well. But a few quick things. You do need to be able to discover VM objects in your VMware environment, and then to do full replication, failover, and fail back. You'll see there's a whole host of permissions that you need there on virtual machine configuration, creating virtual machines, allowing download of virtual machines, snapshotting, all those things, are required for this to be successful. So with that said, this is the overview of Azure Site Recovery and should give you, the basics you need to understand to get this going. And like I said, check out the upcoming demo and we'll walk through this in more detail. In this demonstration for Azure Site Recovery, we're going to look at preparing the Azure services that we need in order to start that recovery from our VMware environment. So to begin with, let's head over to the Azure portal. Okay, and here we are in the Azure portal, and the first thing you can see is I'm already in a new resource group called SL-Azure Site Recovery, and that's the resource group we're going to use to put in the objects we need to create. To begin with, we need to create a storage account. So we'll go ahead and go to All Services, type Storage,
select storage accounts, and we'll click add to create a brand new storage account. So we will put this in our subscription. I'm going to put in my Skyline's primary subscription. The resource group I'm going to select will be SL-Azure Site Recovery for this demonstration. And I'm going to give it a storage account name. So we'll call this SL ASR1. I'm going to put that in North Central US. Performance, I'm just going to use standard disk for this one. And for account kind, the recommendation from the ASR team is actually to use GPV version 1. So we will select that. And then I can choose my replication option. In my case, this is just a demo. I don't need, geographic replicated storage. I'm just going to have locally redundant storage in the data center chosen. So we'll click next to go to the advanced settings. Nothing we need to select there at all. If we wanted to do a virtual service endpoint, this is where we would do it for storage accounts, secure transfer required, and data lake stuff. None of that's relevant for us right now. Tagging, always a good practice, as you've probably seen in other modules that we've covered or other courses where we've covered tagging. Nothing we need to do right now. We can simply click next to review everything we've got there, and we're just creating a basic storage account. Again, just make sure it's that GPV version 1, give it a name, put it in your resource group, and you're good to go. So go ahead and click create. Okay, and that will begin deploying. While that's underway, we will get started on the next piece, which is the Recovery Services Vault. So we'll go back to All Services, and we will type in Recovery Services Vault. And you'll see Recovery Services Vault comes up, and click that. You can see that storage account has successfully deployed. We'll close that out for now. And I've got a previous Recovery Vault in there already, but I'm going to go ahead and create a brand new one. You can have multiple Recovery Services Vaults in your Azure subscription. So we'll call this one SL-ASR Vault Demo. And I'm going to put that in the same subscription. I'm going to put it in the resource group again, SL-Azure Site Recovery. And I'm going to keep it in North Central US and click create. That will go ahead and create our Recovery Services Vault for us. And finally, I do need to have an Azure network that I'm going to connect my virtual machines to when they get recovered in Azure. So I need to create one more service, which is our Azure network. And I'll just click create a resource this time. I'll type in virtual network. Select virtual network. As you can see, while we're busy there, the Recovery Services Vault alert popped up to say that's been created. I'm going to go ahead though, click my virtual network here, and click create. And it's now going to ask me some questions around virtual network creation. And we'll give that a name, so we'll call this SL-ASR VNet. We'll give an address space, we'll just go 10.1.0.0, we'll go /24 there. And that's going to give us up to 256 addresses in that virtual network. Again, I'm going to put it in that same subscription. I'm going to put it in that same resource group, SL-Azure Site Recovery, North Central US. I'll give it a subnet, so we'll call this Recovery Subnet. And I'm going to give it a range, so we'll go 10.1.0.0, and we'll start with a /26 as an example. We'll start to carve that VNet out. So the subnet inside of that VNet is going to allow me 64 addresses. These other settings aren't relevant for what we're doing right now. We're not going to create any firewalls, any virtual service endpoints, any DDoS protection. Everything is standard there, so we'll simply click create. And that deployment is now in progress. So we'll head over to our resource group while that's going. And we'll go down to SL-Azure Site Recovery, click that. And in there, and it looks like that VNet's almost done. We'll probably see the alert pop up any second. We'll just click refresh, and we can see we have our SL-ASR1 storage account. I've got the vault, yep, and you can see that virtual network is completed. SL-ASR Vault-Demo, and my VNet, I've got SL-ASR-VNet, and if I click into that virtual network, it should all be completed. If I click the subnets, we'll see that subnet, the recovery subnet, is there as well. So with that, this completes this demonstration, and in the next demo, we'll look at our VMware environment and how we set up a VM for recovery into Azure. In the previous demonstration, we set up the necessary requirements on the Azure side so that we can perform Azure Site Recovery. In this demonstration, we're going to look at the additional steps we need to take to set up recovery from VMware. So let's begin in the Azure portal. In the Azure portal, we're in the resource group SL-Azure Site Recovery that we created in the previous demonstration. And you can see I've got my storage account, Recovery Services Vault, and virtual network there. I'm going to go ahead and click the Recovery Services Vault first of all. And once it comes up, you'll see you have the options of Backup and Site Recovery. Select Site Recovery, any replicated items that are in effect will show up over here, and recovery plans, etc. will be at this place as well. At this point, on the left-hand side, you'll see a Getting Started section for Site Recovery, which we'll click first of all. And at this point, you can see it says for on-premises machines, prepare infrastructure. So let's click that, and then we choose our protection goal. Where are your machines located? In our case, on premises. Where do we want to replicate those machines? Well, to Azure in our case. The other option would be to a recovery site, but if we are trying to do a migration here from on-premises to Azure, which hypervisor are we using? So yes, it's VMware vSphere hypervisor, but a Hyper-V would be an option as well as physical. If we click OK, it will then ask us for deployment planning and how we run the ASR deployment planner. You are required to do this. This gives additional information on bandwidth utilization and storage requirements, etc. So you can say you've done it if you have, or you can run it later on. It's not completely a requirement, but is recommended that you do it so you can, really understand the capacity requirements for your recovery itself. Click OK on that. Now we can go ahead and prepare the source environment. It says select configuration server. So right now 0 servers are found. We have to add a configuration server, which we'll do by clicking this plus sign for configuration server. And at this point, you'll see we have to register our on-premises server from VMware, and that requires, just like with Azure Migrate, if you saw in the very first module of the course, around downloading that OVA file that we deployed to vCenter, same principle here. We have to download a virtual machine template. It's about a 20 gig file that you download and install in your vSphere environment. So let's hop over to VMware and have a look at how you deploy that. Okay, so here I am over in VMware, and I'm already connected to Virtual Center, also known as vCenter. If you're not familiar with it, vCenter is a management tool that's required to look at your VMware hosts, folders, VMs, etc. that are running, and VMware is obviously beyond the scope of this Azure course. But to begin, I need to deploy that OVF template or that OVA file that I downloaded. So I can go ahead, look at my downloads folder. If I go in there, and you can see I've already got Azure Site Recovery configuration server.OVA. That's the file I downloaded. As you can see, it's about 23 gig in size. If you're not familiar with where to get that from, just go back over to the portal and click this download link where it says download the configuration server virtual machine template. That's what that file is. So back in to vCenter here. And what I need to do then is go to Actions. I've got a folder here you can see called AZ Ready. That's the one I've already deployed to show you once this is done. But I'm going to go and select AZ ASR Demo. This is just a VMware folder in vSphere. And I'm going to go ahead and click Actions and click Deploy OVF Template. And when I select that, that will prompt me to select the file. So I'll choose Local File, click Browse, choose that Site Recovery Configuration OVA Template, click Open, click Next. And now I need to fill in some information, so I can call it, AZ ASR Demo 1, could be the name of my virtual machine I'm going to create from that template, because again, that OVA file is a virtual machine template that gets deployed. If I click Next, I will choose the host where I want to run that, so I can choose the cluster or the specific hosts again if I want to, but we'll choose the cluster. That means VMware will decide which host it goes on. Might take a moment to validate. And once it's validated, you'll just need to review the details and then select the storage. So we'll click Next to select storage. Again, I can choose thick provision, lazy zeroed, or thin provision if I want to. So I'm going to choose thin provision for right now. I don't want to provision all that storage up front. Click the Tintry T880. That's just my storage array that I've connected to VMware. And that's where I'm going to place the virtual machine. Click Next. Select your network. In my case, I'm just going to choose VM network for right now. Click Next, and if everything's complete and you're happy with everything, then just go ahead and click Finish. Well, I'm actually going to cancel out of that right now because I do have one previously created. And if we go over to AZ ASR Ready and select this machine, this one's powered up now, and I can now connect to it. And once you click it, the usual thing pops up. This is a console into the virtual machine. And I'm going to accept the license terms there, type in a password. This is just the initial setup for the appliance, as it's a Windows machine. So once you give it a password, then you'll be able to connect into it. So I'm actually going to RDP into it because it's a lot easier than using the VMware console itself. So we'll grab that IP address, which I get from the vSphere console, and then I'm going to open a new RDP window to that IP address. Okay, so here I am RDPing into that new machine. Now it should pop up automatically, but if not, just double-click the Azure Site Recovery Configuration Manager, and this will ask you to enter a name for your machine. So I'll call it AZ ASR01, and then sign in to Azure itself. So we'll click Sign In, log into Azure as normal. And once that's signed in, you'll see it continue, and just make sure you are connected to the internet for that step to work. But once you're signed in, it shows that it's connected. I can see Skylines Academy there. Click Next. And it's going to configure the machine name, and ultimately it's going to add it to that Recovery Services Vault for us in a moment. So once all those certificates are completed, you just need to reboot, and that'll take about 30 seconds before it happens automatically, or just click the icon on the bottom right. Okay, now after that reboot, as soon as you log back into the machine, you'll be prompted with this window for Internet Explorer 11 that pops up. Don't need to confirm anything around the security settings there, but go back to the main tab that popped up, and this is the wizard that will actually help you connect it and finalize the connections back to Azure Site Recovery. So you're now connected to the internet. Now we've got to select our network interface card. So, we can select the one that's popped up there, which is the only one I've got connected. If we scroll further down, just click Save on that first of all, and then Continue. And now we have to select our Recovery Services Vault. So we do need to sign back into Azure again. So it's got our account there. And it will prompt you for permissions for ASR, which I quickly clicked Accept there. And you click Subscription. So again, now it's pulling all the details from Azure. So I've got my resource group for Azure Site Recovery. And now I will see my Azure Recovery Services Vault listed there as well. So again, this is exactly what we created earlier on when we were preparing Azure for site recovery. Now you note this, once configured, you cannot change the vault to which this configuration server is registered. So every configuration server that you deploy that's with that VMware appliance is registered as a specific configuration server for that vault. So go ahead and click Continue. You'll need to install some third-party software. Just click Accept, download and install. And then wait for that to complete before we can go on to the next section. So we'll fast forward here again. Okay, and that's completed. We'll continue. Just checking everything out there. Again, you're supposed to put a static IP address in, but we're just going to click Continue for right now. And now I need to add my vSphere, my vCenter that I want to basically connect to. So we'll add vCenter. Okay, now vCenter is added. We'll click Continue. And this is where you can add virtual machine credentials, and this is for that mobility agent that needs to be installed specifically on machines themselves. So I can add credentials here. In my case, I'm just going to choose Windows operating system. So these are just going to be generic admin credentials, so administrator and a password. And this is essentially a local user account on those machines that has backdoor access that I'm going to be using. But you do need to make sure whatever these credentials are, they need to have access to all the machines that you want to be able to migrate into Azure, because it's going to log into those machines to do various tasks. So we click Continue. Looks like you do not want to protect virtual machines running Linux operating systems. Do you want to continue? And that's just because I've only put in a Windows credential there. And in my case, I'm actually only going to be doing Windows machines. So I'm going to say, yes, I want to continue. So I click Finalize Configuration, and it will now complete that configuration step. Okay, and after a while, as you can see, everything is completed successfully there. The appliance has been successfully configured. So let's go over to the Azure portal and verify everything. Okay, so back in Azure, we'll click our Recovery Services Vault again and continue the steps that we were going through earlier. If we go to Site Recovery, click Prepare Infrastructure, choose our protection goal again of protecting on-premises machines to Azure with the VMware Hypervisor. Plan to do deployment planning later. And for source now, you can see select configuration server AZ301. That's the machine we deployed in our VMware environment is showing as ready. Now the step 2, select vCenter server vSphere host. Well, vCenter discovery is in progress, so we'll fast forward again here while that completes. Okay, now that's complete. We can select our vCenter. Again, we've only got the one for this demonstration. Click OK. And now we have the option to prepare. So in this case, if we look, we've got our Azure subscription. So we're going to use Skyline's primary, select the deployment model. I'm going to use Resource Manager. We're not going to do anything around Classic. And pretty much don't need to worry about Classic anymore. If you do hear it come up every now and then, Classic is before Azure went over to the ARM, which is the Resource Manager method for deploying resources. We need to make sure that we have at least one compatible storage account that exists. It's found 2, which are available, and ensure that we have at least one virtual network, which we've got one that exists there. So we can go ahead and click OK. Everything is prepared on the Azure side. Now we need to go and create a replication policy. So let's go ahead and click Create and Associate. And we'll give a policy name, so we'll call this ASR Policy Demo. We'll choose the source type, which is already selected for us, so VMware Virtual Machines, and the target is Azure. Here is our RPO. This is the recovery point objective. So this more specifically means if we did have a disaster what level of data can we guarantee would be recovered. So 60 minutes means, okay, we might lose 60 minutes of data, or potentially 60 minutes or under, but our recovery point is 60 minutes. So that'll make sure that recovery and replication take effect in a way to preserve that amount of data. We then have recovery point retention. This is a number of hours the recovery points will be retained. And we also have app consistent snapshot frequency in hours, which you can select as well. And you can click this drop down and you can go from anywhere from 1 to 12, or just turn it off completely if we're not using app consistent snapshots. Then we have our failback replication policy name that's filled in automatically for you. And you can see here it says a replication policy for failback from Azure to on-premises will be automatically created with the same setting. So that's if we wanted to do a failback to VMware. Let's say we recovered in Azure temporarily because we had a disaster on-premises and then eventually we want to fail back. That's where this policy is important. So we'll click OK, and that will go and create and associate that policy. So again, it'll take a little bit of time here while these things complete. So we'll fast forward again here for you. Okay, and that's all completed. So simply select OK. Click OK again. And now we can replicate our application by clicking step 1 over here and configure our source. Our source on premises again, our source location is at AZ301. That's our collector server on premises that we deployed in VMware. Virtual machines, vCenter, and then process server. We'll choose that AZ301, which is basically the inbuilt process server. That's a service installed on that machine. At this point now, I'm going to click OK and configure the target environment for Azure. So if we go through, we've got our subscription, which is Skyline's primary. The post-failover resource group, I can select here as well, which I'm going to choose SL-Azure Site Recovery. The post-failover deployment model, so again, I'm not going to use Classic for anything. We're always going to be using Resource Manager. The storage account, I can select here, so I can choose a different one if I want to, SL-ASR1. You will notice these values are pre-selected for you if you've gone through this step once before, but this is where you would change it. Same for your Azure network. You can configure this now or later, but we'll choose now, and I can choose the virtual network, in which case I've selected my VNet. So this is nothing more than just selecting that VNet that we created before, and then the subnet. Same for your Azure network. You can configure this now or later, but we'll choose now, and I can choose the virtual network, in which case I've selected my VNet. So this is nothing more than just selecting that VNet that we created before, and then the subnet that we wanted to go to. So we've got that recovery subnet there. And if I click OK, now I get to choose the virtual machines I want to recover. So I've got a couple of machines in mind. They're 2 jump box machines, just basically Windows servers. We'll select those. Those are the machines I want to replicate. Click OK. And now I've got some additional properties I can select. So if I want to choose credentials for those machines, I'm going to use those admin credentials that I have. Click OK. Those are the ones I entered earlier. And then proceed on to the final step here, which is our replication settings. And that's that replication policy we configured. So I've got my RPO of 60 minutes, my recovery point retention of 24 hours, and if I was doing app consistent snapshots, it would be 60 minutes. And if I go ahead now, actually one more thing just to cover multi-VM consistency. Do you want to enable multi-VM consistency by creating a new replication group? And that's to allow like phased, recovery of groups of virtual machines themselves. I don't need that right now, but if you were doing actual real world scenarios, you would do things in waves and you would create, multi-VM consistency groups where appropriate. But I'll click OK. And now I click Enable Replication, and we will see those tasks in progress and fast forward here while they complete. One thing you can also do is select the task where it's actually enabling protection. So if we scroll up on the event log here, I can click Enabling Protection, and this will actually take me to the site recovery job, and you can see what it's actually doing. So you can see it did a prerequisite check, and now it's installing that mobility service and preparing the target. Then it's going to enable replication, start the initial replication, and then update the provider state. So again, we'll fast forward at this point, but just wanted to point that out in case you're trying to troubleshoot anything, at this stage. We'll just want to see, where it's actually at from that perspective. Okay, now fast forwarded ahead again here, and you can see that for AZ Jump 02, this is one of our Windows virtual machines that we're replicating. That is completed as well. All the tasks have been successful. The agent is installed, replication is enabled, etc. If we go back over now to Azure Site Recovery, so I'm going to go to my resource group, select Azure Site Recovery, and have a look at the jobs overall. And I've deliberately set one up to fail here. So if we go to ASR Vault Demo on the right-hand side, which is our Azure Site Recovery Vault, and if we scroll down on the left-hand side, we've got replicated items that you can see here. And there are two in this. You can see AZ301 shown as healthy, status protected, but AZ301 did not replicate successfully. Well, what is the reason for that? And it says protection couldn't be enabled. If you click into this, and what you'll see in there is an error message, which basically is saying that the mobility service agent could not be installed, and that's probably because the username or password is incorrect. So the administrator account on that machine has a different password set up, and that's why it was unable to install the agent. And in that situation, you could go and install it manually, or you could provide additional credentials to Azure Site Recovery so you can remedy that. But if we go back over and look at the one that did complete successfully, so if we go over to AZ301, at this point, we should get some additional status around it. Its current RPO, as you can see, it's currently looking at 6 minutes right now, so we'll have data loss up to 6 minutes if we had to recover that machine. Replication health is healthy, and you can see on the right-hand side, we've not performed a test failover yet. So if you ever try to do a failover, it will warn you that you've not completed a test failover, and you should do that before you complete an actual failover. A test failover is just that, a test. The original machine will continue to run in the VMware data center, but a copy of it will essentially begin running in the Azure network that you specify. And to do that, you just click test failover on the top. And on the right-hand side, this will pop up in a second, you'll choose a direction, which is grayed out for you, obviously, because you're going from VMware to Azure. But if you had other data center options, then you would have choices there. But for right now, we're going to choose our recovery point, so it'll automatically select the latest processed low RTO option for you, but you could go to the lowest RPO option if you want. If you're unsure again of the difference between those, so RTO is recovery time objective, so that's the lowest time to recovery, and RPO is the lowest point at which we would have data loss. So essentially, that's that 6 minutes, RPO there. But for right now, we'll just do low RTO, select the virtual network, scroll down, and click OK. And at that point, it starts a test failover of AZ301, and in a little while, that machine will begin running in Azure. So we'll fast forward again while that completes. Okay, fast forwarding again, and that's now completed. If we go over to the alerts on the top here, and we click the notifications, scroll up, and we can see starting the test failover of AZ301. If we scroll down in the details here, again, it's a little hard to read sometimes, so we'll move this over. And you can see it did the prerequisites, completed the test failover, created the test virtual machine, and has successfully started that virtual machine as well. So if we go over to virtual machines, we should see that AZ301 with -test on it, because again, this is our test failover. And if we connected it to a network that I had access to right here, we would be able to connect to that machine. But I can do all the other things I want to do, like restart, stop, etc., all the usual pieces that would normally take care of. Now, if I go back to Azure Site Recovery, so we'll go back to our resource group, and I will select Azure Site Recovery, select our Recovery Services Vault, and if I go in here and select that virtual machine, so if I go down on the left-hand side and look at your protected items, that's replicated items here, click that one, and then you can see if we go into AZ301, we have that test machine running, which we now might want to clean up, right? If we're actually going to do a real failover, we wouldn't really be using the test machine, because the source machine is still replicating to Azure at this point. So what we would want to do is clean up our test failover when we're done. Just say testing is complete. Test was successful, and then click OK, and it will go and clean all of that up for you. And with that, that completes this demonstration. I know this is a bit of a long one here. There's a lot to know in all of this. So just, make sure you read the follow-up in the study guide, understand what's involved, not just from failover and recovery, but even just all the way through from migrate assessment. So running Azure Migrate is just one of the earlier modules. Then you perform in full Azure Site Recovery and know about the different recovery options that you have. Most of the exam questions will probably be focused around VMware, but obviously we can't guarantee that. Things are changing all the time. But hopefully this gets you going. Before we get into the specifics of Azure Backup and Azure Site Recovery, it's worth first understanding the different business continuity strategies that are available. So the first one is high availability, and we talked a little bit about this in the virtual machines module. This is really the case where we run another instance of apps in a case of a catastrophic failure. So maybe a blade on the first rack of servers goes down, and we've got an availability set configured for our virtual machine. Well, that will fail over to another set of hardware. That's basically our high availability option. In addition, we have disaster recovery. This is where we run our app in a second data center, so that if a failure occurs to the primary, the secondary is still online, the app will still continue to run. We might get a blip for some users that were connecting to that primary system, but through the load balancing technology, they would be rerouted to the secondary node. And then finally, we have backup itself, and this is where we want to restore data. So we might have our original set of data that's constantly being backed up, and then if something goes wrong with that data, we can restore it, or perhaps we want to restore the entire virtual machine, perhaps in response to a disaster like the previous option, we could then just do a standard restore of that machine. Now, Azure Backup in particular is one of the products Microsoft provides you in Azure, and this is a backup solution that's been purposely built for the cloud and comes with a number of features. In particular, we've got unlimited scaling. Azure Backup will use the underlying power and scale of Azure Cloud to give you high availability, no maintenance or monitoring overhead. You can set up alerts, but there's no real overhead from your perspective to kind of scale up the system. In addition, you get unlimited data transfer as well. So Azure Backup does not limit the amount of inbound or outbound data that you can transfer, does not charge for the data that is transferred. However, if you decide to use some of these import-export services to import large amounts of data, then you might incur some costs at that point. But otherwise, it's a very cost-effective service to utilize. We also then have the multiple storage options as well. So it supports LRS and GRS. If you recall from the storage module, LRS is locally redundant storage. This is where it replicates your data 3 times in a storage scale unit in a data center. Or we can use GRS, which is geo-redundant storage. And this is the default and recommended option because it's basically taking your data to a secondary region. This is hundreds of miles away from the primary region. Costs more than LRS, but if a whole entire data center or region goes down, then you can still recover your data via the other region. Then we have long-term retention, so there's no limit to how long you can keep your data in what's called a recovery services vault that you'll learn more about. You can keep it as long as you like, but you are limited to 9,999 recovery points per protected instance, but that should be plenty for almost everybody's backup situations. Then we get application consistent backups. Now, I would say that Azure advertises this, but it does depend on which service you utilize, and you'll learn about the different services in a moment. Otherwise, they'll be crash consistent if you're not using any of those services in particular. And finally, data encryption, naturally, like a lot of other Azure storage services, is supported to allow for secure transmission and storage of your data in the public cloud. So let's take a look at the Azure Backup components that are available to you as well. Well, first of all, we have the Azure Backup Agent, also known as the Mars Agent. This allows for file level restore, system state restore. It's not really a VM backup, but you'll see this in one of the demos, but allows for file level kind of recovery of services for you. Then you have a couple of others which require servers. So you've got System Center DPM and Azure Backup Server. You might be using System Center DPM already on premises, and you can utilize that with Azure Backup. Azure Backup Recovery Services Vault would essentially become a target for DPM, and DPM stands for Data Protection Manager. It's a service a lot of people have been using for a long time. There's Azure Backup Server, which you can install on premises or in Azure as well if you like. And then finally, Azure does include an IaaS VM backup, which you will see in the demo as well. In fact, the course really calls for the first and the fourth option here. So we'll look at the Mars Agent recovery and the IaaS VM backup recovery in the subsequent demos to follow. Now, if you want to know about how all these different options compare, because it can get very confusing, so we head over to this link, which I'll select. And if you scroll down, you'll see a table, which I'll zoom into. And it says, which Azure Backup components should I use? And it breaks it down by the various options. So for the Azure Backup Mars Agent, what are the benefits? You can see it backs up files and folders. It's limited to Windows only, backup 3 times per day, and backups are stored in Recovery Services Vault. Scrolling down, you can get the details of DPM and all its extra features, Azure Backup Server and all its extra features, and then finally the IaaS VM backup as well and all of its features. So it's a good reference site if you're trying to figure out, well, which is the right option for me. But like I said, you'll see us demo the first and the fourth option coming up very shortly. Now, before we get into those demos, the last thing just to mention is a couple of the other recovery options. I already mentioned we've got Azure Site Recovery, we've got Azure Backup, but there are 2 other options that you can utilize as well. First one being Snapshot Recovery. So Snapshot Recovery utilizes the underlying blob storage. You can essentially do blob snapshots taken of your VM page blob. These can be copied into the same or different regions. You can create a storage account in another region and copy your snapshot across to it, and then you can basically get your VM from that snapshot. You create it from the snapshot itself. It can be application consistent, but only if the VM was shut down. So if you shut down a VM gracefully, take your snapshot, copy it to another region, instantiate that VM, it will be application consistent. Otherwise, it's essentially a crash consistent recovery option. The other option we have is geo-replication, and this essentially allows us to use the underlying Azure Storage GRS option, geo-redundant storage, which basically replicates our data to a region far away from the primary. And this allows us to then recover in the event of an outage to the entire region, or if we just had an outage and we wanted to recover from that data that's been replicated over there. It also has that RA-GRS, that means it's read available, read access is the official term. There's an RA-GRS option available, so if we wanted to, we could just take that geo-replicated virtual machine as an example and power it on in the other region that's warm and ready for us to go, or if we just wanted to read some of the data, we could do do that as well. So these are two other options, a little bit more manual in operation. They're not really automated recovery options, although it is technically possible to do some of that with Azure Automation and PowerShell, but this essentially is more of a kind of a manual recovery type option. Okay, we've covered quite a lot now around recovery, and hopefully you have a good foundation in Azure Site Recovery and some of the backup tools as well. And I thought it's a good thing because, again, the exam focuses on decisions and choices that you need to make. Then we just do a very quick review of some recovery options. Well, for one, just start to think about what you're trying to solve for. So perhaps we're looking at VMs available in the event of a region outage. You need to be then thinking about things like Azure Site Recovery, going back to that first lecture where we discussed the architecture and you could see how, a VM could fail over. Azure Site Recovery gives us that ability to recover in the event of a complete region outage. We should also be looking at things like GRS, geographically replicated storage. That's covered in more detail in the VM section, and that basically allows us to replicate the disks underneath the VM to another region. Perhaps we don't have the budget to do Azure Site Recovery all the time specifically, but we just need to know that, hey, in the event there was a complete region outage, I could bring those VMs back online. I would still need a network, I would still need subnetting, I still might need AD and other services out there, but GRS storage is a legitimate way that we could recover. In addition, we've got individual recovery of data for specific services. In this case, we need to be looking at Azure Backup or third-party backup technologies. Azure Backup is something we can enable directly on our virtual machines when we build them. The backup gets taken, put in that bottomless pit, that recovery services vault, and machine. Look for questions here around, hey, the VM got compromised and corrupted, we've got data loss, those are things we can look at there. In addition, what if I want to do a highly available application across regions? Well, here I need to think about traffic manager, load balancers in each region, availability sets and zones potentially in each region as well, because now I'm designing a holistic strategy, going back to that original diagram that we had in the first lecture of business continuity around, okay, somebody's coming in through the internet, they hit in this traffic manager, it's going to send them to a region. In that region, my application is highly available, and in the event of a complete regional outage, I can fail over to another region. I may also decide with something like Traffic Manager that users from, say, the UK are coming into one data center, they're hitting that particular region to get access to their application, and users from the US are coming in, say, to North Central, because that's where I've decided that they'll get better performance. So just keep that in mind, because it's not always just about availability of the application, it's also about performance of the application as well when you have users coming in from different regions, especially in those geographic applications. In this demonstration, we're now going to go about configuring Azure Backup, and then we're going to backup and restore a Windows VM. So let's head over to the Azure portal to begin. Alright, in the Azure portal, you can see I've already created a virtual machine, SL Backup VM01. This is just a Windows 2016 VM that we're going to use to simulate our backup a little bit later on. Nothing special yet, just a VM we've built from the marketplace. So to begin, let's go ahead and create a resource and type in backup. And we get Backup and Site Recovery OMS. Select that one. And this is where we can create our recovery services vault. So we go ahead and click create, and we'll give it a name. So we'll call it SL-recovery vault. Choose our subscription, choose our resource group. So I'm going to use SL-recovery for this one, and then our location, which I'm going to put in East US for the purposes of this demo. That's also where I put my virtual machine. So go ahead and click create. This sets up the vault for you, and it's pretty quick. Should only take a few seconds, hopefully, to complete this. And that's completed. Let's go ahead to that resource, and we can see our recovery services vault, and currently nothing is being backed up because we obviously just created this vault. You'll see on the top that we have these options for backup and replicate. So we're going to do backup first of all. You'll see replicate in some of the site recovery options later on as well. But go ahead and click backup, and once you're in there, you'll see the first option is where is your workload running. So you get to choose between Azure or on-premises. I'll just show you the on-premises options quickly. We're going to use one of them in the other demo. But when you choose on-premises and you select, okay, what do you want to back up? If it's files or folders, select that and click Prepare Infrastructure. You'll see that you get the option to download the Recovery Services agent. That's the Mars agent that I mentioned in the tutorial section, and then Vault credentials and various other things that you'll see in the upcoming demo. But if we select this drop-down again, you can see if I select like VMware Virtual Machines and click Prepare Infrastructure, you'll see I get options here for using System Center, DPM, or Azure Backup Server. Also mentioned both of those in the tutorial. We're not going to cover those in this course, but it's worth just knowing that those options are there if you need to get to them, because Microsoft will expect you to know what the different recovery options are, so hopefully this makes it more visual for you. If we go back, though, to virtual machines, so we go to Azure and then select Virtual Machine because we want to back up our virtual machine that's hosted in Azure. Click Backup, and then we get onto the next section, which is to choose our backup policy. So there is a default policy which backs up daily at 2 p.m. and a default retention range. But if we go ahead and select this drop down, you can create your own backup policy. And this is one of the things I actually love about Azure Backup, because it's made backup very, very simple for us. I can go in here and choose a policy. We'll call it SL policy, and then I can choose my backup frequency. So maybe I want to back up at night instead. So we'll go down to maybe 10 p.m. Make sure to set your appropriate time zone, obviously. So if we go to Central Time as an example, so 10 p.m. Central Time, so in Chicago that would be backed up, and then I get my different retention ranges as well. So you can see there, at 10 p.m. it's going to keep 180 days of that daily backup point. Here's my weekly backup point. We're going to keep that for 104 weeks, and I can choose to toggle this on or off if I want to. So if I don't want to configure retention of that weekly point, and I'm good with just the dailies and the monthly that comes in, that's fine, but I can keep that weekly so I know that's there. Same for the monthly, all the way down to yearly, and I can click OK once I'm happy with that. And then we go into the items to backup. So I've only got one virtual machine running right now, so I'll select that one, select virtual machines 1, select OK. It will validate that, and then you basically enable backup. And that'll take probably a minute or so to complete, and we'll begin backing up at the next cycle for you. So if we go over to that, I'll just fast forward here for a moment and head over to the virtual machine. Okay, so yeah, we're on the virtual machine. I'm going to scroll down, and you'll see that you have an option under Operations called Backup. Simply select that, and you will see that this VM is now under backup via Azure Backup. And you can see that it's past the backup pre-check, but there's an initial backup pending. And if we want to, we can go ahead and simply select Backup Now. You can see that you also have the option to stop backup if you want to remove it completely from backup. We'll go ahead and select Backup Now. And we'll retain that one, whatever date you want to give it, simply select OK. And that's going to trigger the backup process and back up that virtual machine. So again, I'm going to fast forward here. That's going to take a bit of time for it to complete the backup, and then we'll come back to it when it's completed. Alright, so as we can see on the backup job screen, the backup for SL Backup VM01 was completed. If I go back up to the virtual machine, so we'll head back to SL Backup VM01, and you can see there backup status, last backup status, success, and you can see at the bottom there also that it's in an application consistent status. Now, if I want to, I can choose to recover the whole VM, so I can click Restore VM, and this is where I choose my restore point. So I'll select that application consistent restore point, select OK, and then I can choose how I want to restore that virtual machine. So I have a few options. I can restore the disks, or I can create a virtual machine. So I can give it a new virtual machine name. So I can call it SL Recovered VM. Choose the resource group. I can put it in the same resource group if I want to, same network, etc. Go ahead and select OK. And then click Restore. And that will now begin restoring another copy of that virtual machine. So the original one is still running, but we're restoring an additional one with a different name. Now I can also, if I wish, do file recovery on that virtual machine. So I can select File Recovery, grab this, select my restore points. Again, I've only got the one that I just did recently. And then I can download script to browse and recover files. So I can click this Download this executable. And then I essentially get this script that I can open up. I'll just save it on my desktop for the moment. And open folder, and essentially it's an application file that you can run inside the virtual machine you are backing up, and it will mount essentially the file system from that machine. And just like you'll see in the upcoming Mars Agent demo, it essentially mounts a drive for you, and you can then browse the files on that machine itself. But we'll go back to the portal here for the moment, and we'll come out of the section, and we'll go ahead and look at the job for recovery. So if we click View All Jobs, we can see that restore job is in operation, and we'll come back to that when that's completed. Okay, and after a while, looks like this one took about 25 minutes. That restore has been completed. We can select that job, and on the right-hand side, we can see, if we scroll down, we transferred data from the vault, and it created the restored machine. If I scroll back up, I can see that target VM name is SL-recovered VM. So I can go ahead and go over to my virtual machines, and I should see now that I have a recovered VM. There it is, SL-recovered VM, and that essentially is my restore of the SL Backup VM01. So the same as that Windows 2016 image that I created from the marketplace, we've just done it now as a recovery instead. So hopefully that kind of makes it clear how easy it is to back up and restore in Azure, particularly IaaS virtual machines. It's super easy to get up and running again, and that concludes this demonstration. In this demonstration, we're now going to go about configuring the Microsoft Azure Recovery Services Agent, also known as the Mars Agent, to do some file level recovery from a local desktop machine. So let's head over to the Azure portal to get started. Okay, so we're in the Azure portal, and I've still got my Recovery Vault set up, SL Recovery Vault. I'll select that one. Go ahead and select Backup at the top. And now I'm going to choose that my workload is running on premises. I'm actually going to use my local laptop for this example, and I want to just back up my files and folders up to Azure. So if we select that and then click Prepare Infrastructure, we'll get the option here, first of all, to download the Recovery Services agent. So let's go ahead and click that. That'll just download locally to my machine. Then you also need to download Vault credentials to register the server to the Vault. So these are credentials that will expire after 2 days, but are needed as part of the installation for the Recovery Services agent. So let's go ahead and download those as well. Okay, and both of those are downloaded. So I'm going to open up my downloads folder, and you can see I have my Mars agent installer and my Vault credentials. So I'm going to go ahead and double click the agent installer. And as you can see, that sort of does its installation process, and then you get your usual like Microsoft installation, questions that you get. Where do you want to install it? Where do you want cache location? So we'll go ahead and select next to both of these. We'll accept the defaults. We'll accept the defaults for the proxy configuration. We're not going to go through an internet proxy. We'll opt into Microsoft Updates and go ahead and install. And that'll take a few minutes. We'll jump ahead here until that's complete. Okay, and once complete, you go ahead and select Proceed to Registration. And this is where it asks for those Vault credentials. So we go ahead and select Browse, go to my Downloads folder, select Vault credentials, validates them, go ahead and select Next. Enter a passphrase. You can simply generate one if you prefer, so you can do that. And enter a location to save that passphrase. So I'm just going to save it on my desktop for right now. Go ahead and click Finish. And that now registers this local machine. This is just a Windows 10 desktop I'm on right now, and it's registering it with Azure Backup. Okay, so now that's configured and registered with Azure Backup. We go ahead and select Close. You'll see the checkbox is already selected there, so it's going to open up the Recovery Services agent. As soon as I click Close, here it comes. It's going to load up the policy information, check for updates, and now I simply need to go ahead and schedule backup. So on the right-hand side, I can click Schedule Backup. Wait for it to get policy information, and let's go through this wizard now as well. So hit Next to get started, and now I can add my items. So I can click Add, and let's say I want to back up my whole C drive, I can, or let's say I just want to back up, what's in my Downloads folder. So let's just take that as the example. So I'll go to Users, Myself, and I'm just going to take my Downloads folder for right now. Just got a various, downloads that I've done over time. Go ahead and click Next. Select your schedule, so day or week. So I can do 10 p.m. today if I want to. Select my retention policy, so I don't really want a weekly, monthly, or yearly retention, so I can uncheck those, but I could configure those if I wanted to. If this was a full server environment, obviously I would want that. Select Next. I can choose this option of automatically backing up over the network or offline backup, but I'm going to choose automatically over the network, but there are options there for offline backup as well. Go ahead and click Next and click Finish when we are done, and it's going to go ahead and create that backup schedule for all of those download files basically. So go ahead and click Close, and if I look now, I can see on the right hand side I can back up now. So if I go ahead and select that, go ahead and click Backup, and you'll get a status update here, and it will basically begin transferring all of those files in my Downloads folder up to Azure. And now if I ever want to recover them later on, I basically can. So we'll fast forward here until this is complete. Okay, and that's successfully completed, so let's close that screen down. And now if I want to recover data on the right hand side, if I select that, you can see that I have an option to recover to this desktop or another server. I can select Next, I can choose individual files and folders, and now it will fetch those volumes that have been recovered. So if I select the volume, it was on my C drive, it's got a recovery point. I'm going to go ahead and mount that. Okay, and that's mounted it as a disk, so I can go ahead and select Browse, and you can see it's mounted it as my D drive on this machine. Click Browse, can open up that users folder. You can see my user account and Collie. Double click that. There's my Downloads folder, and in there should be my two files, my Mars agent installer and my recovery Vault file as well that was in there. And those were backed up to Azure, and I basically brought them back down using the Mars agent recovery feature. And with that, this concludes this demonstration, but I hope you also can see how useful this can be if you've got files and folders on your machine that you want to back up to Azure and keep them in the cloud. This is another way that you can utilize that. As part of design and deployment, you'll certainly get into ARM templates, which follow, which is the primary mechanism that Microsoft will expect you to know for the exam, as well as just knowing PowerShell in general and, check out various PowerShell guides, to get details on that. So there are multiple scripting and different technologies that go without saying that you can use for deployment. But I thought it would help to show you how it all comes together as part of an automation architecture in itself, because you may get questions around, okay, somebody, perhaps a developer is using Jenkins or Bamboo or Azure DevOps. Perhaps you've got an IT request coming in through ServiceNow. It helps to think about the entire automation architecture that would be necessary to fulfill your deployments and think about the questions you get in that context. Well, to begin with, if we look on the left-hand side, we've got IT requests coming in by a user. Perhaps they're going to a self-service portal like ServiceNow, could be Remedy, could be any number of technologies there. On the bottom, we've got a developer potentially coming in. They're probably going to use a CI/CD pipeline in their favorite DevOps tools. So perhaps they've got Jenkins, perhaps they've got Azure DevOps. Those are the two logos that you see there. And ultimately, both of these types of user need to fulfill their request. The developer, particularly with their DevOps toolsets, is going to be build and destroying much more frequently, and so needs a lot more automation. The IT requests could come in, you could choose to build it manually, but it still pretty much makes sense to have an orchestration layer in there, and ideally share that orchestration layer between the traditional IT request and the DevOps type IT requests as well. So if we look at this and go into the orchestration layer a little bit more depth, what would happen is the request would come in, whether it's from the DevOps tool or the IT request through like a ServiceNow, and we hand it off to the orchestration layer via an API, and then that's going to go through a series of steps. And typically it would help to think about in this context, one, I've got pre-deploy integrations. These might be things that I have scripts that go out and do. My orchestration tool is going to go and do them. It could be PowerShell goes over Active Directory, pre-stages a computer in an OU that's going to be built. It could be that we go and create a change control ticket first of all. All sorts of options we can do there. Once we've completed our pre-deploy integrations, we then basically run our ARM template, or perhaps we use Terraform, which is a third-party provider as well. And you may or may not get questions on that, but it is a technology Microsoft's been doubling down on lately and one of the core parts of their automation stack now. But you've got ARM templates there, Terraform there. That's what's going to execute and actually go and build your service out in the public cloud, or if you're using, say, Azure Stack, it could be on-premises as well. The good thing is you can use that same framework across both of those. And then you have your post-deploy integrations. These are scripts and things that you might run after the fact because your VM is now online on the network, or my PaaS service is online, and there's some other things I need to do. Perhaps my CI/CD tool needs to go and run some QA tests, or perhaps I just need to install some application on that. I may at this point hand off to another tool, particularly with IaaS for OS configuration management. So you can see we have Ansible, Chef, Puppet there. Microsoft will also expect you to think about PowerShell DSC as part of that. That's PowerShell Desired State Configurator, and we'll put a module in there on that as well. But essentially, if it's IaaS, you have to go and configure the operating system as well. If it's PaaS, you typically don't have any IaaS type configuration to do because all of that is contained in the PaaS service itself. You've already set those toggles as part of your automation module when you deployed your ARM template or Terraform module. But with that, once that's completed, then we hand back over to our CI/CD tool or potentially to like a ServiceNow, which has an orchestrator. That will finish up any last minute things, and then the application is online. If we take a more simple view of this, essentially we order our stack. That gets handed off to our ARM template or Terraform modules to go and deploy, and that's going to configure all that PaaS infrastructure, build our virtual machine, do what we need to do. And if it's IaaS, we hand off to configuration management, and then perhaps we create our change control ticket at the end or configure any additional monitoring capabilities. Then if we look at configuration management in more detail, it's all about composing various stacks. So if we think about, once the VM comes out of the ARM template and it's online on the network, I still need to do some post-configuration to it. So this is where PowerShell DSC comes in. This is where Puppet or Chef come in. Essentially, the bottom layer there where it says raw IIS server, before it becomes an IIS server, it's just a Windows OS online and on the network. And as soon as I apply my configuration, it's going to install all those various packages, configure security rules, configure various things on the server itself. And that really is what gives us that end-to-end configuration of the stack. If we go back and look at this as a whole, again, IT request comes in through a catalog, hand off to the orchestration layer, ARM templates, Terraform, deploy everything, and then we've got this pre and post deploy integrations. If I'm doing it from a developer point of view, I'm probably coming through Azure DevOps or Jenkins, hand off to those automation modules again. They get everything deployed, up and running. Again, we might hand off to a PowerShell DSC, Ansible, Chef, or Puppet for any OS configuration management. Typically, it'll be one of those third parties, and then we finally have our app online and ready to go. Okay, so now that we have a basic understanding of the Azure Resource Manager model, let's take a look at ARM templates themselves. These are things we really care about from a deployment standpoint. And the first thing to think about is ARM templates are really the mechanism that we apply infrastructure
as code. So the example on the screen there, don't worry too much about the code yet, we'll get into that later, but we define a JSON file full of code that says, hey, this is how I want my infrastructure to be deployed, and then ARM is the mechanism by which we do that. We download templates from the Azure portal if we want to, so if we've built something manually in the UI, we can download a template from everything we deployed. If you go into your resource groups, you'll actually see your deployments there that you can grab the code from. In addition, you could simply author new templates. If you're pretty comfortable with the language and you know to go to the providers like Microsoft.storage, Microsoft.compute, certainly could author new templates from scratch once you're pretty comfortable. However, you'll probably find it's much easier to start with quick start templates provided by Microsoft as a quick way to get going. And quick start templates are available in the two links below. You can see that we have the azure.microsoft.com resources templates link, and then we have the GitHub link as well. And I'm going to go to the GitHub link first of all. Now if we select this one, you can see on the GitHub page, if we scroll down, loads and loads of examples for us. Azure Container Service, Application Gateway, Azure DNS, almost every single Azure service created, somebody has probably created an ARM template for it, and it's available on GitHub. So there's plenty here to actually choose from. The next thing we need to know are what are the different types of files that we will use with ARM. Well, we have our ARM template file itself. This is the main file that describes the configuration of our infrastructure in JSON syntax. If we want to, we can also have an optional parameters file. This allows us to separate out parameters that we want to pass into the template, so rather than typing them in as we deploy the template, we can simply create a file full of those parameters. And finally, we have our deployment scripts. So these are things like PowerShell, etc., that can actually take the ARM template, or it could be that we deploy the ARM template via REST API, but this is our mechanism for taking the infrastructure's code and applying it to Azure. Next, we have our ARM template construct. So as you'll see in the demos, when we open up an ARM template, we have a number of sections. For one, we have the parameter section. This allows us to define those inputs that we want, and again, we can pass them in at the time of creation or via a parameters file. We also have variables, so these are values that you can use throughout your templates. If there's something that we use over and over again, it doesn't really make sense to type it in every section of code. We can simply declare it as a variable and reuse over and over again. Then we have our resources. This is the main part really of defining the resources we wish to construct in Azure, so we'll use resource definitions for that section. And finally, we have outputs, which are also optional, and these are values that are returned after the ARM template deployment is completed. For example, perhaps we want to output a public IP address or something like that, then we would output those from the ARM template. So that gives you a brief overview, and I encourage you to just check out the subsequent demonstration. That will guide you through ARM templates, creating a basic one, and working through the various pieces that we've covered here. In this demonstration, we're now going to go about creating and deploying ARM templates, and to begin with, we're going to start out in Visual Studio Code. Okay, so we're in Visual Studio Code, and we can see the basic layout of an ARM template that I've got on screen at the moment. And if you look at it, you can see there's 6 major sections, 4 of which we covered previously, but notice the syntax for each of them. So for the schema, we simply reference the deployment template.json schema that's available from Microsoft. If you're unsure where to get this, if we head over to the Microsoft Azure website, and we can see under resource group authoring templates with the link on screen that the schema is listed there, and this is the location of the JSON schema that describes the version of the template language that we're using. And if you ever want to grab the latest template format, you can go to this link and grab it from there. But we'll head back over to Visual Studio. Next we have our content version, so we could simply give this version 1.0.0, and it's always 4 numbers that we need to put in there, and this is up to us to version if we want to. And then we have those 4 major sections. You'll notice parameters use the open curly braces, the variables use the same, resources are defined in the square brackets there, and then outputs, same in the curly braces. But let's actually go ahead and look at an actual example. So I've opened up an Azure ARM example that we can see, and this is one you can get from those quick start templates that are referenced earlier in the tutorials. And again, we can see we've got our schema, our content version. I've not declared any parameters or variables yet. Everything I'm doing, I'm declaring in the resource block that you can see in the middle of the screen. So let me just walk you through the section one at a time. So the first piece I've got is the name of the resource. So in this case, I'm going to concatenate, so that's add storage, plus a unique string related to the resource group ID. So this is going to create a new storage account name directly for me. The type, this is the resource provider we're utilizing. So again, I'm using Microsoft.storage as my provider, and I'm using the storage account's resource type from there. Then I've got my API version. So this helps because as Microsoft evolves their services, they will update the APIs, and you're able to reference those by using the API version in this particular area. Then we have our SKU. So these are some of the things that are required as I provision my storage account. So in this case, I'm using standard LRS for locally redundant storage. My kind is storage. That's the type of account. It's this particular piece related to storage, and you probably saw that in the storage account section of our tutorials. And then the location I want to put it in, so North Central US. Any tags, I haven't declared any at the moment, and any additional properties. And that's basically the entire
ARM template, and I've saved it as armexample.json. So let's go over to PowerShell and see how we would deploy something as basic as this, which is to create a storage account. Okay, so I'm over in PowerShell now, and the first thing I need to do before I can use the PowerShell command, which in this case will be new Azure RM resource group deployment, so feel free to Google that now if you want to, but before I can use it, I do need to create a resource group. So in this case, let's create a brand new resource group. So I'm going to declare it as a variable, so $RG equals, and I'm going to do a new Azure RM resource group with the name SL-ARM demo in the location North Central US. Okay, so that's created. If I do $RG, I should see I've got my SL-ARM demo resource group name there. And now let's go ahead and do our deployment. So in this case, I'm going to do a new Azure RM resource group deployment. And I need to select the resource group name. Now this needs to be the string for the resource group. So what I can do is reference the variable $RG period the resource group name, followed by the name of our deployment. So this could be any name you want to give it, so we can just call this deployment 1. And then the last thing I need is my actual template file, so I reference this with -template file. And you can just tab through these if you want. So in my case, armexample.json, hit enter. And that will go ahead and start deploying. And what we can do now is go over to the Azure portal, go over to our resource groups. You can see our SL-ARM demo there, and refresh a few times. And after a little while, we can see our storage account has been created. Okay, but now we decide we want to take that same ARM template and we want to make the SKU name for the storage. So, we used standard LRS before. We don't want to declare it in the ARM template. We want to offer it up as a parameter. So let's go back over to Visual Studio Code. And what we need to do first of all is take a look at our area in the bottom here where we've got SKU name standard LRS. Now instead of us declaring it directly there as a string, we're going to reference it as that parameter I mentioned. So first we need to do is eliminate this and say we want to reference a parameter. So quote parameters, and then we'll call the SKU name the parameter we're going to reference. And we'll just give that a capital N so we can see it more easily. And that's the parameter we're going to reference, but nothing's obviously going to work yet because we haven't declared this parameter. So let's go up to the parameters section and let's add a new parameter right here. So let's call it SKU name, followed by a colon, and let's open up our curly braces, and let's give this type string. And that is it for this file itself. Now, we know we want to pass that parameter in, but how do we do it if we want to declare it in a file as well? So let's go ahead and create a new file. And let's go ahead, and the first thing we need to do is copy the schema across. So we can go back over to our ARM example. Let's grab the top section, put that in there. I'm just going to set this to JSON. And now, if we change something at the top, we know the template is deployment template. Well, in this case, it's actually going to be deployment parameters. We can leave the content version as is. We can leave the parameters initial section as is. But where we've got the SKU name, all we need to do now is change this to value. And now we can give it the different SKUs that we want. So in this case, we're going to say standard, and let's do LRS again. So we'll deploy a new account with standard LRS. And we can add one more, so we don't need this comma here because we don't have another parameter we're adding, but let's get rid of that and check everything through. That all looks good, so let's save that. So let's call this Azure deploy parameters.json. I've actually already got one in there, so I'm going to override that. And we've got that saved. Let's just make sure we save our ARM example. And we're ready to go ahead and deploy now. So let's go back over to PowerShell. And same thing, but with a few variations that we need to incorporate. And I've just cleared the screen, and what we need to do is if we reference our previous deployment, we can still see there with the ARM example.json, but the only thing I'm going to add is a template parameter file. So we use dash template parameter file. And now if I tab through, I can see all my different JSON files, but I'm going to use my Azure deploy.parameters.json and hit enter to deploy that, and I should see a second storage account get deployed also with standard LRS, but this time I haven't declared it in the resource body, I've declared it in this parameters file. And last thing we just need to do before we hit enter is go over to Azure and just delete the previous storage account we created because we gave it a unique name of storage combined with the resource group ID, so it's not going to be able to succeed. It'll think we're talking about the same storage account. So let's go ahead and delete that first of all. Okay, and back over to PowerShell. Let's go ahead and hit enter now. And let that deployment go off. And now back to the portal into our resource group. And let's refresh. We can see on the right hand side it's currently showing one deploying, one succeeded, so we should see it any moment. And after a little while, there we are. We can see that our storage account has appeared with the same name because it's still using that unique string with the resource ID, combined with, if we go into deployments, we can look through here and look at deployment 1 again, and we can see our template and look at everything that was inside our ARM template, as well as look on the left under parameters. We can expand that out and see that we used the parameters file and we included the SKU name that way. And hopefully that gives you a good background on ARM templates. That concludes this demonstration. For the exam, just know that you need to be able to sort of read and interpret ARM templates, and in some cases they'll give you questions where you have to kind of take pieces of code and choose which one makes the most sense for the question. Okay, so by now you know how to create ARM templates or start with the quick start templates from Microsoft and massage them to get your result. But what happens when the templates become really, really large, and what if you want to share things between teams? Well, the answer to that is linking templates. So you might start out with your main template and then have like an optional resource template for, say, virtual machines that you want to add. Then you might have a shared resource template for things like maybe your network or storage you want to share amongst other templates, and perhaps you have member resource templates that you want to consume. These might contain reusable scripts or custom scripts in them. But how do we actually go about achieving this? And linking templates is done in a couple of ways. Your inline method, which is where you create an entire ARM template in the body of an existing template. So your main template's there, and then you just start a new ARM template right inside the body. Alternatively, you can use the external method, where you link to an external template. This could be located somewhere else, could be on GitHub, for example. And what you do here is you can have your parameters still inline as you link to the external template, or you can still link to an external parameter set. So just think about that for a moment. You could have an external ARM template you're linking to and an external parameter set, or an external ARM template you're linking to, but you declare your parameters inline. Just from an inline example, if we look at it there from the properties perspective, we immediately declare a new template resource and immediately start with another schema, content version, parameters, variables, resources, etc. Again, we're just creating an ARM template inside of our main template. Just from an external example, very similar, but if we look at our properties section at the bottom there, we have a template link to a URI where we've located our next template. So in this case, I've got a new storage account.json template stored in blob storage there. And then I've also chosen to use my parameters as another external link. So I'm referencing an external parameters file as well. So pretty good stuff from a linking and ARM management perspective. Another thing to keep in mind are some of the key ARM functions, and you are expected to know these for the exam. So for example, you need to be aware of the copy function. This enables us to declare a resource, then just say, hey, we want to copy it 3 more times, and we'll see that in a subsequent demo. We also have copy index. This is a way of us saying, okay, well, we want to name something, and we want to name it according to the iteration that's going through the loop of our copies. You'll see this in the demo again, but know that copy index, could be used to concatenate against a string and make it unique by copying that index value in there. And finally, we've got the depends on function as well, and this just tells us that a specific variable depends on another one or another piece in the ARM template that we've created. But again, I advise you to kind of check that out in the subsequent demos. It will kind of bring that home for you. Just know about these functions for the exam. In this demonstration, we're now going to use the ARM copy function to create multiple copies of the storage account that we created in our previous demonstration when we created the storage account via an ARM template. So let's begin by going over to Visual Studio Code. Okay, and the first thing we need to do is go in and look at our resource block, and you can see this whole section that I'm going to highlight is the section we want to copy again. And let's say we want to do it actually 5 times. We want to say create 5 new storage accounts, but we don't want to type this code in 5 times. We don't want to paste it there again and again and again. So the first thing we need to do is, if we just look at the name, we are going to run into a slight issue because our unique string, which is based off the name storage plus the unique string based off the resource group ID, is only going to be unique 1 time. So we want to do it 5 times. So the first thing we need to do is add in a function at the beginning, and it's called copy index. So we'll add a parenthesis, copy index, and put in our brackets and put a comma in as well there. And that's now going to take the index for the count, which we'll get to in a second, add it in front of the word storage, and then I'll still add our unique string as well. Our parameters, we haven't changed anything there. They're still being passed by the Azure deploy.parameters.json file. That's for the SKU name, where we define standard LRS as the SKU for our storage. But we do need to add our count now, so this goes ahead and iterates, let's say 5 times. So we go down to properties at the bottom, let's put a comma after that so we can declare copy, then put our colon in, our curly braces, and let's give this a name. So we'll call this storage copy, and then we're going to give it the count, which we said would be 5 times, and that is it. So let's go ahead and save that. And what I've done, if we go over to PowerShell, and I've already created a new resource group, so I'll show you that with the variable. So $RG, you can see I've got a new one called SL-arm counts, which we'll look at in the portal in a minute. And I'm going to go ahead and use the exact same command in PowerShell to go ahead and deploy that. The only thing I've changed there is the deployment name to count deployment, but everything else is basically the same. So let's go ahead and run that. Now, if you get an error like the one on the screen, just go back over to Visual Studio Code and check you've got all your commas in there. You know, we added some variables. In fact, I can see it already there in the copy function. We forgot the comma after storage copy. And so we'll save that again and try one more time. And we can see that's going off now. So we'll go over to the Azure portal, and we'll go into our resource group SL-arm counts. And looks like 1's already there, so it's gone through the loop 1 time. Let's refresh. So 2 and 4 are there as well. And if we refresh again, we can now see all 5 are there. So 0, 1, 2, 3, 4, because the loop starts at 0 and we counted 5 times. That's why we've gone from 0, 1, 2, 3, and finally 4. And with that, this concludes the demo. Hopefully this gives you a good indication on how the count loop works. Look for it in the exams and some of the ARM code that they give you on screen.
One of the really cool features Microsoft has added is our ability now to save deployments as ARM templates, and they've added this to the curriculum as well. So let's go over to the Azure portal, and in the Azure portal, let's just find a resource group. We can actually take this one, SL-storage, that we used for some of the other demos, and you can see here, if we scroll down on the left-hand side, we've actually got a few things in this resource group. We've got storage account, VMs, etc. But if we, on the left-hand side, if we click automation script, you'll actually see it generates the ARM template. You can see on the left all the resources, the VMs, these sections in the ARM template, network interfaces, all of it is here, parameters, etc. And we can essentially download this ARM template, copy it from here, deploy directly from it again. But notice that two resource types cannot be exported yet, are not included in the template. And you can click this to see those error details. And you can see it's because file sync service, file shares that do sync in, storage sync service it's also known as, are not yet supported by this automation script download capability. So if we back out of that again, you'd still be able to download it, but you wouldn't get those services in there. But now think about the benefits of this. You can go ahead in the portal, deploy things manually, and then if you want the ARM template to see what it would deploy, if you try to do it more automatically, you could click download and get it. You'll probably have to do some massaging of the template, but essentially that gives it to you there, so you can use, as you probably saw in the other ARM template modules. So with that, pretty cool feature, and you just need to know where to do it on the exam. You'll probably get a question on downloading it, and then they might even give you some code to kind of look at that came from a download. So just make sure you're familiar with ARM templates as well, and not just the ability to download them from the portal. Let's begin by looking at configuration management as a whole and why it's very important. Previously in our demonstrations, we were deploying virtual machines, we were configuring VNets, subnets, etc. But the virtual machine, when it's deployed, doesn't really have our software packages installed on it. Perhaps we bake them into the template, but then how do we keep them consistent? How do we add additional configurations on top of them? And so if you look at the virtual machine, we break it down into two main sections of configuration management. We have our OS settings, our antivirus and backup agents, infrastructure monitoring. This section is really focused around infrastructure settings, things that your Windows and Linux team will really care about for every virtual machine that gets deployed. On top of that, we have all of our application settings, application installations, app configuration settings, and application monitoring, amongst others. These are things that our middleware and application teams care about as well. In order to get a consistent set of configuration for your entire machine, we utilize a variety of configuration management tools to achieve this goal. This means that if we needed to redeploy the machine, as long as everything is set up in configuration management, we know that deploying the machine again, we will get the same machine over and over again. This is that concept of cattle versus pets that you hear so often in the IT industry today. If we look at this now from an end-to-end process, think about you might use an ARM template or Terraform or some other tool to deploy your infrastructure first of all, and we'll obviously cover ARM templates later on in the course. But think about it this way, the ARM template and infrastructure automation tools go out, deploy all of your infrastructure resources, network, storage accounts, network security groups, and your virtual machines. Everything we've done here is outside of the virtual machine itself. Now we want to configure inside of the virtual machine on top of the operating system. The virtual machine goes off, and we use a variety of extensions here. VM extensions allow us to use things like DSC, custom script extensions, etc. to now configure inside of the virtual machine. Ideally, you'll use the VM extensions that make the most sense for your particular environment. If you're a heavy Puppet user and have a lot of teams using Puppet, it might make sense for you to all standardize around Puppet. Perhaps you'll use Chef, perhaps you'll use DSC, and maybe combine that with some scripts on top of it. The choice is really up to you, but there are multiple ways to achieve the same goal. If we look now at configuration management, these are the three extensions that are provided by Microsoft Azure. We have our PowerShell extension, which obviously we'll go over DSC in a moment, but we also have Puppet and Chef extensions available as well. The key difference being that Puppet and Chef are enterprise-level configuration management for multiple nodes. PowerShell DSC, while very good and tactical for us to go and deploy a configuration, doesn't have the same holistic management that something like a Puppet and Chef might have. So if you're looking more to enterprise across on-prem, public cloud, Windows and Linux, definitely take more of a look at Puppet and Chef. But if you really just want to get a configuration up and running, PowerShell DSC is still a really good tool for you. One last thing to mention, PowerShell DSC scripts can be used inside tools like Puppet and Chef as well. So if you've got a configuration you've configured in PowerShell DSC, there's nothing stopping you porting that over and using that in Puppet or Chef. Now, while Puppet and Chef are certainly out of scope for this course, Microsoft does expect you to know PowerShell DSC and some of the key components. So to begin with, there are three major components with PowerShell DSC. Configurations, these are your declarative PowerShell scripts which define and configure instances of your resources. The next piece we have are the resources themselves. Microsoft refers to these as the make it so part of DSC. They contain the code that put and keep the target of a configuration in the specified state that you've decided on in your configuration. And then finally, we have the logical configuration manager. This is the engine behind DSC. It facilitates the interaction between resources and configurations in a sense to keep the system at the specified state. Now, if we look at a PowerShell DSC example, on the left-hand side, you see some code for deploying IIS, and ASP.NET 4.5. First of all, we have the name of our configuration. In this case, it's Skyline's website. Next, we specify the target the configuration applies to. In this example, we're using localhost. Moving on, we have a declarative statement about what we are configuring. In this case, we're saying install IIS. This is the Windows feature, same as if you went into Windows and turned on the IIS feature from the server manager. We have another one here, a second declarative statement, this time to ensure .NET 4.5 is installed, and then we have our curly braces to close out the configuration. That's pretty much what you need to know for the exam. Look at configurations like this and be able to interpret what they're trying to do. We'll see in the demonstration that follows how to take one of these configurations and apply it to a virtual machine. In this demonstration, we're now going to go ahead and look at implementing runbooks with Azure Automation. There aren't too many questions on the exam specifically around Azure Automation, but it is important to understand how you would set up an Azure Automation account and know about some of the runbooks that exist, and certainly you can expand upon this and create your own runbooks as well. Runbooks are really nothing more than automated workflows, so various tasks that you want to occur in a sequence, that's where the runbooks come in. So to get started, let's head over to the portal and go ahead and create our Azure Automation account. So in Azure, the first thing we need to do is select Create a Resource, scroll down to Monitoring and Management, and select Automation on the right-hand side. Go ahead and give your account a name. Select your subscription, and use an existing or create a new resource group. Next, you'll need to choose a location. Note that not all the regions are available here. So if you're in the US, you'll predominantly use East US 2, which is there for you. So go ahead and select that. And this part is very important. You have the option of creating an Azure Run As account. So this essentially creates those service accounts for you that you will use to execute and run your various runbooks. So runbooks don't really run as a user. You would generally run them in the context of another account. And by selecting yes to this creates that account for you. So generally speaking, you simply want to select yes for this unless you've already, built service principals and accounts, using another method in your enterprise. But with that done, go ahead and click Create. That will initialize the deployment, and within a minute or two, that automation account should be ready for you. Okay, so we're notified that that completed successfully. Now we can go ahead and go to our automation account. We just type automation in the search at the top and select our automation account. And here we are. And a few things to point out first of all. On the right-hand side, we've got a typical overview pane, various job statistics. So this is around the workflows that might be running, workflows that have failed, workflows that have completed. But to begin, let's scroll down on the left-hand side and take a look at some of the runbook options. So if we look at runbooks, we can see this is where we can add a runbook. We can browse gallery. There's some runbooks already published here from the tutorial section for us. We can go to the runbooks gallery and take a look at various runbooks that have been published, and you can choose here from the source. So you can choose between the PowerShell gallery or Script Center. You can filter by PowerShell script if you want to look at graphical runbooks or PowerShell workflows, as well as if you just want to restrict your filtering to Microsoft published ones or include community ones as well. So a lot of people in the community build Azure Automation runbooks and they publish them up to the gallery, and then you can simply take them from there and begin to use them. So if you do want to use anything from the runbook gallery, simply select it. There are a lot of them in there for starting and stopping VMs, scheduling and doing it in all different ways. Let's say you wanted this one, you would simply select it, and then you would go ahead and import that into your library basically, and you can give it a different name if you want to. You can also then go ahead and edit it and change things around if you want to as well, but this is a good way to get started pretty easily. What we're going to do though is go ahead and just create a very basic runbook to begin with. So I'm going to go back to the automation account, go over to runbooks, and go ahead and click add a runbook. And we're simply going to click the quick create option, create a new runbook, and give it a name. So we'll do a Hello World runbook in this example. And then for our runbook type, we will choose PowerShell. And you will notice that they've recently added this Python 2 option here. So if you do want to author runbooks in Python, that's a new option that's currently in preview. But for now, we'll simply select PowerShell as our option, and you can give it a description if you want to. Then click Create. And then what you'll notice is that the runbook is created, and you'll see the Edit PowerShell Runbook page that opens up. And on the left-hand side, you can see we've got various commandlets. If we want to pull from PowerShell commandlets, Azure RM compute commands, they're all in here. We can kind of expand them out and use these commandlets to kind of build up our script as we want to. So it's just an easy way to kind of get around if you don't want to kind of go looking up PowerShell commandlets. But for right now, we're going to do something very basic. We're just going to go in on the right-hand side and type in param. So we're going to declare a parameter that we're going to ask the user for, and we'll put in the first parameter. We'll make sure it's not required, so we'll set a default parameter.
Okay, and then we'll do the parameter as type string, and we'll call it name, and we'll give it a default of Skylines. So instead of hello world, if you don't type in a name, it'll say hello Skylines. And so if we go down below, we can simply put our script to say hello $name with an exclamation point at the end. And we can go ahead and save that. And then if we want to, we can publish it. But for right now, let's just go ahead and test it out. So we'll hit the test pane. And on the right hand side, we can put in a parameter if we want to. So you can see, because we've got that input parameter, it's asking for the name. But I can go ahead and run it without. And we should get a simple hello Skylines. But one thing to point out here, as you can see, so first thing, when you run a runbook, it has to be queued up. So it waits for a cycle of compute that it can then, put this runbook script on and then run. In this case, it's completed already now, and you can see it says hello Skylines. But if I wanted to put, hello students, we could do that. And go ahead and hit start again. It's queued up, waiting to execute. Completed, and you can see hello students. So definitely, if you're familiar with PowerShell, this should be right at home for you. Otherwise, just go ahead and look at the gallery, take some other runbooks from there and utilize those, until you kind of get familiar and get what you actually want to do. A lot of people do use these as automation runbooks as a response to events. So there's a lot of new services like Event Grid coming out too, where you can say, okay, when this event happens, fire off this runbook, or you can also just, from other monitoring alerts, fire off runbooks as well. Like, let's say you had low disk space on the C drive of a Windows machine, and it's because you had a bunch of logs that you put there and you probably shouldn't. You could have a runbook go in there and actually just kind of remove those for you periodically or in response to that event. Speaking of periodically, if we go back to our runbook itself and go ahead and publish this runbook. So that's one thing you do have to do before it's available to use. So let's go ahead and publish it. This allows you to also do some element of versioning control as well. But you will see that you have this option that appears now where you can now view the code, edit still, go back into that screen we were just at. But the schedule option is also available to you. So you can select schedule and you can link a schedule to this runbook. So we can click that and create a new schedule as well. So if we wanted this runbook to just occur at a periodic period of time, like maybe every morning at 9 a.m., that's where a lot of people do like these startup VM ones, like 6 a.m. before everybody comes in. They make sure everything's powered on and ready to go, and then shut down for developers, at 5, 6 p.m. whenever they go, depending on different time zones, etc. But this is a way you can schedule it to run, when you decide to do it. And with that, this concludes this demonstration and hopefully gives you a good overview of Azure Automation and how to implement runbooks. In this demonstration, we're now going to build upon what we discovered in Azure Automation and extend it to Azure Automation DSC. If you remember from the Virtual Machines module, we created a desired state configuration module in PowerShell for installing IIS. Well, Azure Automation allows us to automate the installation of these DSC modules across multiple machines and also check that they remain in a consistent state. So let's head over to the Azure portal to begin. In the Azure portal, as you can already see, we're in our automation account that we created in the previous module, and if we scroll down, we can see we have these options under Configuration Management, the DSC nodes, DSC configurations, a gallery again in preview currently, and DSC node configurations. So the first thing we need to do is add one of our configurations. So we go to DSC configurations, and we can go ahead and add a configuration. And in this example, I'm simply going to select the one we used in the Virtual Machines module. So I've got the Skylines IIS.ps1. In fact, if I right-click it and edit it, that opens up, and you can see we have our configuration called Skylines IIS. We have our node of localhost where we simply are enabling the Windows feature IIS, and we're going to enable ASP.NET 4.5 as well. So we can close that down. We're not going to make any changes to our DSC configuration. We simply want to apply it now from Azure Automation DSC instead of going to every single VM and putting it into that VM extension like we did in the Virtual Machine module. So I can select the PS1 file here and go ahead and select that, and it will populate this name. This has to match the configuration. So you can see in that PS1 file, my configuration name was also Skylines IIS, and I can give it a description as well. If I go ahead and click OK, that will create that configuration, and now I can select that configuration and I can choose to compile it. So I have to do this before I can put it onto one of my servers. And you can see it says, are you sure you want to compile this configuration? Any node configurations generated will be automatically placed on the Azure Automation DSC pool server. And this is the server that's going to essentially connect to the virtual machines and make sure all those configurations remain consistent. So we're going to go ahead and select a yes to this, and that's going to compile the configuration. You'll see a job get queued up at the bottom here, and we'll fast forward a little bit. Yeah, it takes a few minutes for all this to complete, and then we will have our node configuration ready for us. Okay, and as you can see, that compilation job is completed, so we can exit this screen and go now to DSC node configurations, and you'll see that we have skylines IIS.localhost. That's the configuration that we compiled. Now all we need to do is associate it with virtual machines that we want to apply it to. So I've got a test virtual machine all ready to go. If we go over to DSC nodes, you can see there's no machines already in there. We can simply select add an Azure VM, and it is possible to also add non-Azure VMs as well. But in my demo, I'm going to choose Azure VM, and then we'll go ahead and select Windows VM 01. Select this one and choose to connect it, and you can see it's actually deallocated right now. So first thing we need to do is go ahead and power that machine back on. So let's go over to virtual machines, go to Windows VM 01, and start that machine up. And again, I'll just fast forward here while that comes up and then head back to Azure Automation. Okay, that machine has successfully started back up, so let's go ahead and try that again. Let's hit Add Azure VM, select Windows VM 01, and we now have the option to click Connect. So we'll select Connect, and this connects it to this node configuration that we select in this drop-down. So I'm going to choose Skylines IIS.localhost. I can choose how often I want to refresh. I can choose the configuration frequency, and I can choose the configuration mode. And this is very important. You can see the option here of Apply and Monitor, Apply Only. So that means it just pushes the configuration, as opposed to Apply and Monitor, which pushes it and will check it for consistency. And then a big one, which you need to be ready for, and certainly a lot of people will start with Apply and Monitor, but Apply and Auto Correct means if somebody logs into the server, changes are set in manually that conflicts with the DSC configuration, when Azure Automation DSC goes and checks the configuration against the pool server, it'll say, nope, this isn't correct. I'm going to override what the person did manually and set the configuration back to how we set it here in Azure Automation. But I'm going to choose Apply and Monitor in my example, and a few other things here. You've got Allow Module Override. If you select this controls whether new configurations downloaded from Azure Automation DSC pool server are allowed to override the old modules already on the target node. So if you've got old modules that you've already put on from a different version and you want to override them with this one, then that's something that you would select as well. Reboot if needed. That's if some of your configurations require that reboot, then it can execute that and then continue configuration. The last thing to mention is just that you do have this option of primary and secondary key. So there is the concept of keys in Azure Automation to basically know which Azure Automation is registered to and authenticated to run against those machines, and you can rotate those keys much like any other key. I'm not going to show you that just yet because I want to complete this configuration, but if you go back to Azure Automation, you'll have a section there called keys. You'll have your primary key and your secondary key, and you can rotate them. So you would basically then use your secondary key before you push and change your primary key, basically. If we go ahead and select OK, that now connects that VM in and will apply that DSC configuration. So again, I'm going to fast forward here because it does take about 5 or 10 minutes for that IIS and ASP.NET configuration to apply, and we'll come back once we've got some data to show you. Alright, and after a little while we can now see that that VM is now connected, and you can see it's connected, and there's an extension version there as well, so it's using the DSC extension to get connected in. And if we go back to Automation DSC now, if we go back to the account, and if we select DSC nodes, which are actually already still on, you can see our Windows VM on the right-hand side with status compliant. If we select this, we can now see, if we scroll down, status compliant, different times it's checked. These are the initial checks going on there, consistency in progress. And what you'll notice is that every 15 or 30 minutes, depending on what you set your time interval at, you will see that these reports come in to say whether or not this VM is compliant with the configuration. And so this is the true power of Azure Automation DSC, because not only can we define a node configuration for our virtual machines, we can assign it to multiple virtual machines all in one go, and then we can continuously validate whether or not they are compliant. And this can also help with login, auditing, etc. And it can also all be fed into log analytics as well, which you'll see in the other modules. And with that, this concludes this demonstration and hopefully gives you a good sense of Azure Automation DSC and what you can do with it. As we move into migration now, we'll cover the various assessment tools, and you'll see how we migrate a VM from on-premises to Azure. It helps to think about the methodology that you're going to take and how you're going to make those decisions on when to migrate an application. And this framework will help you a lot to decide, when you get a question that comes up, what do I basically do with that application? So we have our app that comes in. It's got to go through some level of analysis. This needs to be for cost, for architecture, lifecycle, security, etc. And throughout this course, you've seen various, technology examples of security and architectures. You're talking about cost, throughout out as we look at different pricing plans and things. But we need to analyze the application and say, okay, if I move it to the public cloud, what would it take, to do that? And there's three main areas that you can see on the right. We can re-architect or rebuild it, and that's where we move into these cloud-native PaaS services. And if you haven't covered or jumped ahead to the compute section yet, you'll see that we cover, containers there as an example. We've got infrastructure refactoring as well. So this is more of a minor refactor that you can do to get something into, a more cloud-like state, but not necessarily moved as is, but you can get some cost optimization here. And then you've also got rehost or optimize and shift as well. If we think about this in a little bit more detail and looking at rehost, that's really just picking your VM up and moving it to the cloud. But it does make sense to do some sizing at the same time. Perhaps on premises, you had 8 CPUs on that machine, but you're only really using 2 to 3 CPUs. You could probably size that down to a 4 CPU machine to be sure it's still going to get good performance, and meet the application demands. Infrastructure refactoring could be, hey, I've got a web app on premises running on IIS. Let me move that up, and make it cloud friendly. I can move it into Azure App Services. Now I don't have to manage that underlying VM anymore. And again, as we move up the stack, we get back to cloud native, and that's more about, deconstructing the application into, a more scalable model, whether it's containers, serverless functions, etc. that will work more natively there. Alternatively, it could also be a candidate for SaaS, and this is a business-driven decision. Perhaps you could turn that application that you had on premises and not, host it anymore, buy off-the-shelf software. It could become a SaaS application. Good examples of this are obviously things like Exchange, which have moved to Office 365 a lot now. A lot of people are doing that. We could choose to just retire the application, so look out for this potentially on the exam. Does it make sense? Look out for what's the life cycle of the application. If it's only going to be around for another 6 months and the application team is going to retire it in their specific use case, well, let's just choose that as an option. It's not design and architect around something that's going away. And last but not least, it could be it just stays on premises and it's not a good candidate for public cloud. The other way to look at it too, if you look at your cloud strategy for it, and we sort of put these applications through the funnel, there's typically a priority that customers will go down when they're deciding what to do. And this is just kind of real world approach, we take in the field with customers when I'm out there doing engagements. Well, one, you might retire, minimize, duplicate, application environments as we just talked about. Then my priority should be, okay, is there a SaaS option available? And what does it cost to convert to that SaaS option? Okay, that's not really a good option. So let's look now at PaaS. So now I can convert to PaaS. And what does that take? Do I need to do a bunch of sprints to kind of convert that application? What's my project management methodology to do that? Then perhaps I'm going to continue to use IaaS. So let me optimize for that in the public cloud. And if I really don't want to make any changes, I'm in a hurry. I've just got to exit a data center. I can't make any big change. Lift and shift is kind of your final option there, where you're just picking things up and moving them in a migration factory kind of fashion. And again, last but not least, if none of those are going to work for you, just remain on premises. So keep this funnel in mind. Keep the decision matrix in mind here as you go through those use cases and look for questions around that so you can pick the appropriate option. Let's begin by looking at Azure Migrate, and Azure Migrate is a service for assessing our on-premises workloads for migration to Azure. It's an Azure service that's available in the Azure portal, as you'll see in one of the demos later on. Now what it does is it assesses for Azure readiness. So are my machines capable of running in Azure? Are there any specific compatibility issues that I need to address before I can bring that workload over to Azure? Now in addition to just looking at the workload, it also looks at the appropriate sizing for it. So can I get approximate sizing recommendations based on its performance on premises? An example of this is there's a lot of cases where virtual machines running on premises, say that might have 8 CPUs, but it's not really using all of that CPU value. Maybe it's only using 20, 40%. It was oversized when it was provisioned on premises. This is a good opportunity to resize it as you move it to the public cloud, because at that point, we can save some money as well. And the cost estimation is part of Azure Migrate. Based on the sizes selected, how much is it going to cost me to run in Azure? Now, the final part that's really interesting is dependency mapping, because you can visualize dependencies in order to plan waves of workloads for migration appropriately. Now, examples of that might be, okay, I've got this one workload, but I can't move it without moving this other workload because it contains the data that this workload needs. So workload A is maybe an app service that depends on the data in workload B. Well, moving them together makes more sense, and you can cut those over together when you move them into Azure itself. And so this dependency mapping, which does rely on an agent, so it can't just do it agentless, but it does give that extra, detail and can sort of build this web mesh of what everything's connected to. And then knowing what you know about the business and the application teams can help kind of figure that out and decide the appropriate waves. Now, how does this all work in practice? Well, first of all, if you look at this diagram, which we've got from the Microsoft website here, step one is to download and configure an appliance. So that's a virtual appliance that you'll actually deploy on one of your ESXi hosts and basically target your vCenter. Once that's in place, that data can start to be collected. Essentially you start discovery, and it sends raw metadata. It doesn't send any actual data from the applications or database servers, etc. It's just sending metadata to this collector VM. That metadata is sent in raw format up to the Azure Migrate service. It's then processed and made available to you
you in the Azure portal. And the final thing you just need to do then is create an assessment. And an assessment is essentially, say a group of machines that we want to assess and decide what the appropriate, recommendations are and different things we can toggle around those recommendations as we put them into Azure. Now, there are some limitations for Azure Migrate. First of all, it's a VMware assessment only. So in order to assess Hyper-V, and this may be a question that you get in one of the exams, you do need to use ASR Deployment Planner, which is Azure Site Recovery Deployment Planner. It can do up to 1,500 VMs in a single discovery and project, but for large environments, all you need to do is just split the discovery into multiple assessments, and you can execute up to 20 projects per a subscription that you have in Azure. Projects can only be created in the US regions, and the metadata is stored specifically in West Central US or East US. Now, logically, you're probably thinking, what goes into an assessment? I've got all this data up there, this raw data, processed data from Azure Migrate. Well, there's a number of key things. First of all, you've got your target location. This is your target region in Azure, and this currently supports up to 30 of the Azure regions that are available for your assessment. Your storage type, that's whether or not using premium or standard disks, premium being the SSD disk, standard being the spinning disks, and performance-based size, and we'll actually give you a recommendation on this. It will pull that data from the I/O that it sort of detects from the vCenter data that is incorporated as part of the metadata that comes up. The sizing criteria, so do you want to base it on performance history of the VMs or not? That is something you need to decide. This is really important. Hybrid benefits. So if you've got Windows licensing that you can bring across to Azure, you can save additional costs with the Azure Hybrid Benefit Program that reduces your CPU and memory costs of that instance because they give you credit for the licensing. So it's technically not the CPU and memory that's reducing, it's just the instance cost that's been reduced because you have existing licensing. Reserved instances, so you can determine whether to utilize RIs, also known as reserved instances, to further reduce costs. So that's where I say, okay, I'm going to commit to this machine for say 3 years. I don't necessarily have to pay the pay-as-you-go pricing. I can pay the reserved instances pricing then. VM uptime, so the duration when the VMs will be accessible. If we don't need this VM to be on 24/7, typically on premises we do that because we've paid the capital for the VMware hardware already. In the public cloud, when we're not using it, we're saving money. So VM uptime is a factor there. The pricing tier, so for A-series VMs as an example, you might have the basic tier or standard tier that you want to choose between. Performance history, do you want to go just for the last day? Do you want to go for a longer period of time? And finally, the VM series types that you want to include. So do you want to include A series? Do you just want to look at D series? Do you want to look at E and F? Those are all decisions that you can make as part of the assessment. The next really important piece to consider is the comfort factor. So this is very important. Azure Migrate considers a buffer, which is a comfort factor during assessment. Now this buffer is applied on top of virtual machine utilization data for the VM, so CPU, memory, disk, and network. So this accounts for things like seasonal usage, shorted performance history, etc. You're basically saying, okay, you've got this recommendation for me, Azure Migrate, but I want to be a little bit more comfortable with it. So for an example, a 10-core VM with 20% utilization, you'd be saying, okay, well, they oversized that on premises. Maybe I can get away with a 2-core VM. However, if you choose a comfort factor of 2x and you say, no, I want to go double, then it's going to recommend a 4-core VM instead. The default comfort setting is 1.3x. That's built into Azure Migrate by default. Now, here are some examples for you. A source machine, again, with 10 cores, 20% utilization, that 2x comfort factor would give us the 4 cores that we just mentioned. But take a look at the next one. If I say I've got 10 cores, that's 50% utilized. This is maybe what comes back from vCenter that when we're looking at the performance data. Recommended CPU would be 5 cores. We times that by our comfort factor of 1.3x if we're using the default. That would give us a 6.5 core recommendation. Well, that's not realistic because there's no 6.5 core VM in Azure, so it's going to round you up to the 8 core instances. So the recommendation would be 8 because you can't have a half core and no 7 core VMs exist. Next and final one in this example, 10 cores. Let's say they're 20% utilized. That would have been a recommended CPU of 2 cores for the instance type. Well, if we leave it at the default of 1.3x, we would get 2.6. Again, not realistic. We can't have a 3-core VM in Azure. You can technically have odd number of CPU counts on premises, but they don't offer them in Azure. It's all even numbers. So the recommendation would be 4 in that case. And this is very important. You need to look out for this on the exam. Make sure you take into account the comfort factor and know how it works. And it's common sense. 2x is going to give us 2 times, but make sure you know what the options are that you can actually use in Azure as a result of that comfort factor. Finally, we have port requirements. So we have things like the collector itself. That communicates with the Azure Migrate service that runs over port 443. The collector also talks to the vCenter server. That is over 443. If your vCenter was deployed with a different port number, you would need to change that as part of this installation. And finally, the on-premises VMs need to communicate with Log Analytics Workspace in some cases, and that is over port 443. With that, this concludes the lecture portion of Azure Migrate, and check out the subsequent demo that will help reinforce this knowledge, and you'll see how to deploy this and get that data into Azure and run an assessment. In this demonstration, we're going to perform an Azure Migrate assessment, and to get started, we'll head over to the Azure portal.
And in the portal, I'm going to create a brand new resource group. You'll see I already have one already created called AZ101 migration. That's my pre-completed one that we're going to come back to. But to show you the steps to get there, we'll start with AZ101 migrate demo. So that's just a brand new resource group we'll create in our subscription. And that's created. And now what I'm going to do is go to all services and type migrate. And you'll see migration projects comes up. We'll select this one. And you'll see I've already got that ready pre-created one, but I'm going to create a brand new migration project first of all. So we'll click add and give our project a name. So we'll call this AZ101 migrate demo. Choose our subscription and choose the resource group that we want to put that in. And that's going to go in that migrate demo one that we just created, and go ahead and click create. That takes care of creating a migration project for you, and that's the repository that's going to hold all the data that we're going to assess from our VMware environment. So the goal of this migration project is to look at a VMware environment that we've got on premises, look at all the virtual machines that we've got in there, pull that data in, and look at the assessment that we can do that comes out of that. So that's completed, so we'll go to that resource. And the first thing you'll see on the bottom, it says Getting Started, Discover and Assess. So you click Discover and Assess, and it'll say Step 1, Discover Machines, Step 2, Create Assessments. So the first thing we need to do is discover those machines, and if you click this, what you will see is it prompts you to download a collector appliance. Now for the exam, one-time discovery is covered. Eventually they will add this continuous discovery, which is a slightly different download, but for now we're going to focus on one-time discovery. Once we've downloaded that appliance, you basically create a collector virtual machine in your VMware environment. You configure the collector to start discovery, and you'll need these project credentials as part of that. Now to show you this, I've actually VPN'd into my VMware environment, and I've got an RDP session open here to a jump box. So in here you can see I'm in a machine and I'm looking at a vSphere web client. So if you're not too familiar with VMware, it probably makes sense for you to download VMware Workstation and learn how to build a VMware environment, just so you know how to deploy ESXi, etc. Now that's not going to be covered in the exam. What you do need to know though is how to deploy the appliance itself, which we're going to show you here. So to begin, I've got a folder called Migrate Demo, and I'm going to go to Actions, and I'm going to deploy an OVF template. If I select that, this is actually deploying a virtual machine on VMware, and it prompts you for a URL for the machine, which we can't use, but we can use a local file, and click Browse, and select that Azure Migrate OVA file. Now you might be asking again, where did I get this from? Well, before we continue here, I will just go back over to the portal, and you can see under Download Collector Appliance, that's this OVA file right here. If I click Download, it takes me to a Microsoft Download link, and there you'll see it asks me what do I want to do with it, and all I've done is I've pre-saved it. It's quite a big file, 11 gig, that you download, because it is an entire virtual machine that gets downloaded. So I'm going to cancel that for now, but just know that I've completed that step already. So back over to my jump box, and we'll click Next. Let me get rid of this download link here, and then I have to give it a name. So under this folder, this is where I'm going to put it, AZ Migrate Demo. I give it a name. I'm just going to leave it as Azure Migrate 10915. Click Next. Select a resource. So this is where you actually select the VMware hosts that will run this virtual machine. So in my case, in this cluster, I've got a management cluster and a resources cluster. I could select a specific host, or I could select the cluster itself at the top and let VMware decide which host to place it on. So click Next. I've clicked the management cluster. It's validating to make sure it's got appropriate resources there that this machine can actually run on. Okay, that's completed. I can review everything. I can see that it's got a download size of 11.7 gig. That's the OVA downloaded, but this is the size it's actually going to be on disk. And you have a couple of options. Yeah, not too important for the exam, but just so you know, thin provisioning is where it creates the blocks on the disk as it's needed, as opposed to thick provisioning where it pre-creates that entire disk for you and consumes that size from the storage array. But for now, I'm going to click Next. And then I'm going to go ahead and choose where I want to place it from a storage point of view. So we've got a tin tree storage array here that's connected to the VMware environment, and I am going to select thin provision for that disk format because I don't want to consume all that capacity now. And then go ahead and click Next again. Selecting the network decides which network the appliance is going to run on, and again, this will depend on your specific environment. So for now, I'm just going to click VM network, click Next, and it's all ready to complete, and we click Finish. And what will happen then, I'll just do it, I will cancel it in a second. You'll notice a whole bunch of tasks will appear. If I click the Home button right here, scroll down to Tasks, and then I will see that task where it's deploying the OVF template, it's importing the package and deploying it at the same time. Now I'm not going to continue. I'm going to cancel that out because it'll take a long time, and we've already created one for you to see. So we'll go back to our VMs and templates section in VMware. And now I'll click the AZ Migrate Ready. These two VMs you see here, these are just my jump boxes to get into the environment. But the one I created previously was called AZ Migrate 01, which I have here. And now I'm actually going to RDP into that machine. So I'm going to connect to it remotely. If I come out of this RDP session and open up my other window, you can see, it's asking to do Windows updates on it, but I can just cancel that. And you can see I'm in the collector itself now. So when you RDP into it, the only difference you will see is that you have to set up your prerequisites, specify your vCenter server details, and specify the migration project. So if I expand the migration project, this is where I put in that project ID and key that you can see in the portal. So if I minimize this for a second, if we scroll all the way down, and you can see in our migration project, copy project credentials, and this is the ID and key that I've used here. So I'm going to take those and go back over to the machine that got deployed, the migrate virtual machine that Azure's deployed. You deployed it in your VMware environment using that deploy OVA, and this is where I would put that project ID and product key. In addition, you will have set up your vCenter details. This is going to be, your vCenter server address, your username and login for vCenter itself, and you'll connect that, and when it's connected, it will go green. And just going back to some of the prerequisites that would have been done, you just have to make sure this machine can connect to the internet, it's connected to a time server, and it will take about 10 minutes or so to update Power CLI 6.5. You'll see that happen as soon as you connect into it. When all of that is complete, you'll basically kick things off, and you'll see collection progress happen, and you can see at this point my collection is actually completed. 187 machines have had their data collected. Now again, that's not the data from inside the machine, it's just the metadata from VMware about the performance and sizing of the machine. And so now what I can do, I can go back to our portal. I'm going to go back to home. I'm not going to use that assess that I was starting to do. I'm going to show you the one we completed previously. So I'm going to choose the AZ301 migrate-ready. We'll click in here and you can see 187 machines. You can click on this. It'll actually give me details of all those machines, the memory, etc. But now I can go ahead and create an assessment. So if I click create assessment, here I can choose to create a new group. So I can, group machines by waves and select the machines. I can just say select all machines. And if I scroll down, so you can see more. These are just the machines that were collected. I can choose some of them, or I can choose all of them. I'll choose all of them. And I can create a group. So I could call this like wave 1, or maybe these are just prod machines. Give it a name, whatever you think is relevant based on what you know about those machines. Now, this part is very important for the exam. You'll see this button here. It says view all under assessment properties. So if we click this is where I can toggle all the different details. So which region am I going to put these VMs if I do migrate them? What pricing tier do I want to choose, standard or basic? What type of storage do I want to use, premium or standard HDDs? Do I want to take into account those reserved instances? Obviously, that's going to save money as well if I use reserved instances. Sizing, I can choose as on-premises or performance. If I say performance-based or as on-premises, how much performance history do I want to take into account? 1 day, 1 week, 1 month. And this is important. Which percentile do I want to use for that data? So if we use 95th percentile, the performance history, will include everything under 95% there. And the VM series, I can choose my different ones. So I can choose, DSV2, ES, etc. I could just unselect this. If I just wanted to choose DSV2s, I could do that as an example. This is part of what goes into the comparison. Now, one thing you remember from the lecture, we talked about comfort factors. So at this point, I can choose, if I want a 2x comfort factor, I would choose that there. So again, a 10-core machine, let's say perhaps was running at 20% CPU, then it would be typically 2 cores, but because of my comfort factor of 2x, it would be a 4-core machine that it chooses. And then some of the pricing things, any discounts applied, hybrid benefit, those things that you would deal with your Microsoft sales representative on if you had an EA account to get, different pricing, etc., if that was relevant to your specific situation. So with all of that, once you've decided what you want to do, you click save, and then you would basically run your assessment. Now, again, I've also created one of those ready for us to look at. So let's take a look at a pre-created assessment. Okay, and now we're over in Excel because I've actually got a pre-created one from a customer that I've sanitized for you to take a look at. So I've replaced all the machine names with machine 100 plus here, but they would have been, actual VM names or operating system names if this was the real customer one. And then you can see things here along the top. So is it ready for Azure? So sometimes it's going to say, yep, it's completely ready, nothing required, or maybe it's ready with conditions. And that could be based on support and things like that for certain like Linux distributions as an example. Recommended size, this is the instance type it's recommending we go to, and it will actually tell you the compute monthly cost based on some of those toggles we selected. Storage cost, the operating system in question here, the boot type, BIOS, cores. So this is 4-core machine with 4 gig of memory. If it's got any good CPU usage data, sometimes you're going to see everything as 0 here from this actual assessment, and that's because we didn't grab all that performance data. We just immediately grabbed the specs of the machine. But if you wanted to get the performance data, you could do that as well, and that does require that you have sufficient login turned on in your VMware environment also. Storage, hard disks, SSDs, premium, all of this information is here for you. How many network adapters are on the machine? If you got network throughput, that would show here as well. And the vCenter it's coming from, and the vCenter server inventory scope. So there's a concept in VMware called the data center object. That's where you would see the data center listed here, and the group name itself. Those are the groups that you could give it. So that's basically what there is to it, and everything here is pretty much what you need to know for the exam. The key thing is really around those comfort factors, knowing that if you're doing the 95th percentile, the 50th percentile, know that, make sure you understand that, and just know that you have to download that OVA appliance. You need that project ID, that project key, in order to connect that to VMware, and in turn connect it back up to Azure so it can send that metadata up for you. And with that, this concludes this demonstration. One of the key services in Azure right now is import and export, because there's a lot of data center migrations going on, and the need to just get lots of data into Azure or out of Azure via disks instead of, say, uploading everything over the internet or via ExpressRoute that perhaps you don't want to saturate. And so there's a number of use cases for import-export that you need to understand. One is for data migration to a cloud, speaks for itself. So, when you want to take that data from your data center, export it onto these hard drives, copy it onto these hard drives, and then ship it off to Microsoft, and then they will import it in, to Azure onto a blob store for you, so then you can access it and move it around as you need to. Another use case is content distribution. Perhaps you've got a lot of data in Azure and you need to send it out to customer sites. That's one example there. Backing up, perhaps you're backing up your on-premises data to store it in Azure, and you've just got a lot of data. Perhaps you want to archive maybe things that you sent off on tape to another site once before, and you're going to bring all that back in and now maybe ship it off to Azure for recovery in the future if you need to. And finally, data recovery, the reverse of that, perhaps I want to send that data back to recover it because I've been storing a lot of data in Azure, but now I've got a need to recover it, and so I could use the export service to get that data back to me. Now, there's a lot of components in the service itself. So one, we have the import-export service, which you access via the Azure portal, and that's used to track your data import, the upload jobs basically, or track the data export. These are the download jobs to you. The next service you've got is a command line tool, which is used for preparing disk drives that are shipped, copying data to your drive, encrypting data with BitLocker, generating drive journals, determining the number of drives. That's the WAI import tool that you will find, and that's the command line. You can just download that from Microsoft. There's version 1 of that for blob and version 2 for files. And finally, disk drives themselves. It supports HDDs and SSDs. There's import jobs where you ship the drive containing your data, and with export jobs, you're essentially going to send Microsoft empty drives that they will put the data on and then send back to you. Now, the supported disks and all that information is available on this link that's on screen, and again, will be in the course material for you. Now, if we go a little bit further and look at the job workflow, which this comes from the Microsoft site that you can see linked to on the bottom left. Think about this from beginning to end. You've got this creating phase, shipping phase, transferring, packaging, and completion phase. So creating, if we think about this way, number one, you prepare the drives using the import export client tool, and you encrypt them with BitLocker. Then you create a job in the Azure portal, and then you ship the drives off to the Azure data center in that shipping phase. And then the carrier delivers the drives to the data center. It's all tracked and everything. You'll see all that in the service itself. The hard drives are then processed. So this is the transferring phase now, where Microsoft is processing the drives. The data is copied from the hard drives to the specific storage account that's indicated. And then the hard drives are packaged for return shipping back to you. They're packaged up, shipped to you, and you effectively have completed the service then. The export job, a little bit different, because you're basically shipping the drives to Azure first, then they transfer the data to them and then ship them back to you. But that essentially, is the service as a whole. And just make sure you understand it, know that different drives are supported, know how to get that information, and you'll probably get a few questions on the exam around this, perhaps around the use cases, or perhaps just knowing how the service itself works in the portal. Right, with all those intros out of the way, let's dive straight into the meat now, and let's just take an introduction to virtual machines. For anybody that's not familiar with virtual machines, it helps to just think about how your computer operates, right? So you have some hardware, you have CPU, memory, and disk, And on top of that, you have your operating system. So this could be Microsoft Windows, could be Mac OS. And on top of that, we obviously have our applications that we install. Well, along came virtualization many years ago now, and the concept is still very similar. We still have our hardware, so we still have to run our applications somewhere, and we have our CPU, memory, and disk, but we install something in between, which is the hypervisor. And on top of the hypervisor can live multiple operating systems with multiple applications. So instead of just running one operating system that may only get used 10% of the time, we can run multiple operating systems, make much more use out of that CPU, memory, and disk. And every single one of these is essentially our virtual machine. And when we're in Azure, we're basically doing the same thing. We don't manage the hypervisor on premises. You would typically manage something like VMware ESXi or Microsoft Hyper-V. But in the public cloud, Microsoft presents us with a whole bunch of options for provisioning our virtual machines. And that leads us onto a really, really cool thing, which is all of the VM types available to us. Typically on premises, we would have one or maybe two different variations of hosts, and every time Intel releases a new CPU, we would upgrade those hosts. But in the public cloud, because just the scale that they have, you have multiple choices available to you. So if we go through this, it's very important to understand and select the right instance type for your workload. The A series were the very first series that Microsoft introduced. They're divided up into basic and standard. So standard are actually our general purpose VMs, and then there's a basic version of the A series for testing and development. Then we get on to B, which I remember as B for burstable. These instances can burst to the full capacity of the CPU when needed, but you get a discount because you're not using the machine a lot of the time. So it's storing CPU credits, and then when it has to consume CPU, it can use those credits and use the full capacity of the CPU. Now, if you're going to use the CPU continuously, it's obviously not going to make sense because you're not going to store any credits and you're going to get worse performance, but a very cost-effective option there, and I highly encourage people to use them during some of the labs and things as well. D is the general purpose ones. You'll see a lot of these around in the enterprise. And then we have memory optimized. These are the E series. You'll see there's some other memory optimized ones out there. This is the newest memory optimized series they brought out recently. This is a high memory to CPU core ratio. Then we go into the F series immediately after memory optimized is CPU optimized, and this is the reverse. So we have a high CPU core to memory ratio, and so it's kind of the opposite of the E series there. The G series, Microsoft calls us the Godzilla, at least that's what people tell me when I'm walking around, Microsoft Ignite in various conferences. Very large instances, hence the Godzilla name there for large databases, big data use cases. Then we got high performance compute, computational, molecular modeling, scientific applications. That's the H series. The L series is for storage. I remember this as L for LUN, like in the traditional sense of storage. And these are, storage optimized with a high disk throughput and high I/O. Then we got the M series, another very large memory series available. These go actually much, much larger than the E series. You can go up to 3.5 terabytes of RAM here. Then we have the N series. They're actually divided up into NV and NC, depending on the type you choose there, what configuration you require. But these are graphics card enabled instances. And finally, we have SAP HANA on Azure certified instances as well. So as you can see, just a ton to choose from that. And then we go into the specialization. So if you just got your head around, okay, I've got all these types, well, now there's different specializations, and you notice this in the way the instance types are written out. So for example, we've got S for premium storage. So if you see D series, you'll also see a DS version. So DSV2, that's a premium storage option there. We have the M specialization as well. That's for larger memory of a configuration type. So if, for example, we've got a standard A2, then you might see a standard A2M that just has more memory. And then the final one, we have R, which is supports remote direct memory access, also known as RDMA. And you'll see that by things like H16MR as well. All right, so we have all of these various types and specializations, but how do we actually compare the CPU performance differences between different types? We know some might have more CPU and more memory, but what do those cores actually equal in terms of actual performance? And so Azure Compute Units, also known as ACUs, are a way to compare CPU performance between different types and sizes of virtual machine. It's a Microsoft-created performance benchmark, so they took one of their A-series virtual machines and started at 100, and then equate all your different other, instance types to that one. And so essentially you can say, look, a VM with an ACU of 200 has twice the performance of a VM with an ACU of 100. And a good way to really look at all of this is to go to the OS reference documentation for Windows virtual machines or Linux virtual machines, and Microsoft will actually list all of these out for you. And these are actually great sites, just from a deployment aspect and revision for the exam. Highly encourage you to check them out. And if we go to the Windows one here, what we'll see as this pops up is a section called concepts in here. If we expand that out, you'll see VM types and sizes, but if you scroll a little bit further down in types and sizes, you'll see Azure Compute Units here. And if we expand this out, you can see here, the SKU families, A0, A1 to 4, and you can see here's the ACU number. So if we compare, say, anything in the A1 to 4, A5 to A7, these all got 100. And if we go down to something, like a DS1, V2, the performance there is going to be 210. The other thing to note is, this 2-to-1 ratio that you'll see on the V3s and the DV3s and the EV3s. And this is because they are now hyper-threaded. So, for example, a DV2 might give you, 210 to 250 on the ACU number, but when you go up to the V3, you're actually getting less performance. So it's just something to keep in mind, as you start to, invest in your instance types in Azure. Definitely, compare these so you know what you're actually getting. Don't just go by the pricing calculator if it's something that you're doing that, depends on CPU. All right, so we might be thinking we've got our types, our various supported OS distributions. Can we do it anywhere? And the answer, unfortunately, is no. There are, in fact, regional limitations on services in Microsoft Azure. And the screenshot here, I'm just showing the various compute products that are available in the various regions. And if you just take a look at this, look at the B series as an example. It's available in East US and West US 2 only at the time of recording this course. A8 to A11 instances, only 4 regions those are available in. And so this is important to know. Just because you decided, hey, I want this particular type of instance, you need to make sure it's actually available in your region, because you're not going to onboard every single region necessarily to your organization. In addition, it's worth understanding region pairs. So East US is paired with West US, and what that means is when Microsoft does their patching, they will patch one of those regions, then the other one. They won't do those at the same time. If you don't use region pairs, and let's say you went North, Central, and East US, they could be patched at the same time. So in the rare event that there is an outage, you could have a global outage to your Azure infrastructure if those are the only 2 regions that you use. So it's worth also keeping in mind the region pairs as well. And finally, before we get into the demos, the last thing you just need to be aware of is restricted usernames that you'll see when we go into the demo as well. So, here is a general list, things like administrator, admin, user. A lot of this is common sense. You can't use these for your VM usernames when you create your Azure VMs. Next, we need to cover one of the key parts of the curriculum as well, which is identifying supported workloads on Azure. And we'll start with the Windows ecosystem. If we look at the OSs first of all, and we look at pre-Windows 2008 R2, so these are things like Windows 2003, they are supported for deployment. However, you must bring your own image, and there's no marketplace support at all. And you also need to have your own custom support agreement. Microsoft's not going to give you any type of support for Windows 2003, via Azure. When we get to Windows 2008 R2, that is supported. However, there's a specific support matrix for server roles that you want to check. So just because Windows Server 2008 R2 is the OS is supported, you do need to check the matrix of server roles that you're going to install on top of the server and check that those are supported. Things like Windows Server 2012 supported. There's actually a data center version in the marketplace. Windows Server 2016 is supported. There's a data center and a nano version in the marketplace. And for desktop OSs, those are supported for Windows 10 Pro and Enterprise, which are available in the marketplace. And there's another link here that's very, very useful. And if you click on this one, it'll actually also give you details of other Microsoft Server software that's supported on Azure. So it goes beyond just the operating system. And if we scroll down a little bit on this web page, we can see things like Microsoft BizTalk Server, Microsoft Dynamics CRM. So within the Microsoft ecosystem, Dynamics CRM as an example, 2013 and later versions are supported. And they list these for a whole host of things. It's very common to run, Exchange, which is supported again for 2013 and later if you're not using Exchange Online. And there's some other options here as well. So this link will give you, any other information you need around the specific workloads that are supported. But for now, at least for the curriculum of the exam, you may get asked on these variations, but for the most part, I'd say just revise the operating systems and you should be good to go. As far as Linux supported distributions go, all the major ones are pretty much accounted for here. So we have CentOS, Debian, Oracle Linux, Red Hat Enterprise Linux, SUSE Linux, etc. And another link here you can go to if you need to check, what Linux distributions are endorsed. We hit this link here. We can see it takes us to this page, and all of the current supported Linux distributions are here. So currently for Red Hat, it's 6.7 plus and 7.1 plus, so try to remember those. CentOS 6.3, 7.0, and SUSE 11 and 12 are supported as well. One of the most important things to understand when you're managing your virtual machines are the different storage types that you can connect to your virtual machine.
And we'll start off at the beginning with the lowest price, but the one that's really just backed by traditional HDD, which is the standard storage, standard HDD storage to be more specific. It's the most cost effective, but the throughput and IOPS, you don't get very high maximums there. They're based completely on the throughput of the VM itself and aren't guaranteed from a performance aspect. When you move up, though, you get into standard SSD. Everybody today hopefully knows about SSD drives, certainly a lot quieter, but more importantly, you just get much better throughput, much better IOPS per disk, and these are the ones that they recommend now for most workloads that you provision in Azure. Moving up, you still have premium storage. Premium storage actually came out before standard SSD, and then they released this lower SSD storage as standard SSD, but premium SSD storage still exists, and it's backed by SSD drives, highest performance, lowest latency, max throughput 750 megabytes a second per disk, and max IOPS 7500 IOPS per disk. If we look at these more individually, you'll see there's various SKU sizes. So if you start with the standard disks at 32 gig, you've got an S4 going all the way up to S50 at 4095 gig, or 4 terabyte disks essentially you can add there. Again, the IOPS throughput depends on the VM itself, and essentially as soon as you go above like 32 gig from the S4, when you hit the 33, you suddenly start paying the S6 SKU price for that. Moving on, we've got standard SSD storage sizes. So here we move into the E series of disks. So they have SKUs associated with them as well. 32 gig up to 4 terabytes. Max IOPS, so you can see 120 for the E4. E6 goes up to 240. Then we hit 500 throughout from E10 up to E50. When we look at throughput, again, 25 megabytes a second on the E4, 50 megabytes a second on the E6. And then once we hit the E10, we're at 60 all the way up. Premium SSDs, a little bit different as well. P4 through P50, 32 through 4 terabytes. As you can see, that's 32 gig, through to 4 terabytes. And then max IOPS 120, 240, 500, then it starts to jump 1100, 2300, all the way up to 7500 on the P50. Max throughput again increasing throughout as well. And once you hit the P40, you sort of level out around 250 megabytes a second. Now, Microsoft does have Ultra SSD in preview right now, and this allows us, based on disk size 4, 8, 16, see a little bit different here as we go up, but you can see massive IOPS increases, a lot of throughput increases. So, at the time of recording, they shouldn't be on the exam. It's worth noting because things change very, very quickly. Services go GA very quickly. Once they hit the public preview, it's not long before they go GA. So definitely just be aware that these exist as well. Now, when it comes to these, you'll also see when you sort of pull up the Microsoft website, the concept of these higher size disks as well. And so they increase in increments of 1 terabyte, and the IOPS you can see is capped at 160,000, and throughput is capped at 2,000 megabytes a second as well. And you'll see now that there are other disks for premium and standard SSD as well that go beyond the sizes that you've seen, just in the tables that I've shown you. So definitely just check on the latest sizes because they are constantly being updated. Now, one thing to keep in mind are the VM limits. Just because you picked a size does not mean that your VM can handle it. So make sure that your VM can handle your bandwidth. Otherwise, even though you've associated a disk with high throughput, high IOPS, it is constrained to lower values on the virtual machine. That's the same with networking as well. The VM is going to have network limits. The VM has storage limits, and you need to make sure that just because you associated this, very high performing disk, is my, VM SKU able to handle that as well? Perhaps I chose a D2. Now I need to move up to a D4 instance in order to accommodate that. Next, we need to look at things like managed versus unmanaged disks. So just because we picked out disk, we also decide how we want to associate it. You probably saw in the demo, we pretty much use managed disks throughout now, but it is important to understand the difference. Unmanaged disks are your DIY option. You have to manage the storage account and decide, when am I going to reach my limits, etc. You've got to piece everything together. It does have this overhead essentially because you have a 20,000 IOPS per storage account limit that you have to then deal with. However, it does support all replication modes: LRS, ZRS, GRS, and RA-GRS. Managed disks, by contrast, are the simplest option. You don't have to worry about the storage account. We don't care about management overhead. Microsoft is going to manage all of that for us. However, it only supports LRS replication mode currently. Now, you may be saying, okay, that's a huge limitation because I need to be on GRS, I need geographic replicated storage. What about in the event of a disaster recovery? Well, the good thing to notice, and we talk about Azure Backup in a different module, you can back up your VMs to GRS, and then you could restore them anywhere else. Not quite the same thing as having the disk, readily available, but if it's backed up to GRS, depending on your RPO, RTO requirements that you have for backup and disaster recovery, that could be a safe option for you. But I would always, if possible, choose managed disks. It's much, much easier to handle. Now, speaking of those replication options, let's take a look at them. Well, we have locally replicated storage, LRS. This is replicated 3 times within a storage scale unit. And a storage scale unit is a collection of racks of storage nodes. They're hosted in the same data data center in the region that your storage account was created. Then we have ZRS. This is zone replicated storage, replicated 3 times across 1 or 2 data centers, in addition to storing 3 replicas similar to LRS. We have geographically replicated storage, GRS, replicates your data to a second region that is hundreds of miles away from the primary region. Your data is curable even in the event of a complete region outage. So that's where a lot of people look at GRS for that region outage scenario. And then finally, we have read-only geographically replicated storage, and basically it means read access. You can access the replicated storage at the other region. You can't write to it, but you can read from it if you want to as well. Now let's sort of summarize these out. So again, if we look at LRS, data replicated across multiple data centers? No. Data can be read from a secondary location? No. Number of copies? 3. So ZRS, 3 again, but it's replicated across multiple data centers. GRS, 6 copies of the data replicated across multiple data centers in multiple regions, if you recall. And then RAGRS, exactly the same as GRS, but now we can read the data from a secondary location and the primary location as well. So definitely understand these if you're heading for your Azure certification.
Okay, so we know we need to plan for availability in Azure. How do we go about doing that? And the mechanism Microsoft uses for that are availability sets. Before we can kind of, decide how to use them, let's understand our potential for VM impact first. First of all, we have planned maintenance. This is when Microsoft needs to patch or, say, do some firmware upgrades on the underlying hardware that your VM is running on, and they need to evacuate your VM. In most cases, this will happen using their live migration technology. They will simply move your virtual machine from one host to another. But on other occasions, they do need to shut down your virtual machine in order to do this maintenance because live migration won't work for whatever reason, and so you need to account for that. The second one is unplanned hardware maintenance. This is when Microsoft detects, using, say, their monitoring systems, that a failure may be about to occur on the underlying host. And again, kind of like planned maintenance, they need to move your virtual machine, or sometimes very quickly they have to shuttle the virtual machines down, do the maintenance, and then bring that host back up. And then finally, we have unexpected downtime. This is when there's a catastrophic failure to the underlying hardware, and you're essentially forced. Your VM is, shut down immediately, not gracefully, and, the VM will eventually be powered on another machine, but your application will receive an outage. The way to solve this is using availability sets. This allows us to group 2 or more machines into a set, and they're basically separated out based on 2 things, fault domains and update domains. If we think of fault domains, first of all, this is essentially when we have a rack that has its own power, its own networking connectivity, and we can have up to 3 fault domains in an availability set. So if we think of our virtual machines, if we have 3 virtual machines in a particular tier, which we'll get into more in a moment, they can be spread out amongst those fault domains if we've used 3 fault domains. If there's an outage to one, the virtual machines on the other fault domains will be unaffected, and eventually the virtual machine that had the outage on the first fault domain would come back up once Microsoft resolves the underlying issue, or just simply moves your machine to another host. In addition, we have update domains. So think of these a little bit differently. Microsoft has to patch a whole series of hosts, but they will do them sequentially, and they won't patch the same update domains at the same time. Now, they allow you up to 20 update domains, so your virtual machines will be spread out amongst those update domains in your availability set. You don't control the specific order. So, for example, if you've got 3 update domains, UD0, UD1, UD2, we know that they won't happen at the same time. Again, this is the patching of the underlying hosts, not your virtual machine patches themselves, but we know that UD0 won't happen at the same time as UD2, but UD2 could happen before UD0. This isn't an ordering system, it's simply a separation. If we think of planning for availability in a little bit more detail, the other thing we need to think about is what goes into an availability set. Well, it's very important that you put your tiers into separate availability sets. Think of it like this. We would have an availability set for our web tier, an availability set for our app tier, and an availability set for our data tier. Now think of it just from a fault domain perspective. We know now in our web tier that if we had 3 fault domains, those 3 servers would be separated out between 3 underlying fault domains. The reason for this is if we combined everything, let's say we put our data tier and our app tier and our web tier all together, we could be in a situation where all of our data VMs are on the same fault domain, because again, we've only got 3 fault domains. Microsoft's going to spread all of those machines out amongst the fault domains and update domains as well, obviously. And, if we've got too much in there grouped together, they could just, we could just have all of our data machines on the same fault domain, and that doesn't really help us from an availability standpoint. So use this model whenever you're trying to decide, what availability sets to use. And there's definitely a lot of questions, at least when I did the exam on this. They'll give you some scenarios on, he has so many web servers, so many app servers, so many data servers. They'll describe the scenario, and you have to decide how you group the servers out.
As we've covered availability sets, Microsoft has also begun to introduce availability zones throughout their regions. Now, they're not available in every region, so it is important to, look at the regions when you are planning for availability zones and make sure they are available. But essentially, they work similar to availability sets, but now we get 99.99% availability. They minimize the impact of planned and unplanned downtime and really just enforce them like availability sets, but now you choose your specific zone in Azure. So in availability sets, we had those fault domains and update domains. What we do with availability zones is we essentially just choose the zone. In fact, when you build in your virtual machine, you'll get a number. If availability zones are available in your region, you'll get to choose those instead of availability sets. So it's an either-or option. You can't have availability sets now in the regions that have zones. They want to move you towards zones. But essentially, you choose the zone number. So if you build in a VM, one VM will go in availability zone 0, one will go in availability zone 1, and then you know that they're in separate data centers in the same region. Now, the latency is such that it's such a fast connection between the two data centers in the region itself. So there's no performance impact by using zones, but they do give much better redundancy. In fact, there was a region outage in South Central at one point where the data center essentially had some power issues and went down, and just because you're in an availability set did not help you. You were completely out. All the backup generators and things didn't kick in properly, and people had complete outages. But availability zones would be two data centers further enough apart to make sure that in the event of something like that happening, you would still be online providing your machine was in the other availability zone. So know these in addition to availability sets. Okay, so in this demonstration, we are going to now create an availability set that we can place two virtual machines in. Let's head over to the Azure portal to begin. In the Azure portal, the first thing we need to do is head over to availability sets. You can use the search button at the top, type in availability, and you'll see the services appear for availability sets. I've already selected that here. So if we go ahead, let's create our first availability set. Click Create Availability Sets at the bottom, or click the Add button in the top left. In there, you'll need to type in a name for your availability set. So in my case, I'm just going to use SLVM Demo AS. We choose our subscription, and we use our existing resource group or create a new one if you feel the need. In addition, we choose our location, and then you can see here, we've talked about it in the PowerPoint presentation. We've got a number of fault domains and update domains I can use. So I can go up to 3 fault domains. In my case, I'm going to choose 2 right now, and I can choose up to 20 update domains. And again, this is how our VMs will be spread out inside the availability set. Next, we have this option around manage disks. If we use manage disks and say yes aligned, Microsoft is going to make sure that our disks underneath the virtual machine are also appropriately put into availability sets. There's nothing we need to manage manually there as opposed to when we do it in kind of the classic methods. So with that said, just go ahead and click create, and your availability set within a minute or so will be ready for you. And now it's ready. We go to our resource. We can see our availability set here. We can see our fault domains, update domains, and currently we have 0 virtual machines in there. So let's go ahead and add a couple of virtual machines. And to do that, it's really the same as creating a new virtual machine as we did in one of the earlier modules. So we'll just go ahead and click new and get into the virtual machine creation here. Give it a name, etc. So in my case, I'm calling this SL Test AS for availability set 01. Give it a username, password, etc. Choose your subscription and resource group. Select your size. And then you can see here, when you get to the high availability section of creating the virtual machine, simply expand this out, and you can choose your availability set. We can actually create a new one directly from here in virtual machine creation, but go ahead and select your availability set there, and now it knows that this virtual machine, when it's created, needs to be part of this availability set. I'm going to fast forward here and continue creating the 2 virtual machines and come back when they're completed. Alright, so we can see both of our virtual machines, SL Test AS01 and 02, have been created successfully and are both running. I'm going to flip over to our availability set now, just by using the search button at the top. Go to availability sets. And we can see SLVM Demo AS that we created earlier. We'll go into that one. And now on the right-hand side, what we can see are our 2 virtual machines listed there. They're both managed, and we can also see that we have our 2 fault domains. So SL Test AS01 is in fault domain 0 and update domain 0 as well. And SL Test AS02 is in fault domain 1 and update domain 1. And that's great. So these VMs from an availability standpoint are on separate hardware in Azure's data center. One of the other things that's good to know is how you would associate a load balancer with this availability set. This is one of the other things you're expected to know on the exam. Now, I'm not going to cover load balancers in detail now. That's going to be covered in the networking section, but let's go over to a load balancer I've created previously. So I'm going to select load balancers from my menu on the left here. You can see I have a load balancer already there, SLAS LB01. Going to select that one. And in here, you can see we have a section for backend pools. If we click that and go in here, nothing there right now, but I'll go ahead and click Add, give it a name. So in this case, I'm just using SL-pool, and now I can associate it to an availability set. So I select that, I select my availability set. We can see SLVM demo AS with 2 virtual machines in it. And now I add a target network IP configuration. So I choose that, and now I choose my first target machine. So AZ301. Choose its network IP. And then do the same again. Now for AZ02, its IP, and hit OK. And what's great then is now this backend pool is associated directly with that availability set. So, my traffic's going to come in, get spread out between those 2 VMs, and those VMs are on separate hosts. So in the event there's a failure, one of the machines will always be up and running, and my application will be serviced. And you can see after a little while that's created, expand it out. You can see our virtual machines and our private IP addresses associated with them, as this is a backend pool. And with that, this concludes our demonstration. Now let's take some time to talk about scale sets, and maybe you've heard the term in the industry, cattle versus pets, and scale sets is really a lot around that. Traditionally, if we wanted to scale up an application, we would add more CPU, memory, disk, etc. But scale sets allow us to essentially scale horizontally. So when we want to scale out our virtual machines, we simply stamp out additional ones to meet the demands, and then scale back in when that, that seasonal demand is slowed down, for example. If we look at this, we can define virtual machine scale sets in Azure, also known as VMSS. You can use the portal, PowerShell, or the API, and you'll see a demo of that a little bit later on. But you define the number of instances you wish to run, the instance size, etc. Do you want to scale beyond 100 instances? Do you want to use managed disks? You define everything around your instances there, and then we determine if we want to auto scale. So keep that in mind. A lot of people think of scale sets as, oh, do I have to use auto scaling? Well, you don't have to. You can go in there and choose to scale up and down as you want to, but you can auto scale if you wish. And auto scaling really is around setting a minimum and maximum amount of instance sizes. So you could say have a default amount that you start out with that you always have to have like a minimum of 1, but we want to scale up to maybe 10 as an example, or maybe we go with a minimum of 2 just to ensure we have that availability, as we talked about in availability sets. But then I want to scale up for load as well. We can scale out based on a variety of metrics, and these can be infrastructure or application metrics. And this is really important because Azure ties everything together. We can use things like App Insights to look at the application metrics, say like transactions that are happening on the web server, and scale out based on that. Or we can scale out based on traditional infrastructure metrics like CPU, etc. We can also scale out based on a schedule as well. So if we know that at a certain time of the year, let's say a lot of retailers on Black Friday, for example, need to scale out for demand there, we know on schedule, we don't need to wait for the application to be hit hard. We can already preemptively start scaling out. So schedule-based helps in that instance. And finally, you do need to remember to account for sessions when you scale in. Very often, we always want to create a scale in rule at the same time as we create our scale out rule. So we know when demand goes down, we scale in. But if we've got a lot of users with sessions on specific web servers, they're not going to maintain their session if they scale in. So we need to account for that by using things like Redis cache, etc. when configuring auto scaling in rules. So hopefully you can see now there's just a lot of power in treating scaling in this manner, and we'll see more of that in the subsequent demo here. In this demonstration, we're now going to cover how to create a VM scale set using the Azure portal. So let's head straight over there. In the portal, to begin, simply type in scale at the top of your search bar and choose virtual machine scale sets. Up it comes, and as you can see, I currently have no virtual machine scale sets in my environment. So I'm going to select Add. As you can see, it comes up and asks us for some of the basics for our scale set. First of all, give it a scale set name. So I'm going to call mine SL Scale 01. Choose the operating system disk image. So in my case, I'm going to continue to use the Windows Server 2016 data center images I've been using before. It is possible to use your own custom images. You just need to configure it using PowerShell instead. Go ahead and choose our subscription and resource group.
I'm continuing to use the same resource group I've been using throughout these VM demos, our location, and then our username and password for those virtual machines. If we scroll down, now we get the details around the instance specifics. So in my case, I'm saying I want an instance count of 2, and now I need to choose my instance size. So in my case, I'm going to select this and choose a B series. We scroll all the way down and choose the B2S here. And then I need to decide some other things. Do I want to scale beyond 100 instances? Obviously for this demo, I don't need to do that. And do I want to use managed disks for my virtual machines? I definitely do. Next, we do some IP address and information. So I'm going to do SL public 01, dynamic for allocation method, and my domain label, I'm going to just call this Skylines VMSS, and it'll add the domain suffix at the end there. With the configuration out the way, we can now move on to the auto scale-in section. So if we choose enabled here, another section expands out. If we scroll down, we can see a few things we need to decide here. So the minimum number of virtual machines, this is important. If we're trying to design for availability as well, we probably want to go with a minimum of 2. That's the minimum that will always be available in the scale set. And then we can say a maximum of 4 in my example, but I can choose to go up to 10, 20, etc. And then we can choose how we want to scale out. So what's the decision criteria for scaling out the VM? Right now, we're just looking at the infrastructure criteria that appears on this page, and we can go by CPU threshold, so 75% as an example. When we get to 75%, we'll add another virtual machine. We set it to increase the number of VMs by 1, but we could immediately say, look, when we get to 75%, go ahead and add 2, which would then put us at our maximum of 4. Then we have the scale in rule. As I mentioned, we want to try to create that always when we create a scale out rule. And in this case, I'm saying at 25% CPU threshold, start to decrease my number of machines by 1. And with all of that configured, just go ahead and click create. And we can see deployment is now in progress, and we'll come back to this once it's completed. Okay, so now we can see that our scale set's successfully been created, SL scale 01. If we go ahead and select it, we can go in here, we can see our instance count. If we go down to instances, you can see there both of those are running. And if we open up the scaling section, and we can see in here our various auto scaling rules. And as we mentioned before, we're currently scaling based on an infrastructure metric, but we could, if we wish, add additional profiles, scroll down here, add additional rules, and decide if we want to scale in based on other metrics such as application metrics, etc. And with that, this concludes our demonstration. Let's now shift our attention from virtual machines over to containers. And containers, just an exciting technology development. They're gaining traction all the time, and there are now so many services really devoted to orchestrating and helping you operationalize containers in Azure. Well, first of all, what is a Docker container? Well, for one, it's a standardized packaging for software and dependencies. So think of it as a way to isolate apps from each other, but they can run on the same OS itself. So instead of you stamping out lots and lots and lots of virtual machines for every little bit of application code that you want to run, well, now you can just package that up into a container. You can have multiple containers running on the same OS. So this could be a Linux or Windows OS, but it allows separate apps to share that same OS kernel in itself. And Docker is really the technology that's taken the industry by storm here. If we look then at what's driving this, and it's ultimately because of the issues with monolithic applications. You've got this application code, but all of it is kind of, running on the same box, and minor code requires full recompile and testing. Applications become this single point of failure. If one piece goes down, well, the entire, system has gone down. An application becomes difficult and, often very expensive to scale. And the solution to this has ultimately been to decouple this into microservices. So whereas everything was running on the one box, as we kind of saw in the previous slide, everything's there together. We've got all those different pieces of code together. Now what we do is we break them apart into separate services. So each individual service, could be a container essentially. And this makes the app independently scalable, stateless, highly available by design, because we can build everything around that specific microservice that makes up the application as a whole. If we look then at comparing these, we can see, monolithic, they're simple deployments, but they're a lot of intermodule refactoring. Vertical scaling is the biggest problem here. Often when you've got a monolithic application and we want to increase performance, we have to just give it more CPU, give it more memory, to really get things going. On the microservices side, everything is like the small partial deployment, a lot of technology diversity, and we get a lot of horizontal scaling. We can just rapidly spin up more microservices or tear them down as needed, and they've got these strong module boundaries between them. If we look at the 3 keys to microservices, one, it's about functional decomposition. So typically all services are tightly coupled and error prone. That becomes a breakdown into those services, kind of like I just showed you, as we sort of break that application down and say, okay, this part of
the app does X, this part does Y. One of the demonstrations that I've often built with my team is around a traveler application for handling their bags. And essentially, we started with a monolithic application where people check in, to check their luggage into a plane that's going to go from A to B. And we had a traveler check-in system for the passenger and a bag check-in system for the bags. Well, what we do then is we say, okay, when we break it out into containers, we take the passenger check-in system and we say, okay, this web front end and the data associated with it, this becomes one service. The data associated with the bag system, that becomes another service, and we can scale up or down, depending on which service gets hit more. Perhaps the passengers are checking in for the flight, and that service gets hit, that gets, the performance has to be improved, we scale out containers there. Or perhaps there's a lot of activity on the baggage management service where we scale out that. And that's all about this horizontal scale, is scale what you need to, not what you don't. And the scaling options here, even if it's a microservice, could still be VMs you're using scale sets for, could be Docker containers, could be functions as a service. That's really up to you there. The other thing that's really, really key is data decoupling, because now you can also pick the best database for the service you're after. Perhaps your service would be better suited to a MongoDB type database. Perhaps you need SQL, perhaps you need Cosmos. You can now decouple that and make really good decisions about how you organize the data for each of your specific services. So this is really the key. And again, on the exam, focus on horizontal scaling versus vertical scaling, depending on what the use case asks you for. In addition, if we compare containers to virtual machines in more detail, we covered VMs and all the different sizes, but ultimately a VM is still the combination of that app and OS running on top of the hypervisor. On the container world, you can see we have that Docker runtime engine that runs on top of the OS itself, and we have multiple apps now running on each OS. So again, we're not focusing on scaling OSs out, we're focused on scaling the applications out that run on top of the OS, and Docker really makes this really easy to do, and so do the Azure Kubernetes and container services that are available as well. So definitely look at this and understand the differences between how containers scale out and virtual machines. If we look at some of the container benefits that you need to look out for, well, speed. Well, there's no OS to boot, so the application is online in seconds. You can schedule a container and it's up really, really quickly. The portability is key as well. There's less dependencies between process layers, so you can pick up your containers and move them around really easily. It's easy to redeploy in other regions. The containers are stored in a container registry, so super, super easy. And just the efficiency gain and cost benefits by less OS overhead and improved virtual machine density that you can ultimately get. If we look at some of the basic terms that I would want you to be aware of, the image, this is the basis of a Docker container. The content, is at rest there. The container itself, the image when it's running, this is the standard unit for the app server. So again, the image, it's the basis for the container. The container itself is the image running. The engine is the software that executes commands for the containers. The registry is where we store and distribute the containers. And the control plane is the management plane for container and cluster orchestration. And so essentially when you're using something like Azure Kubernetes service, we have a management plane there. And it's going to manage and run our containers, orchestrate our containers for us. So that's containers, in a nutshell for you, and should give you what you need. And I encourage you to, check out just building and running a container demos that follow, because it'll just help solidify that information if you didn't see that in the AZ300 exam. Before we can jump into the containers themselves, we do need to have a mechanism for running containers on our operating system. So we're going to go ahead and install Docker as well as Git for Windows. So let's head over to our web browser. And in our browser, I'm already at the website here, docs.docker.com/Docker for Windows. And this is a tutorial which you can browse through about getting started with Docker for Windows. But if we go ahead and click C, install Docker Desktop for Windows, and this prompts us to download from Docker Hub. So we select that. You do need to sign in order to download. So go ahead and register for an account if you haven't got one already with Docker. Otherwise, just proceed to log in to download. And then once you're logged in, simply click Get Docker Desktop Windows. It's a free download, and that will begin for you. While that's downloading, we do also need to go ahead and get hold of Git, and we can go over to git-scm.com, and you'll see download version 2.20.1 for Windows. You can just get the latest release, that'll be fine. Go ahead and download that as well, and that will begin downloading, and we'll fast forward while these download and come back to you. And as you can see, they've both been downloaded successfully. We'll go ahead and install Git first of all. Feel free to change the options here. I'm just going with the defaults for everything here, so I'm going to skip through this pretty quickly, and that will begin installing Git on the computer. Okay, and Git has completed. Now we'll do Docker. Again, same thing. We're just going to accept all the defaults and download and install that. Now we'll create a shortcut to your desktop, and the first time you run it, it will prompt you to sign out and sign back in again as well. So I'll fast forward again while everything completes here. I'll come back to you in just a second and show you that prompt. Okay, and there you see it. We just have to close and log out. And once we log back in, we can see we have Docker Desktop available for us now. Now if we go ahead and double click it,
you'll see a little Docker icon appear if you click the little show hidden icons, and you'll see Docker desktop is starting. And then what will happen is you'll see this prompt, Hyper-V and container features are not enabled. Do you want to enable them for Docker to be able to work properly? Go ahead and click OK, and then you will be prompted for another restart as well. Okay, and as you can see, our final restart is completed, and if I click the little show hidden icons on the bottom here, you'll know Docker's running when the Docker desktop has completed starting. But while it's doing that, I can right-click, and you can look here and see switch to Windows containers. Now, I don't want to use Windows containers. I'm going to use Linux containers for this demonstration. But if you ever wanted to run Windows containers in Docker for Windows, I know it sounds a little interesting. Why is the default behavior Linux? Well, a lot of Docker containers today are on Linux. And so if you want to run them in Windows, you actually have to switch to that as your default behavior, because the default behavior is to run them as Linux containers in Docker for Windows. So just worth pointing that out there. And once that's completed, we can just click the little Docker icon here and says Docker desktop is running. We're now going to go ahead and open up a PowerShell window. So we'll launch that as an administrator. So we'll click Start, type in PowerShell, right-click it, and run as administrator. A PowerShell window pops up, and let's go ahead for these demonstrations that are going to follow and create a new directory. So we're going to just go to the root of C. I'm going to make a directory called AZ demo, and I'll just expand this out so it's easier to see. And once we're in there, we'll just cd into AZ demo. Okay, empty directory, as you can see. And now let's just check that Docker is actually running. So we can do docker -- version, and we can see Docker is running 18.09.1. And let's also make sure Git is running as well. So git -- version, and we can see we've got Git version 2.20.1 for Windows running there. So we are now ready for the subsequent demonstrations. In this demonstration, we're now going to prepare our application for Azure Kubernetes Service, and we're going to begin by downloading a repo from the Microsoft samples that are available on GitHub. So if we go to this website, which is on github.com/azure-samples, you'll see a number of samples Microsoft makes available here, and we go to azure-voting-app-redis. And this is a simple application that we're going to use. It's a voting application between who likes cats or dogs more, so it proves pretty interesting for our demonstration now. But what we need to do is just go ahead and grab this link here so that we can clone this repo to our local machine. So we've got the link there. We'll go back over to PowerShell from our previous demonstration. You can see we're in this AZ demo folder. I'm just going to clear the screen, and then we're going to go ahead here and do a git clone of that URL. So we'll paste that in, and you can see there it's basically going to clone that locally, and you can see it did that. And now we have a folder inside here, azure-voting-app-redis, for us to basically use. So we'll cd into that folder, and if we do a directory list in there, you'll see there's a number of different files that come along with that. Now, in particular, what we're going to do is a Docker Compose. So there's a Docker Compose YAML file that's included for us. And if we open that up in Visual Studio, Docker Compose, if you're not aware, is a way to automate the building of container images and the deployment of multi-container applications. I highly encourage you to check out all the Getting Started guides on the Docker website if you want to know more about building the containers themselves. But for right now, we're going to use this Compose file to build what we need. And essentially, you can see the container names there. We've got Azure Vote Back, Azure Vote Front. This is the front end, which is basically built on top of Nginx and Flask image as the base. And then the Redis image is used to start a Redis image instance as well for session state. So with that said, that's really the file that is there. It defines the ports, defines basically what we're going to build. And as soon as we run this, you will see it goes ahead and downloads those images. So let's go back to PowerShell. And the first thing we need to do is do Docker Compose up-d, hit enter there. And you'll see it'll go ahead and it's going to go and pull those different files from the Docker Hub and download them locally for us. And now we can basically look and see what actually happens. So if we go ahead and click in here and type in Docker images, you can see that those images are there. We've got the front end, the Redis cache, and you can see also that because one of the images is based off Flask, that is listed there as well because that serves as the base. And the Redis, just to confirm, that's the Redis image used to start the Redis instance. So we're basically going to have two instances that start up. Now, in addition, we can see the containers that are running. So we can do Docker PS. And as you can see, we've got a couple of containers here. So this container ID, that's our front end container. This one is our ID here for our backend, which is our Redis cache, and it gives you the uptime here as well as the ports that they're running on. Now we can also test this locally now. Now we know we've installed this on our local machine. If we open up a web browser and just do localhost 8080, we should see our application. This is our container running on our local machine, essentially running as a Docker container on top of that Docker daemon for us. And now we can click through. We can say, okay, if we like cats more, we can increase that. If we like dogs more, we can increase that one there. We can reset. It's just a simple application. Doesn't do too much, but it's a great sample app for our purposes. And with that, that concludes kind of building the app. If we want to go and clean everything up, because we don't really need this to run locally all the time, And we can go back into PowerShell and just do docker compose down, same as docker down concept there as well. So this will basically stop that Azure vote front, Azure vote back, and everything is stopped now. If we do docker ps, we will see the containers are no longer running. But if we do docker image, we can docker images, we can see that our images are still there, our front end, our Redis, and the Flask base image as well. And with that, that concludes this demonstration. In the next demo, we'll go about pushing them to our own Azure Container Registry. In this demonstration, we're going to build upon what we did previously and create our own Azure Container Registry to push our container images into. Now, to begin, we are going to need the Azure CLI to run locally for this to work, so we'll go ahead and download that first of all. If we open up our browser, just type in Azure CLI download. This will take us to the download link for that, install the Azure CLI, and we can choose Windows, Mac, etc. I'm going to do everything on Windows as I have been throughout this lecture and demo, and we'll go ahead and click download the MSI installer. That downloads, it shouldn't take too long, it's a pretty small download, and then go ahead and install that. Now, just to point out, if you do have it installed previously, you can use your existing one. There's no reason to go back and do this particular step, but you do need to make sure you have version 2.0.53 or later for the items we're going to run throughout this demonstration. Okay, and up the installation wizard comes, and all we need to do is accept the terms and proceed with the install. And now that's complete, we can proceed. So let's open up PowerShell again. And let's just do an AZ login. And this will open up our web browser to log into Azure. Up it comes, we'll select our login. It says we've now logged into Azure. If you tab back to PowerShell, and you can see we're logged into the Visual Studio Enterprise subscription there. Okay, great. So now we need to go ahead and start making a resource group for us to use and put our container registry in. So we can go ahead now and just do everything from the command line. We can do AZ group create -- name, and let's give a name for our resource group. So we're going to do this AZ containers RG. So that's the resource group we're going to create. We'll give it a location, and we'll put this one in East US 2. And that should only take a second to create. And that's created. You get confirmation there. We can also just go over to the Azure portal and just verify everything is there. And we're logged into the portal. If I go to resource groups, I can see AZ containers RG, and obviously nothing in there yet because we haven't created anything. So let's go back over to PowerShell, and let's go ahead now and do AZ ACR create. So that's for Azure Container Registry. Now keep this in mind, a container registry is a private registry for us to put our container images in that we can then deploy from. So as opposed to being a public registry that we want to sort of grab from, this is private to us. We're going to create our own registry as that's what we do. And we're going to do AZ ACR create -- resource group. And then we'll put in, so AZ containers RG is the one we want to put everything in. Give the ACR a name, again ACR for Azure Container Registry. This has to be unique within Azure itself, and so let's go ahead and call this AZ demo ACR. And then let's go ahead and choose a SKU for this. So we're going to go and just use the basic Azure Container Registry SKU. That will go ahead and deploy. It should take about less than a minute to get this one done. In fact, already completed there. And if we go back over to the portal, refresh, we now see we've got our container registry available for us there. Okay, so now we want to log in to that registry. So let's do AZ ACR login -- name, and our name is AZ demo ACR, and that logs us into the Azure registry, and we should get a login succeeded message once that's completed, and there we go. So everything looks good there. Now let's just verify our local Docker images. So if we do Docker images, we can see we've still got those images from the previous demonstration, but to use the Azure Vote Front container image with the Azure Container Registry, we need to tag that image with the login server address of our registry. So this tag is used for routing when pushing container images to an image registry. And so what we can do is we can do an AZ ACR list, first of all, to get our login server. So if we pop this up, and we can see here is our actual login server. Now what we need to do is tag our local Azure Vote Front image with this login server address of the container registry. So to indicate the version number, we're going to go ahead and add v1 to the end of the image name. So let's go ahead and do that. So let's do docker tag Azure Vote Front. We're going to need to put in our login server now. So we'll go ahead and grab our login server, paste that there, / Azure Vote Front : v1. Okay, so now if we do Docker images again, we should see that an image, here it is here, version 1, is tagged with the ACR instance address plus that version number as well. So now what we want to do is push those images to the registry as well. So we built our image, we've tagged it, it's time to push it up to the registry. So we do a Docker push for that, and we grab our login server again, /Azure vote front v1, and this is pushing it up to the registry. So there it goes, and as opposed to us pulling it down, we're now sending those images up there. As you can see there, everything is completed successfully. Now let's just verify they are actually in the registry. So we can go ahead and do our AZ301 repository list, and we can specify the name of our repo, which was AZ demo-ACR, and just hit enter, and we should see our images listed there. And there it is. We can see Azure-vote-front is there as well. Now, if we also want to, we can go ahead and show the tags. We can do AZ-ACR repository, show tags, choose the name. So again, that's AZ-demo-ACR, the repository, which is Azure-vote-front. And let's output that as a table for easier reading. And there it goes, and we can see our result. Version 1 is the tag assigned to that Azure Vote Front image. And with that, this concludes this demonstration. You now have a container image that is stored in a private Azure Container Registry instance, and this image is deployed from ACR to a Kubernetes cluster in the next tutorial that we go through.
In this demonstration, we're now going to take our application and run it on the Kubernetes cluster that we created in the previous demos. But let's just quickly head over to the Azure portal so you can see the Kubernetes node that is running there. And in the Azure portal, if we go to our resource group, so my AZ containers RG, you'll see we've got our Azure Container Registry there. And we also have AZ Demo AKS, that's our Kubernetes service. If I click into that, you'll see our overview section come up, and you can see on the right our Kubernetes version 1.9.11. Here's our API server address, total cores 2, total memory 7, and on the left you can see this is running in East US 2. Now on the left-hand side we can go and modify a few settings. We have our usual things like activity log, identity, and access management if we want to give people permissions, tags, etc. That's all the normal stuff we've seen over and over again in Azure. But if we go to upgrade, this is where we can choose to increase the version of Kubernetes. So we can go from 1.9.11 to 1.10.9 or 1.10.12 at the moment, and this does take about 10 minutes per node to do the upgrade. If we go to scale, this is where we can see the number of nodes that we have here. So I can go in here and I can choose 2, and you can see that's going to take it from cores 2 vCPUs to 4, memory from 7 gig to 14 gig. So this is one area that you can scale. You can also do it from the command line, but you can also do it here as well. We also have dev spaces. And dev spaces allow us to share the cluster with our team. If we want to collaborate in a dev space, it's basically an area where you can develop your code in isolation for testing purposes. We've got our properties, standard Azure properties. We'll just see our version, DNS prefix, API address, and details around the node, etc. there. Our usual resource locks that we've covered in other modules, automation script we've talked about in other modules, and then we can also go in and look at monitoring. We've got insights, and metrics is now in preview. This is a service they recently announced where containers went into Azure Monitor. Basically it was officially supported, and hopefully this will be GA pretty soon. But this is where you can go in, get your AKS resource, choose your namespace, and then choose your metrics. So number of pods by phase, total amount of available memory. You can start to pull metrics just like you can for like OSs and, host-based metrics as well. But with that, let's go ahead now and deploy our application. And to do that, let's go to the folder we created on our C drive. And you can see I'm in this PC, local disk C, AZ demo. We've got our Azure voting app Redis there. And what we need to do is go ahead and edit our Kubernetes manifest, which is this file, Azure Vote All-in-One Redis.yaml. So if we double-click that file, and if we scroll down, the important part that we need to change is this section right here where it says containers image. It says Microsoft/Azure Vote-front v1. We need to change that, basically update the manifest file to basically point to our ACR login server name. Now, if you don't remember how to get that, we go back to PowerShell and we do AZ-ACR list -- resource group. That was AZ containers RG. And what we get is our login server name. So let's grab that, copy it, go back to Visual Studio where I'm editing my YAML file, update this part right in front, and you can see that's our AZ demo Azure Container Registry, and we're still deploying the Azure Vote Front v1 container. So we'll go ahead and save that and come out of this. We'll CD to that folder, and we will do a cube ctl apply -f Azure Vote All in 1-Redis .yaml. And you can see deployment of Azure Vote back created. That's our backend there. And our Vote front has been created. Now what we want to do is check the progress on this. Let's do a kubectl get service Azure Vote front, and let's just watch it. And you can see it's waiting for an external IP. It's going to basically use a load balancer with a public IP address on it. And right now we're just watching it, waiting for Microsoft to provision that external IP. And once that is available, then we can connect to the service. Okay, and we can see that external IP is there. So let's go ahead and grab that, put it in a web browser. And there we can see our Azure Voting app is up and running. I can click the cats, click the dogs, reset. That is all working just like it worked locally, except now we push the image to the registry, and now we've deployed the container on top of the Azure Kubernetes service. Now, the last thing before we end off this demonstration on Azure Kubernetes service is how do we scale out the number of pods that are actually running? So if we go back into the command line and we do a kubectl get pods, you can see that we have one instance of the front end running, one instance of the back end running, and we can also scale these out so we can have additional containers basically spun up for us. And if we go ahead and do kubectl scale, and we can do replicas equal to 5, do deployment Azure Vote front, and that is going to scale out the front end. If we do the get pods again, very quickly we can see, pretty much all of them are running. One is still creating there. Let's do it again. They do happen very, very quickly, and you can see all of those are running. We could do the same for the back end if we wanted to. You can also do auto scaling on pods as well. So if you want to automatically scale them up and down, say perhaps based on a CPU metric or something like that, you can do that. And there's documentation on the Microsoft website for that. We don't need to know specifically how to do it for the exam. Just know that auto scale of pods does exist there for you. And you can do it based on requests, say, of CPU. You could say, when requests are at 0.25 CPU, you could do a limit of half a CPU. There's different sort of metrics you can play around with there. Now, in addition, we can also scale out the cluster itself, but here we do AZ301 scale. So you can see the difference. When we're doing the pods, we're in the kubectl. When we want to scale out the cluster itself, we're back in the Azure CLI. So we do AZ301 scale, and we do resource group, AZ containers RG, and name. So it's AZ demo AKS. And we just set the node count. Again, this is the nodes that the Kubernetes, again, these are the nodes that the containers will run on top of. So we'll do node count 3. Now this does take a little bit of time because it has to spin up those additional VMs that ultimately are available then for the containers to run on top of. But with that, nothing ready to see. Once it's completed, it'll just show you that there's three nodes running. We basically concluded this demonstration, and you've learned, how to create a container, how to use the container registry, how to run your application in Kubernetes, how to scale it up and down. Now that could be the pods or the nodes being the underlying architecture that needs to support everything, and the pods themselves being the containers that are running on top of it. And with that, this concludes this demonstration. In this demonstration, we're now going to go about creating our Kubernetes cluster in Azure. And to begin, let's head back over to our PowerShell client. Now, just to make sure you're ready for this part, you do need to make sure you have that Azure CLI version 2.0.53 or later. Just do AZ-version. That will come up and confirm your version. If you scroll to the top, you will see your version number right here. And that's what you need to make sure is correct. But with that, first thing we need to do is go ahead and create a service principal, and this is to allow the AKS cluster to interact with other Azure resources. And we covered service principals already in a previous module, so if you're not too familiar with them, I encourage you to just jump back to that module and then come back here, when you're done with that. But to create our service principal, we do AZ-AD, SP for service principal, create for RBAC. And we're going to skip the assignment for right now. And hit create, and you'll get a bunch of values on screen that we're going to basically just copy for right now and pop those into Notepad. Now the next thing we need to do, and I've just cleared the screen here, is to go ahead and configure our Azure Container Registry for authentication. So we need to do an AZ ACR for Azure Container Registry, show, and let's select our resource group, which was AZ Containers RG, and then choose the name of our Azure Container Registry, which was AZ Demo ACR, and hit Enter. Okay, and this comes up and you'll see here a couple of things. We've got our login server that we found previously, but there's another object just slightly above ID that we want to capture. So if we go ahead and just grab this ID, copy this, and let's put that in Notepad as well. Alright, and now what we need to do is go ahead and grant the correct access for the AKS cluster to use the images stored in the Azure Container Registry. So we're going to assign permissions to that service principal. So if we go ahead and do AZ role assignment create, choose the assignee, and that's going to be our app ID that we had previously. So we'll go back over to Notepad, I grab the application ID, sometimes known as the client ID, grab that, that's our assignee. Then we're going to do scope, which is the ACR ID. So let's grab this ID and paste it in there and give it the role of a reader. Okay, we got a small error there, so just double check that, and looks like we just missed a dash right at the beginning. So let's add that in under assignee. Got to watch out for the double dashes in the AZ versus single dashes, and click enter this time. And now that is successful. So now that's completed, we can go ahead and create our Kubernetes cluster. And what we need to do here is do AZ AKS for Azure Kubernetes Service, create, choose the resource group, so AZ containers RG, the name of our AKS cluster, so we'll call this AZ demo AKS, the node count, so this is the number of nodes that are going to be provisioned that our containers can run on. So we'll just do 1 for now. Our service principal, so service-principal, and that is our app ID again. So if we go ahead and go back to Notepad, that is this ID that we have right here. Paste that one in. Then we've got our client secret. So this is the password that was generated. So again, if I go back here, you'll see there's also a password option here. That's our secret. Paste that in. And then last thing we need to do is generate SSH keys as part of this. And this will take a few minutes, and it will go ahead and provision our AKS cluster for us. As you can see, that's completed successfully. So now we want to connect to the Kubernetes cluster from our local computer, and so we do need to use kubectl in order to do that. Now, if you are doing this from the Azure Cloud Shell, kubectl is already installed, but to install it locally, it's pretty easy to do. Just do AZ AKS install -CLI, hit enter, and that will go ahead and install kubectl for you, which shouldn't take very long at all. And that's completed as well. And what you will notice one thing, it says please add the kubectl path to your path, the environment path. And I usually do it with this one. I just grab the $env::path plus equals, so it'll keep the existing path, and then just add up to the kubectl part right here. So copy that, I'm just going to paste that, and then you can do environment path, and it will show you all the things that are in your path in Windows, and I can see this is the one I just added here as well. So with that, we can now go ahead and get some credentials so we can connect to our cluster. So what we do is we do AZ AKS get credentials, choose our resource group, AZ containers RG, and then our name of our AKS cluster, which was AZ demo AKS, and hit enter. And there you see it's merged AZ demo AKS as the current context in our config, and now we can go ahead and run kubectl to get the nodes that are currently running. We should just have the one that we deployed, so kubectl get nodes, and we can see we have that one node there running, and status is ready. With that, this concludes this demonstration. Our Kubernetes cluster is up and running, and in the next demonstration, we'll now take that application that we pushed up to the Azure Container Registry and run it on our Kubernetes node. It's pretty much become impossible to talk about Azure these days without first understanding about app services as a whole and where they fit. As opposed to a virtual machine, app services allow us to bypass that layer of OS management and IaaS infrastructure management and shift that focus up to running our applications. You know, at its core, app services is a series of PaaS-based application services. So if you think about it, it consists of the following four. There are web apps, mobile apps, logic apps, and API apps, and all of these can run on the same underlying infrastructure of virtual machines that support them. So let's take a look at web apps in more detail. Well, web apps were formerly known as websites. If you're familiar with classic Azure, this is what we called them back then, and they allow us to host and build web applications using a variety of programming languages that we can choose from. They offer auto-scaling capabilities as well as high availability, and also include a whole bunch of DevOps features that enable us to automate deployments from things like GitHub, Visual Studio Team Services, and other sources as well. Then we have mobile apps, which also run on that underlying infrastructure, and they allow us to build a mobile device backend. Essentially gives the developers that mobile-friendly environment platform, still is highly scalable, highly available, and allows developers to build native apps for iOS, Android, Windows, and cross-core platform apps are supported as well. One of the biggest benefits, is really that this shares the same app service deployment to reduce those run rates and, bring the costs down. Then we have one of my personal favorites, which are logic apps, and these really allow us to automate business processes. Think of it like creating your own orchestration workflows. There's an orchestration engine under the covers that helps us out with various tasks that we want to perform. And think of these examples like, every time your app calls an API, I want to do some task, or every time there's some data in blob storage, I want to do some work on that, or maybe there's an external SaaS service I want to connect to. Perhaps I'm trying to do something more around the social media space, like check-in tweets or check-in Slack messages, and then I want to take some series of actions. So it's a very easy way to build automated workflows without really having to learn a lot of code. Then we have API apps as well, and so these allow us to easily create, consume, call APIs. We can basically use our own APIs as part of these, and these could also be from external API services as well. So then we get on some of the security features, and Azure App Services are highly secured. Any of the app service features that you consume will run on their own isolated virtual machine. They meet all the security standards, ISO, SOC, PCI compliant, all the main ones are there, and Azure Active Directory is fully integrated as well, so it can be used to authenticate users along with social logins. And in addition, Microsoft recently added managed service identities, which are currently in preview, but a managed service identity from Azure Active Directory allows your app to easily access other AAD protected resources such as Azure Key Vault. The other things that are really important are some of the features that are supported from a security standpoint are custom domains, SSL TLS, custom certificates that includes wildcard or subject alternate name, supports multiple directory authentication protocols, so OAuth, OpenID, and Microsoft Active Directory. And finally, this is really important, with the release of Web Application Firewall, this can be integrated into your web apps and app services as well. So then we have DevOps features. Pretty much, you can't release a good development platform without having a lot of DevOps features. So Microsoft includes the most common ones here for you. So, CI/CD support is available through Git, GitHub, Bitbucket, Docker Hub, as well as VSTS as well. You can integrate with all your popular IDE tools such as Visual Studio. That could be the Community Edition, could be Visual Studio Code. That's all available for you there. And it also supports deployment from external folder sources such as Dropbox and OneDrive as well. So if you just want to get your application up that method, you can do that as well. App Service also has a unique feature called deployment slots, which allow us to stage environments. So we can basically have like a stage environment, a prod environment. We can deploy the stage and then flip it into prod. And you'll hear more about that, later on in the course. So if we look at app service plans now in a little bit more detail, app service plans represent the collection of physical resources under the covers that are going to host our apps. This is where our apps are going to run on top of. So first, we have to define the following: the subscription the plan belongs to, the location, so it could be like North Central US, the pricing tier, so it could be free, shared, basic, standard, premium, or isolated, and we'll talk more about that one shortly, and the instance size. So this is the size of the VMs running under the covers, and you'll notice when you look at the pricing of these, they pretty much map to the VM sizes if you went and deployed a VM like you would just for IaaS. Once you've got that part set up, then you configure your settings. So it's around things like scale count, like how many instances do I want under the covers, what are my scale rules, allow for auto scaling if the plan supports it, scale up, you can increase the resources associated with the app service plan. This is essentially how you would switch the plan you defined at the start if you wanted to kind of increase the resources associated with it. So let's look at the pricing tiers in a little bit more detail. So first of all, we've got those shared tiers, the free and the shared one. So these run apps on the same Azure VM as other app service apps, and this includes apps of other customers. So here, CPU quotas are allocated to each app that runs on the shared resources, and resources are not able to be scaled out. You'll need one of the other plans for that. And that brings us onto these, which are dedicated compute resource plans. So you've got the basic, standard, premium, and there's a premium V2 tier. These run your apps on dedicated Azure VMs, so only apps in the same app service plan plan share the same compute resources. The higher the tier, the more VM instances are available for you to scale out. And then we've got this isolated tier, also known as app service environments. And this tier runs dedicated Azure VMs on dedicated Azure virtual networks. So they provide additional network isolation on top of compute isolation for your apps as well. And these provide the maximum scale out capabilities for you. So there's some general guidelines that you need to follow. And first of all, you can select this link at the bottom, which will give you the subscription service limits and give you more details on that. But if we look at some of the guidelines in more detail, first of all, you create an app service plan for your specific applications. Then you deploy your app services to support that entire application. What you don't want to do is use a single plan for every single web app that you have. That's not going to scale very well, and it's just going to be very hard to manage. You do want to then combine app services versus mass VM creation as well. So this is a key thing, because if I'm going to go and create a whole bunch of app service plans and then put a whole bunch of app services and spread them out, that's not going to be very cost effective. So the more I can combine my app services for that application, the better, more cost effective it's going to be. And then you can combine other services in the same resource group. So you can mix your app service plan. If you say you got, IaaS SQL servers, but you want to have web apps running in an app service plan, you can do that in the same resource groups. Everything can still share the same life cycle. If you destroy the resource group, it could destroy everything, the IaaS services, the app services, plus whatever other services you've decided to utilize in Azure as well. Now, to wrap up, let's take a look at ASEs and app service environments and kind of talk through those in a little bit more detail. So app service environments, again, are that fully isolated environment. So it's a feature of Azure App Services that allows us to reserve that dedicated compute environment for securely running those apps at high scale. And ASEs can host web apps, mobile apps, API apps, as well as Azure functions on top of them. So your use cases really are around high-performing apps, high CPU, high memory. Service instances are generally good enough, but they are pulled from a common pool which is shared with other Azure customers. At very high utilization, this could result in some performance problems, as compute services are all suddenly requested from a whole host of people. Within that, though, you've still got individual or multiple service plans that you can put on top of your ASE. So there could be a mixture of, different plans that share different applications. And there are two ways we can go about deploying them, internal or external. So when we look at an internal ASE, this is where a VIP is created on an internal IP address. The internal endpoint is essentially an internal Azure load balancer. These are sometimes referred to as ILB ASE. And then you've got external ASE. Use this option when you want your ASE to be directly accessible via the internet. After selecting your VNet, you then select the number of external IP addresses you want to utilize. Again, something to stress here, this is created in a subnet of a VNet, which achieves isolation. And another note, these may take a few hours to spin up. These aren't things that are just click of the button and readily accessible. They're reserving compute specifically for you. It's dedicated for you. So there is a time period as these spin up. So with all of that, this concludes this part of the module and hopefully gives you the good background on everything you need to know about app service plans. Make sure you understand the different plans, the different tiers, the app service environment option, the fact there's that internal and external option. And I encourage you to just check out the upcoming demo, which will guide you through creating your first app service plan in Azure. In this demonstration, we're now going to go about creating our first app service plan in the Azure portal, and we'll use this to deploy our web apps on top of later on. So let's head over to the Azure portal. Okay, and in the Azure portal, on the top left, simply select Create a Resource, type in App Service Plan, and you'll see it come up. Simply select it once it's there, and that will give you the option to create the app service plan. Go ahead and click Create. And now we need to enter our details. So first of all, what's the name of our app service plan? I'm going to use SL-app service plan as my example. Select our subscription. I'm going to use my pay-as-you-go one. And I'm going to create a new resource group to put all of these objects in. So call this one SL-app services. Choose your operating system that your web apps that you're going to put on top are going to run on. So if you're doing .NET apps for Windows, you would use Windows. If you're doing some kind of Linux-based apps, you would choose Linux as your operating system, and then select your location. So in my case, I'm going to use Central US, and then choose Pricing Tier. Now this brings us up to a good point. If we go over to our web browser and pull up app service plans on the Microsoft site, and if we scroll down, this is where you need to understand all the differences between the app service plans, and you can see Linux is called out specifically under app service Linux there as well. So if we look at these, we've got free, shared, basic, standard, premium, and isolated, as we mentioned in the tutorial section. So some of the key things we need to remember as we look through these. So first of all, there are limits on the number of apps you can deploy in free and shared. So it's 10 for free, 100 for shared. There are disk space limits as well, so 1 gig for those shared tiers. Then as we get up to basic, it's 10 gig, standard 50 gig, 250 gig in premium, and then 1 terabyte in isolated. And then we also have a max number of instances. So you may get questions on this on the exam, and you can see there under basic we can go up to 3, standard up to 10, premium jumps us to 20, and then isolated is 100. If we scroll further down, you'll see some other things like deployment slots are only available when you get up to the standard tier and higher. Development tools, everything's pretty much there, but things like cloning apps are reserved for premium and isolated, as well as some of the testing and production options. Those are for standard, premium, isolated, and app service for Linux as well. Most of the diagnostics and monitoring tools are there throughout, just some exceptions for app service Linux. And then for networking, you'll see there as well. If we want VNet integration, we have to be at standard, premium, or the dedicated isolated tier as well. For programming languages, if we drop down, pretty much good across the board there. You'll see though the difference between what you can deploy on top of app service for Linux and the generic Windows app services there as well. So that's important to be aware of. The one extra one you get there is Ruby on Linux, which you can't do on the Windows systems. And then as far as scale goes, that's the other important thing. You can see that auto scaling is only supported on standard or higher, as well as traffic manager is only supported on standard, premium, and isolated as well. So just be aware of this matrix. I think I've covered the major ones you'll get asked on the exam. They're the big one that you'll see is probably around scaling and the sizes that you can scale up and down. There's definitely a lot of questions on those. So with that, let's jump back to our portal and go ahead and select a tier. So we'll scroll down and you can see there that these represent the price of the underlying infrastructure. So if I go ahead and select a standard, this is a 2-core, 3.5 gig of RAM, I've got that 50 gig of storage. I can scale up to 10 instances there. So you get a good summary there, and I get 5 deployment slots. So if I select that one, hit select, and then go ahead and click create, that will now spin up that app service plan, and should take probably a minute or two for that to be available. So we'll fast forward while that completes. Okay, and we can see in our notifications that deployment succeeded. So we'll go ahead and select that resource. That should take us directly to our app service plan. I'll take away these notifications, and we can see an overview there. We can see it's obviously not very much in use right now. The CPU percentage is low, but you've got this kind of good monitoring overview of your app service plan right at the front of the main screen. We can see that it's in Central US, status is ready, and then on the right-hand side, we don't have any apps deployed, live or into any deployment slots at the moment. So with that, that concludes this demonstration, and let's move on to the next module where we'll start looking at deploying web apps themselves. All right, so we've deployed a lot of web apps, we've configured a lot of web apps, but as I say to a lot of my clients, nothing is real until we know how to manage and monitor it. When you start to put things into production, you have to know how to operate it. And there's a lot of management tools to cover and a lot of metrics and things we're going to go through in this module. So if we look at management tools, first of all, there's a number available to you. You've got the Azure portal. You've also got something called Kudu, which is System Control Manager. We'll see a demo on that a little bit later. And you can also manage and do additional diagnostics through Visual Studio. You probably saw those settings, enable remote debugging services. Visual Studio then can get additional insights into what's going on in Azure if you utilize that. In addition, you've got your CLI commands and PowerShell. Those are available. They can be used for automation or to just retrieve additional data about your service and how it's performing. So those are the tools, but let's start taking a look at it from the app service plan first of all. So the app service plan is what's running underneath that's supporting our web apps. We need to understand how the infrastructure is performing. So we have a number of metrics available to us here. First of all, we've got our CPU and memory. So these are the average CPU and average memory across all instances of the plan. So, the instances can scale out, and you'll see that in the subsequent module, but this is the average across all those instances, so we know if we're maxed out or not. Then we have our data in and data out. So this is the average incoming and outgoing bandwidth used across, again, all the instances of the plan itself. We have our disk queue length. So this is the average number of both read and write requests that were queued on storage. So a high disk queue length is an indication of an application that might be slowing down due to excessive I/O requests, or perhaps there's other apps that are performing, a lot of I/O that are affecting your app because they're running on the same service plan. Then we got HTTP queue length. This is the average number of HTTP requests that had sit on the queue before they were being fulfilled. So a high or increasing queue length is a symptom of a plan that's also under heavy load. So this is another one that you definitely need to be aware of. There are some others as well, like average response time, the average time taken for the app to serve requests in Microsoft, the average memory working set. Don't worry too much about those. These are the core ones that you need to know for the exam. Then let's look at the free and shared apps, because they work a little bit differently. They don't so much look at CPU percent and memory. Those are really focused, on the on the standard plans that you have. When you look at the free and shared plans, you have these other options. So first of all, you've got the CPU short and CPU day. So this is the amount of CPU allowed for this application in a 5 5-minute interval for the short one, and then the day one is the total amount of CPU allowed for this application in a day, and those quotas reset every 24 hours for the day and every 5 minutes for the short one. The memory is the total amount of memory allowed for the specific application. Bandwidth is the total amount of outgoing bandwidth allowed for the app in a day, and that quota resets every 24 hours as well. And then finally, the file system. So you have this here, which is the total amount of storage that you're allowed. Now the results of exceeding quota are as follows. So if we look at CPU first of all, so if you exceed either that short or that day quota, that will result in your application actually being stopped until the quota resets. So during all this time, the incoming requests from the user to the website, they'll just get a 403 HTTP error on their page. So obviously not going to be a good result for them. This is why you need to use the other tiers. For memory, the application will be restarted. For bandwidth, also a 403 error. The application is stopped until the quota resets. So during that time, they'll just get the 403 error. And if you exceed that file system limit, write operations, including writes to your logs, will basically fail. So if that gives you a good indication, on how the quotas work there. Now, what about the web app diagnostic logs? Well, there's two varieties these come in. So we have our application logs and our web server logs. And if we look at application, they essentially just come in the following login levels. So we have error logs, warning logs, information logs, and verbose login can be turned on as well. And those pretty much map up to, if you're familiar with Microsoft applications, those are the typical warning levels that you get for application. For the web server as well, though, you can enable or disable the following kinds of logs. So you've got web server login. This is information about HTTP transactions. This is useful when you're trying to determine overall site metrics, such as number of requests handled or how many requests, say, are handled from a specific IP address. You've got detailed error login. So this is detailed error information for HTTP status codes that indicate a failure. So this could be status codes 400 or greater. And then you have failed request tracking as well. And then you have failed request tracing as well. So this is detailed information on failed requests, including a trace of the IIS components that were used to process that request and the time taken at each component. So this is useful if you're attempting to increase site performance or isolate what is causing a specific HTTP error to be returned. Now let's take a look more closely at those diagnostic logs and locations. So application logs, so these are all stored under /log files, then /application. This folder contains one or more text files containing information produced by application login. Then we got those failed request traces, so they're under /log files /w3svc, and then there'll be a number following there. This folder contains an XSL file and one or more XML files. So you need to be sure to download the XSL file into the same directory as the XML files, as the XSL file provides the functionality for the formatting and filtering of contents for the XML file. It'll just be very hard to read if you don't have both of those. Then you've got your detailed error logs, so /log files /detailed errors. This folder contains one or more .htm files that provide extensive information for any HTTP errors that may have occurred. Then you've got your web server logs, so we've got /log files /http raw logs. This contains one or more text files formatted using the W3C extended log file format. And finally, we've got our deployment logs, which are under /git there. So just make sure you understand, as a whole, where these, log files can be found. For the most part, you shouldn't get too many trick questions on this. Everything's under /log files, app logs under application, detailed error logs under detailed errors, and deployment logs is one I have seen from time to time, which are under /git. Last, but certainly not least, is Application Insights. You've probably heard of this. It's kind of an application monitoring tool, very similar to the App Dynamics and New Relics of this world. And Azure Application Insights can alert you to changes in performance or usage metrics in your web app. So there are three kinds of alerts. There are metric alerts that tell you when a metric is crosses a specific threshold value for some period, such as response times, exception counts, page views, things like that. You've got web tests, which tell you when your site is unavailable on the internet or if it's responding very slowly. And then you've got a very cool thing, which is proactive diagnostics, and they're configured automatically to notify you of unusual performance patterns. So it sort of determines what's the normal behavior for your website. And then, if things start to look like they're not behaving normally, or maybe user activity isn't what it's expected, or some other pattern that it distinguishes, then it can kind of, alert you to that as well. So that's a pretty cool one, because you don't really have to kind of go in and configure something. You don't have to necessarily know what you're looking for. It's going to determine that normal pattern and then see what's kind of different from it. So with that, this concludes this tutorial overview, and hopefully that gives you a good understanding of all the diagnostic and monitoring tools. I encourage you to check out the demos that follow, so you know where to kind of turn logging on, turn diagnostics on, and, access the Kudu management engine as well. We've talked a lot this far about all the app service plans that we've deployed. We've deployed web apps into those plans, but there are a lot of settings that you can fine-tune to meet your needs, and you need to be aware of a number of these for the exam. So to begin with, let's look at the different framework versions. So for example, we've got .NET, PHP, Java, and Python that are all supported, but .NET and PHP are on by default. The default setting for .NET is version 4.7, although you can change that to 3.5. The default setting for PHP is 5.5, or you can change it to the other versions as well. Java, like I said, is off by default, but you can make that Java 7 or 8 and turn that on. And Python, same thing, you can go to version 2.7 or 3.4 as well. If we look at the platform itself, the default is 32-bit, but you can switch to a 64-bit environment if you desire. However, the free and shared modes, if you're using one of those lower tiers, they only support the 32-bit option there. WebSockets can be set to on to enable the WebSocket protocol if that's desired. And this is an important one, the option for always on, because by default, web apps are unloaded if they're idle for a period of time. This lets the system conserve resources. However, in basic or standard mode, you can enable always on to keep the app loaded all the time. And finally, we also have this option of auto swap. You saw the deployment slots demo, but in the auto swap scenario, whenever I push code into the slot, I can have it automatically swap into production. So perhaps I've got a slot that I just want to push code in and then that becomes production immediately. I can do that if I desire. Then we got things like connection strings as well. So if we look at connection strings, number of characteristics here, connection strings allow us to specify database servers that can be utilized per slot. So again, perhaps you've got the staging slot that you want it to go to staging data, and the prod slot is talking to your production database. This allows you to kind of set that up. And just like a lot of app settings, these can be global or slot specific if you want to. The connection string is a variable instead of a configuration file. That's an important distinction there. So it's just a variable that you set for the configuration string. It is secure because it doesn't store information as a file at all. So it's purely the connection string stored in Azure there. The variable prefixes, you can see you've got SQL Server, so you would use SQL con str, and then the same for all the others. So if you're using MySQL, you've got a MySQL option. If you're using Azure SQL, you've got the option there, and then you can also do custom connection strings as well. Then we've got some other more advanced things like handler maps. So handler maps allow you to choose specific file extensions and then have them handled by specific script processes that you define. So these script processes can be external and instead must be local to your application that has mapped the handler. So you can have the extension, the file extension to be handled, example .py for Python, PHP, etc. The processor path, so this is the absolute path of the script processor, and then any additional arguments you want to pass to your script processor can be handled there as well. You also then have virtual applications and directories. So these allow you to configure virtual applications and directories where you specify each virtual directory and its corresponding physical path relative to the website root. So by selecting the application checkbox, this marks the virtual directory as an application. So using this feature essentially allows you to create subdirectories of your website that handle specific functionality. That could be content storage or specific execution. So you've got the virtual directory. This is the path users will take to access the application itself, the physical path to the physical directory or application, and then that application toggle box or virtual directory. By default, you must select this for web app. Then we've got something like custom domains, obviously a common thing. So if you don't want to use those built-in domains that you constantly get, you obviously want to register your own domain against it. Well, you can use custom domains, and all you do is go into the settings section here, select your custom name that you've got from your registrar, add your DNS record in your registrar, and associate it with the web app. It's actually a pretty simple process to get that all registered and taken care of. And so that concludes this tutorial piece. Hopefully that gives you an overview. Just make sure you understand certainly all those initial settings and the options you have around handler mappings, virtual apps and directories, and just know that the process to kind of configure a custom domain is a two-stage process. It can't just be done in Azure. You have to also go to your registrar and do some DNS work there as well. All right, so it's time for us to begin our journey down networking, and there's obviously a lot to cover here for the exam. If you look on screen, we've got this network overview image that Microsoft always presents us with, and you can see more on this at the link on the bottom of the screen. I do encourage you to check that out. There's just a ton of documentation Microsoft provides around networking. But if you look at the image on screen, on the left-hand side, we have our on-premises network with options for like an encrypted tunnel, direct connection. Over to the right-hand side, which is our Azure network. And this right-hand side is where we are going to be focused on primarily as we work through this module. And there's all sorts of concepts there, but let's start with the VNet first of all. The VNet is one of the core pieces, and it has a number of capabilities that Microsoft provides for us to utilize with VNets in Azure. And if you look on screen, we've got a boundary there. So we've got our VNet boundary. Inside there, I've got two subnets, subnet A, subnet B, and I've got a couple of virtual machines in each one. Each virtual machine has a network interface card that connects it to the subnet, and then by default, these subnets can route to each other because they're in the same VNet. And then if we want to, we can put an NSG, a network security group, which we'll hear more about later, around these to say, okay, I want to filter traffic between them. So this is kind of the core concept of just if I want to put machines out in Azure, VNets are the way to do it. So what are all those capabilities? Let's just kind of summarize them and work through this list. First of all, they are isolated. VNets are isolated from one another unless we choose to connect them to each other. So VNet isolation is very important, particularly in multi-tenant scenarios. They all provide internet access. So if we want to connect these VMs to the internet, we can do that by default unless we choose to restrict that, but that is available for us. They allow us to connect multiple Azure resources, not just virtual machines. We could put cloud services like web apps and other services in there. We can plug them into the same VNet as our virtual machines. Everybody can share that networking boundary if they wish. The VNet connectivity, I kind of mentioned briefly, and again, we can chain these if we want to, so we can connect VNets to other ones, and there's various methods to go about doing that connectivity. We can provide on-premises connectivity, so we can allow VNets to route to on-premises, as you saw in that original diagram. We can apply traffic filters via network security groups. That's kind of the shields again that you can see on the screen there. And finally, VNets provide a number of capabilities around routing. So we have default routes available. We can also define user-defined routes. And so we can basically customize this to manipulate it in a way that meets the needs of our organization. If we look at some of the key points, let's just hammer these home. Number one, VNets are a primary building block for Azure networking. So just think of this as the core for everything that we do out in Azure and all the services we want to connect together. It's a private network in Azure based on an address space prefix, and this is something that we define. We create subnets in our VNet with our own IP ranges, so we need to plan for them. We do have to think about things like overlap in address space, much like we would on premises as well. We can choose to bring our own DNS or use Azure provided DNS, and there's more to come on that a little bit later on. And finally, we can choose to connect the network to on-premises or the internet if we wish to. But hopefully this gives you a brief overview. I think if you just understand these 5 points and work through the demos, I think you'll get a lot out of this and see very quickly how easy it is to connect all the pieces of Azure networking together. Let's now take a look at routing inside of Azure, and to begin with, let's look at the system routes. Every subnet that you create has a route table that at a minimum contains the following routes. The local VNet, this is the route for local addresses, and so there's no next hop value. On premises, this is the route for defined on-premises address space that you might have in your main data center in your premises, and the next hop will always be the VNet gateway, which traverses the traffic to your on-premises data center. And finally, you'll have your internet route, and this is a route for all traffic destined to the internet, and the internet gateway is always the next hop address here. The default routing in a subnet is as follows, and if you look at the diagram on the right, it gives you the 3 major use cases, but we'll break them down a little further. 1, if the address is within the VNet address prefix, we just route to the local VNet, so we have implicit routing for VNet addresses. If the address is within the on-premises address prefixes or BGP published routes, we route to the gateway, and this is implicit routing for on-premises address on the left-hand side there. If the address is not part of the VNet or the BGP or LSN routes, we route to the internet via NAT. And then finally, we've got 2 more. If destination is an Azure data center address and express route public peering is enabled, it is routed to the gateway. Or if the destination is an Azure data center, but we're using site-to-site or an ER express route again without public peering enabled, it is routed to the host NAT for internet path. However, it doesn't actually leave the data center. Going a little further, we can also define user-defined routes. So if we look at this, this is our typical scenario with system routes that we kind of described before. And you can get more information on this by selecting the link below. But to go a little bit further, let's see what happens if we change something like this where we have our web servers and our database servers. Currently, they can talk to each other because they're in the same virtual network, so the system route works there between the subnets. But what can we do if we want to route them through, say, a Palo Alto or something like that, or another network virtual appliance? Well, we can input a user-defined route to stipulate that all of the traffic now has to flow through this virtual appliance, and that's effectively what a user-defined route is. We go into the route table section of Azure, we define it, and then we associate it, and we force all the traffic to the appliance, and you'll see that in the upcoming demo. Last but not least, we also have one other trick up our sleeves. When we want to connect one virtual network to another one, we can use something called VNet peering. And what this allows us to do is, say we have the hub of shared infrastructure services on the right-hand side, and that virtual network, we want to be able to route to services in, say, the customer apps VNet or the data services VNet or another VNet. Then we can simply peer the VNets, and that's effectively like joining them together so they can route within that same space. And now, the only problem we might have is if we want to go again, we can't daisy chain to a third one. So we can't say do another peer between customer apps VNet and another one beyond that. That won't work. It only works directly between two VNets. So you can't assume that it daisy chains along the line. But that's it for routing and VNet peering. Check out the upcoming demo, and hopefully that will solidify all your knowledge in the space. One of the core security components for networking in Azure are NSGs, also known as network security groups. And what are they? They're essentially a traffic filter, a network filter that's checking traffic. Think of it like a firewall, and it basically allows or restricts traffic to resources in our Azure network. There are two types of rules. There are inbound rules and outbound rules that you'll see in the upcoming flow that we'll walk through. And finally, they can be associated to a subnet or a network interface card, and it's very important, something I'll reinforce over and over throughout the section. Finally, it is worth noting that in classic Azure, you were able to associate NSGs with the virtual machine itself, but that changed under the ARM model, and now you've got the network interface card and the subnet that you can associate with only. Now, if we look at this from a flow perspective, if we've got some virtual machines in subnet B that wish to communicate with virtual machines in subnet A, we ultimately go through this kind of traffic flow. The virtual machine in subnet B wants to communicate with this virtual machine in subnet A, and the traffic goes out through the subnet NSG in this example. And that NSG is going to check it from an outbound rules perspective. If it's all okay there, then the traffic will continue on to subnet A. The NSG in subnet A will check it from an inbound rules perspective, and then if everything's okay, allow it to talk to the virtual machine in subnet A. Now again, this can be applied at the network interface or subnet level, and the subnet rules apply to all the resources in the subnet. Now think about this from a rule precedence perspective. If the NSG is applied to the network interface card and the traffic is coming outbound, it may never even reach the subnet NSG. That network interface card overrules the subnet policy. The same in reverse. If we're coming into the subnet, and let's say the NSG associated with the subnet allows the traffic in, it'll get to the virtual machine, and then the network interface card can still deny it. So just think of it from that perspective. It gets denied, outbound first from the network interface card, then to the NSG on the subnet. If it's reversing coming inbound, the traffic is stopped potentially first at the subnet NSG, and then again at the network interface card NSG. Now, what are some of the properties that you configure when you create a network security group? Well, aside from just giving it a name, we have to define these things. One is the protocol that we want to allow. For example, it could be TCP or UDP. Second, the source and destination port range. So anything in the range from 1 to 65,535, or we could simply choose a star for all ports. We have our source and destination address prefixes. So this could be our ranges, or we could use default tags, which I'll come on to shortly. We can do our direction, so inbound or outbound. That's obviously a natural property there, and that, as we went through the flow previously, that's going to determine where things are going to be stopped. The priority, which I'll also come on to in a moment, so that's, in what order are these rules evaluated, and then whether we choose to allow access or deny access based on the rule we've just defined. So we set the criteria, and then at the end we say allow or deny. So what about rule priority that I mentioned? Well, rules are enforced based on priority. As you can see there, they have a range from 100 to 4,096, and the lower numbers have the highest priority. So if you've got a rule that's 100, that's going to be a higher priority than a rule that's, lower down the spectrum, closer to the 4,096. So hopefully that gives you an idea there. Now, the default tags I mentioned are also really important because they can make things a little bit simpler when we're trying to restrict certain ranges of IP address. And these are system provided to identify groups of IP addresses that Azure has provided for you. And there are three major ones that you need to deal with. First of all is your virtual network. So this includes all the CIDR ranges defined in Azure for virtual networks. In addition, you've got your Azure Load Balancer. This is Microsoft Azure's infrastructure load balancer, i.e. this is an Azure data center IP address. And finally, we have internet. So this is all address space outside and reachable by the public internet. And this includes all of the Azure-owned public IP space. Now, if you're still unsure what these are for, just remember when we create our rules, we can choose to use service tags instead. So rather than us having to try and figure out all these IPs that we want to deny in these services where there's groups and groups of IPs, we can simply use the default tag instead. And this just makes it a lot easier for us to say, okay, I don't want to allow any traffic to Azure Load Balancer, well, I can use a default tag for that. Now, when we look at the NSGs, and we've created one, there are a number of default rules that are created as well. And we've got the inbound and outbound rules on screen for you. And they essentially are the same if you look at the categories across them. So if we look at the top row in both inbound and outbound, which is called allow VNet inbound and allow VNet outbound, this is for traffic originating and ending in a virtual network. And this is allowed for both inbound and outbound directions, as you can see there. Then you have internet on the bottom there. This is allowed by default out, but is blocked coming in. And finally, in the middle row there, we have our Azure Load Balancer, and this allows the Load Balancer to probe the health of your VMs and role instances. Now, you can change these rules, but you can't delete them. They have to be there in the network security group. By default, what you will notice is that the priorities are very, very low, so they're not set to a high priority. A lot of the rules you create will be given a higher precedence over these ones. One final thing we just need to cover on networking is around networking limits, and you can see the limits on screen. You can get the latest limits by checking on the Azure website. Now, there's a couple I'll just bring your attention to. For one, there's a default limit for network security groups of 100, but this can be increased very easily to 400. NSG rules per an NSG, we're looking at a default of 200, but this can be increased to 500. But the other ones I'll bring your attention to are public IP addresses, which for dynamic ones you can have 60, for reserved public IP addresses 20, and to actually get those increased you have to contact support, and they don't like to increase those very easily. So that's just something to be aware of there as you're thinking through some of your network configurations. Let's now take a look at the Azure Load Balancing services you're expected to know about for the exam. And first of all, we have Azure Load Balancer. This is the most common one. This works at the transport layer, so think layer 4 in the OSI network reference stack. It provides network level distribution of traffic across instances of an application running in the same Azure data center. Now, in contrast to Load Balancer, we have Application Gateway. This works at layer 7, the application layer. It also acts as a reverse proxy service, terminating the client connection and forwarding requests to back-end endpoints. And finally, we have Traffic Manager. Think global scale, globally distributed endpoints. This works at the DNS level, so we might have applications running in multiple regions and users coming in from multiple locations. That's where we would utilize Traffic Manager. Now, in more detail, let's look at Azure Load Balancer first of all. So as I mentioned, it's layer 4. It's important to know that there's basic and standard SKUs now available. Now, the standard SKUs are in preview. They're not required for the exam, so you're only expected to know about the basic one, but just know that's coming out, and we'll certainly update the material when that actually happens. You have something called service monitoring as a feature. This allows Azure Load Balancer to probe the health of various server instances behind the load balancer. When a probe fails to respond, the load balancer can stop sending new connections to the unhealthy, let's say, virtual machines that are behind the load balancer. We have something called automatic reconfiguration as well. So this can reconfigure itself automatically when you scale instances up or down, perhaps when you add new web server instances as an example. Next, we have something called hash-based distribution, and this is how Azure Load Balancer distributes its traffic. And by default, it uses a 5-tuple hash composed of a source IP, a source port, destination IP and destination port, and protocol type to map traffic to the available servers. It also provides stickiness only within a transport session. So this means that if a client comes back, has the same session, they will continue to connect to their same, say, web server behind the load balancer as well. And finally, there's internal and public options. And you'll see some of the examples in a minute, but just know you can configure an internal load balancer for traffic to hit it and then disperse for internal applications, or it could be people coming over the internet and you want to expose a public IP, and then once they hit that load balancer, then we pass traffic to the servers behind the load balancer. So let's look at some of those examples. First of all, look at an internal example, and in this case we have our internal load balancer at the top there, which has a private IP associated with it. That can be dynamic or static as well. You can decide how you configure that. And then we could have, say, 2 database servers behind the load balancer. Traffic will hit the private IP and then be sent over to one of either DB1 or DB2. Now let's look at a public example where if we look at the load balancer, which is in the center of the screen, the traffic would come through the cloud at the top there of over TCP port 80, and then we would pass the traffic down to one of the 3 available web servers that are behind the load balancer there. Now you're also going to get multi-tier examples as well. So in this case, you might see traffic come in and hit one of the 2 load balancers. First of all, traffic from the public cloud would come in and hit that web load balancer at the top, and then that would pass the traffic down to the web tier. Now those virtual machines that are perhaps the websites would then pass traffic to another load balancer when they want to query the database. So in this case, the second load balancer there goes in front of the database servers, and the web servers just query the database server. Now it's also possible then that people internal could just hit that database server if they wanted to from other applications as well. Could be coming from the website. It opens up a host of options for you there. So let's shift our attention now to the app gateway, the other load balancer that's available to us from Azure. And first of all, it's layer 7 app load balancing, as I mentioned before. So just keep that in mind the whole time. When we want application load balancing, we need app gateway. When we want just layer 4 load balancing, we can get away with just Azure load balancer. But a couple of unique features as well are important. So cookie-based session affinity, this is a common requirement for many web applications. And this is required so that a user can maintain the same user session on a backend server. It also supports SSL offload, so all those decryption tasks, etc., that web servers would normally have to deal with. They don't have to deal with that now. They can offload that to App Gateway and it can take care of it for them. We also have end-to-end SSL. So App Gateway supports end-to-end encryption of traffic. It does this by terminating the SSL connection at the App Gateway and then applies routing rules to all of the traffic. And then it re-encrypts the packet and forwards it to the appropriate backend based on the routing rules that you've defined. In addition, one of the most popular new features that they added recently was around web application firewall. And this has become a key feature. When you enable this, it provides protection for web applications from a lot of common web vulnerabilities and exploits. This can include like SQL injection, cross-site scripting, things like that. And you also have URL-based content routing, and this allows us for directing traffic to different backend servers based on the content that the user is actually requesting. A different server can serve that content up. Finally, one very important thing is App Gateway does require its own subnet, and you need to create that subnet before you can create your App Gateway, and you'll see this in the upcoming demonstration. In addition, there's a few things you need to know around App Gateway sizes. In the following table, this shows you an average performance throughput for each application gateway instance, and this is shown with SSL offload enabled. And Microsoft does make a caveat on their website for this. These values are approximate values for an application gateway throughput. The actual throughput depends on various environment details, such as your page size, the location of the backend instances, and the processing time to serve up a page. So just keep that in mind as well. Finally, if we just take a look at a comparison overall, we covered Azure Load Balancer, we've covered App Gateway, and we've covered Traffic Manager just very briefly there. So just think at the top level technology, what am I trying to do? So if I need layer 4, Azure Load Balancer, if I need layer 7, App Gateway, and if it's something more geographically dispersed, think DNS level, think Traffic Manager in that context. As far as endpoint monitoring, it's worth noting at the bottom, it's all supported via probes for Azure Load Balancer and Application Gateway, but Traffic Manager is supported via HTTP and HTTPS GET requests. As far as endpoints go, that's the other different feature there. Azure Load Balancer supports Azure VMs and Cloud Services role instances. Application Gateway supports any Azure internal IP address, public internet IP address, Azure VM, or Azure Cloud Service. And Traffic Manager supports Azure VMs, Cloud Services again, Azure Web Apps, and external endpoints as well. So that's just a brief summary there of all the different load balancing technologies for you. But that's it for this tutorial section. I encourage you to check out the subsequent demos. Alright, so everything we've been talking about so far has been primarily focused around the Azure Virtual Networks and all the great software-defined networking services that we can build out there, but often we still want to connect that Azure network to our on-premises data center, and so we have a number of hybrid connectivity options available to us from Microsoft. First one, and very common, is site-to-site VPN. This is how a lot of people get going before they're ready to commit to something larger, and essentially this involves connecting your data center over a VPN device to Azure. The next one is ExpressRoute, which is kind of what people mature and gravitate towards as they adopt a lot of Azure and decide, okay, I'm ready for a dedicated circuit. Maybe I'm doing a large-scale migration. Maybe I've got a lot of data to access on premises and in the public cloud, and I've got apps running everywhere. I really want Azure to feel like a permanent extension of my data center, and ExpressRoute is a good method for that. And the third one is point-to-site, which is a very easy way to connect, say, your laptop directly into a virtual network. And we're going to cover all of these in a little bit more detail as we go through the module. So let's begin with site-to-site VPN, and you can see a couple of examples on screen right now, but let's just take a look at the quickly at the top one first of all and focus on the basics of a site-to-site VPN. Well, on the one side, we have our data center, in this case on premises. It's got its own IP range. And on the other side, we have Azure with a VPN gateway. And essentially, we just want to connect these two together. We have to have a public IP on the right-hand side. You can see there we've got that VPN VIP. And on the right-hand side, we've got our VPN VIP there. And what we do then is we create an IPsec IKE S2S VPN tunnel between the two, and now they are connected. Now we can also do this across multiple sites, as I mentioned, so we can have multiple data centers with their own networks. Again, you can see in a lot of these examples, we don't have any overlap in address space because that's obviously not going to work from a routing perspective, but multiple sites all connected in to the same VPN gateway. So there's a lot of flexibility there. If you've got a lot of offices or a lot of data centers that you want to connect in, you can do it that way. You could also create multiple VPN VIPs if you want to connect different offices into different VPN gateways and segments of Azure networks. You can really start to carve this out in multiple ways. If we look at some of those specifics, you definitely need to know for the exam, a site-to-site VPN gateway connection is a connection of IPsec/IKE, that's IKE version 1 or version 2. It requires a VPN device in your enterprise data center that has a public IP address assigned to it. It cannot be located behind a NAT, and site-to-site connections can be used for cross-premises and hybrid configurations. If you definitely take one thing away, remember those 4 points for the exam. If we look at point-to-site, then in contrast, this is really about connecting clients directly into the network. So you can see on screen there, we have a number of VPN client users, on the right-hand side, and they could be a mixture of laptop, remote workers, could be people at their desks, but essentially they've got a few options there. They can do an SSTP or IKE version 2 tunnel, as you see on the screen there, into the VPN gateway. Now that's just like VPNing into your corporate network. When you want to access network resources in your corporate network, you might VPN in there. Well, same thing here, you're just VPNing into Azure, and now you have access to your resources in the Azure network. The one thing I will say about this is a lot of people use this in conjunction with, say, a jump box. You might VPN in, connect to a jump box, run it from there, or potentially look at some of the new services like Citrix and Microsoft's RDMI and things like that that are coming out. There's a lot of ways to kind of solve these scenarios. And I'll bring that up because there's a few things you definitely need to know, especially for the exam here. Obviously, we understand it's a secure connection from an individual computer, and it's great for remote worker situations. There's no need for a VPN device or public IP. We can connect wherever we have an internet connection. OS support is something we have to consider, so it's all Windows support primarily at the moment. Throughput and scale is the big thing, though, that we have to be concerned about. Throughput's up to 100 megabits per second, and this is unpredictable due to the internet, and it just doesn't scale easily. This is difficult to manage. It's really only useful for a few workstations that you might want to connect in this manner. Now, in addition, you also need to know about the different VPN gateway SKUs that are available to you. So if you look at the bottom there, starting with the basic SKU, it has a maximum of 10 tunnels available. For the point-to-site connections, it's 128 across all of the SKUs. But the other big difference, if you look at the basic one, it really has a maximum throughput of 100 megabits a second, so that's not very much. You really have to get into VPN Gateway 1, 2, or 3, where they start at 650 meg, going up to 1 gigabits a second on VPN Gateway 2, 1.25 on VPN Gateway 3, and those gateways allow for the max of 30 tunnels, so a lot more flexibility. If you look at it from a recommendation standpoint, pretty much if it's a production critical workload, you're not going to use the basic. You're just going to pick the VPN gateway SKU that meets your throughput requirements. If it's dev test or proof of concept, then sure, the basic SKU is fine. And then at the bottom there, you can also see we've got the SKU, whether it's basic or the VPN gateways, and just the features on the right-hand side. So if you see a few things there on the basic SKU, policy-based VPN does not support point-to-site. I already mentioned it's kind of 10 tunnels maximum. When we're looking at route-based VPN, the policy-based is only 1 tunnel. And then if we look at the VPN gateway SKUs, again, up to 30 tunnels. Point-to-site, BGP is supported, so that's the Border Gateway Protocol for routing, and you've also got custom IPsec, IKE policies, Express Route VPN can coexist, so we could have like an Express Route connection with a VPN failover as well. So that's kind of just a summary of your gateway recommendations there. Now, if we want something a little bit more dedicated, a little bit more private, better guaranteed throughput, we can move up to something like ExpressRoute. And this essentially is a dedicated circuit between us and Microsoft Azure, and it works in a number of steps. So first of all, we have our network on the left-hand side. We're going to choose a partner to work with who's going to provide that connection all the way across to the Microsoft Edge. And then we have the flexibility of looking at the private services or the public services available to us in Azure. And that's really important. If we look at the private services, this allows us to connect directly to anything we've created like VNets, etc. in Azure. The public services, in contrast, this is things like Office 365, as well as services like blob storage, PAS SQL services, Power BI, etc. These are kind of those services that are publicly exposed in a public address space, and we can choose to have those connected to our circuit, if we want to or not. Now, in addition, you've got some connectivity models that you need to choose between. There's three major ones available. One, very common now, is a lot of people started to use these cloud exchanges in a colo location. That could be like an Equinix facility as an example, and they will provide the cloud exchange for you and connect you into Microsoft Azure. We could do a dedicated point-to-point Ethernet connection that could be set up with our partner, and they would help facilitate that. Or we could do something like an any-to-any IP VPN connection over a MPLS WAN type scenario. If we look at the key benefits of ExpressRoute, and there are definitely many here, but let's just hit on some of the main ones. Well, first of all, this is now providing layer 3 connectivity between our on-premises network and Microsoft Azure's network. So it adds a lot of flexibility in allowing us to share resources between the two data centers. It allows connectivity in all regions, so to every Microsoft Cloud service across all regions in the geopolitical region. But in addition, you can add on ExpressRoute Premium add-on, and this allows to Microsoft services across all regions with that add-on, so global connectivity at that point. In addition, we've got dynamic routing, so this uses BGP, so this is the industry standard protocol. So between our network and Microsoft, we have that all built in, and there's built-in redundancy. So in every peering location, Microsoft is ensuring redundancy of hardware at every single point along the way, so we don't need to worry about that in addition. Okay, so you've decided you want to move up to ExpressRoute, but what does it take to get all of this provisioned? Well, there is a bit of a process, and it can take many months sometimes for this to be completed. This isn't as simple as just going into Azure and clicking new service and it's up and running. There's data center work that has to be done. And so there is a workflow. Let's just kind of walk through that. First of all, ensure your prerequisites are met. So you need to have a connectivity provider identified and set up a business relationship with them. Make sure you have your Azure subscription, and you have to set up physical connectivity with your provider as well. Then you go about ordering your ExpressRoute circuit. You're going to select things like your peering location, your bandwidth, your billing model, and whether or not using the standard or the premium SKU. Next, the service provider is going to provision that connectivity. You're going to provide them with some information. There's a service key you have to give them. They're going to provide you with information and get that connected. You'll work together to establish that connection. And then you can start using your ExpressRoute circuit, and you can link your VNets to Azure private peering. You can link to public peering. All of that suddenly becomes available to you. Now, in addition, it's worth noting some of the data that you have to collect. And some things are very, very important, because for private peering, public peering, and Microsoft peering, you're going to have to create some /30 subnets for your path. So for path 1 is a /30, and for path 2 is a /30. That's for private peering. For public peering, it's the same, but you must have a public IP, and same for Microsoft peering as well. So these are pieces of information you have to have on hand in order to be able to establish that circuit. And now it's very important just to know about the /30. Often in the exam, you'll get some questions around space and subnetting, and just knowing around, that those require /30s is very, very important. If we kind of look at one other aspect of this, there's the concept of unlimited versus metered. So if we look at unlimited, first of all, speeds from 50 megabits a second to 10 gigabits a second, you have unlimited inbound data transfer, unlimited outbound data transfer, but you do pay a higher monthly fee for this unlimited option. Now, naturally, if you look at the metered option, well, you still got the same speeds, so you can go from 50 to 10 gigabits a second. You've still got unlimited inbound data transfer, but the big difference is the outbound data transfer is charged at a predetermined rate for gigabyte. Now, there's a lower monthly fee for that, obviously, because you're sacrificing that outbound unlimited data transfer. And obviously there, if you're bringing data in and you're just moving into Azure, metered may be the way to go. But if you foresee a lot of traffic going both ways and just watch for questions on this, then the unlimited option would be better for you. So to end off, let's just take a look at some of the ExpressRoute considerations. There's three major areas. One, just understand the model. So the difference between unlimited data and metered data. If you're trying to do this in your own data center, understand what model you're using today to accelerate adoption, understand the differences in port speeds, locations, and approach, things like that. Understand the providers and what they offer. And finally, understand the costs. If you think of these three things, models, providers, costs, you'll be well on your way to being able to answer any of the ExpressRoute questions they might throw at you. And with that, this ends this module. Hopefully this gives you a good background on everything you need to know from a connectivity standpoint. Like I said in the exam, the questions will be focused around you picking probably the right SKUs around the VPN gateway, so definitely know those. Choosing between ExpressRoute connection versus site-to-site, when to use point-to-site, things like that are likely to come up. And with that, that's the end. Thank you. In order to get started with monitoring for Azure, it helps to understand the way Microsoft looks at monitoring overall. And first of all, we've got monitor and visualize metrics. So this is really two things in itself. One are the metrics themselves that you can get based off things like CPU, disk, all the different services in Azure, and then the visualizations on top of those. You'll see when we do some demos and we go into the metrics view that you can actually look at metrics and visualize them and see them on charts and things. If you're coming from a VMware background, this is very similar to what you would see in vCenter in, say, your performance tab. The next thing you've got is query and analyze logs. And one of the big features they offer in addition to Azure Monitor is log analytics. And we have a pretty large section just on log analytics a little bit later on, which shows you how to query and analyze logs and data that's coming in. That could be a mixture of metrics or log data from a variety of sources. And not only can we just, pull the results of those queries, but we can actually visualize on those queries as well if we want to. And then the final one is set up an alert on action. So kind of the first two are more around kind of analyzing the environment, seeing what's going on, troubleshooting performance, etc. The last one is really around, okay, I know the things I want to look at, but how do I actually take action upon them? And so you'll see the concept of action groups and then tying those action groups to various alarms and triggers that go off in the environment. So with that, that's kind of the brief overview. So just always think about it in terms of these three categories, but we'll show you in the subsequent demos how you can go about configuring all of them. In this demonstration, we are now going to take a look at Azure Monitor and Azure Alerts from the Azure portal. And in the portal, there are a couple of ways to access monitoring. First of all, we can access it from our favorites by clicking Monitor on the left, which is there by default. If you don't have it there, simply click All Services, go ahead and type in Monitor, and that will bring up Azure Monitor for you. So you can click into it here. And while we're in this area, you'll see Monitor and Visualize Metrics, Query and Analyze Logs, Set up Alert and Actions, much like we covered in the previous lecture. But before we dive into it from this point of view, it's also worth noting that if I want to get at it from a specific object, perhaps I've got a virtual machine already built and I just want to look at metrics of that VM without having to go through the monitoring view, I can go over to my virtual machines, select my VM. In my case, I've got a VM that's pre-built here, so VM01. And on the left-hand side, if I scroll down, you'll see monitoring, and we've got alerts, metrics, etc. here as well. So there's a couple of places to get to it, directly from Monitor or directly from the object itself. But we will start in Monitor first of all. So we'll click Monitor, and on the right-hand side, let's go ahead and explore metrics first of all, and opens up the metrics pane. Now, sometimes it's a little hard to see here in the dark scheme, so you can go to your settings and just change it to a lighter scheme inside of Azure, whatever your preference is. But once we've got that up, now what I need to do is choose the subscription I want to pull my metric from. So in my case, I've just got the one subscription, my Visual Studio Enterprise one in this demonstration. So that's what I'm going to pull my metrics from. I need to choose a resource group. So I'm going to choose the one that my virtual machine is in, which is AZ-demo. I could select all if I wanted to. And then the resource types that I want to pull from as well. So I could narrow this down and choose specific services I care about. Perhaps I just want to look at virtual machines. But in my case, again, the subscription I'm looking at, I don't have much I need to filter on. So I'm going to go ahead and just select everything there and then select our virtual machine, which is right here on the bottom, VM01. And then this will pull up the metrics for that specific object. So in my case, I've got a few things here, CPU credits consumed and remaining. That's specific to B series VMs. So nothing you need to worry about too much right here. But then I've got other metrics like data disk, reads, writes. If we go down, I've got network in and out. I've got queues. I've got a very common one that we want to look at, which is percentage CPU. So I can choose CPU percentage, and you can see already, 0.26%. This VM isn't really doing much. You can see it along the bar here, what it predicted it did in the past, and then what it's doing right now in the solid blue bar on the right. Now I can zoom in a little bit there by saying I don't want to look at the last 24 hours. So I just power this machine on. That's why it's kind of predicting and showing that blue dotted line there, because it doesn't really have history for that area. So I can go and select the last 30 minutes. And then we'll start to see something that makes a little bit more sense, like a virtual machine that's just been powered on. It's still got very low CPU utilization. I can go back in and click this VM% CPU. I can also change the aggregation, so I don't have to just look at the average. I can look at the min, I can look at the max. These are all options available to you. So you can choose how you want to, display that information. You can also choose if you want it to be in a line chart, if you want it to be in, say, a bar chart, so you can just look at the CPU over time. Depending on how you're troubleshooting, perhaps you're in a war room scenario, this is where you can sort of get, different views of that data and present it differently. Now, perhaps I want to put this on my dashboard. Perhaps I really care about CPU on this VM. This is something I'm looking at a lot. Well, I can click Pin to Dashboard, and I can pin to the current dashboard or select another dashboard. I'm just going to pin it to the current one, and then I'm going to go ahead and click Pin to Dashboard. I could also click Dashboard on the left-hand side here, but this is a shortcut. I just click Pin to Dashboard, and then here is my dashboard. Again, I can create new dashboards if I want to, but if I scroll to the right-hand side, here is that widget that's now on my dashboard. And if I want to, I can edit this dashboard as well. So I can move this guy around. So I can move him under, this section. I can move this around. It's really just a canvas for you to, ultimately play with and put whatever monitors you care about on there. To create new dashboards, I click this plus sign. That creates my new dashboard. And I can also upload and download dashboards as well, which is really handy for sharing things between colleagues. But that's basically, the dashboard created there. I've got my metric, my CPU metric that I've got there, all very well and good. But what happens if I want to see a little bit more? Let's go back over to the virtual machine itself. and select VM01. I don't really want to go through monitor every single time, so I'm going to scroll down on the left-hand side here, and I can check metrics directly from in here, and you can see source is already filled in, the namespace already filled in, and I just choose my metric there. Well, going back even further, if I scroll to the top of this area and select the overview for my virtual machine, and this is the same for a lot of other Azure services as well, and I scroll down on the right-hand side, Microsoft has created pre-canned widgets for you associated with the object that it thinks you might want to look at. So, the CPU average, that's the one we just created manually, that's available there. If I want to look at network throughput, that's available to me on the right, and same with disk operations as well. So all of these are available there. And again, if I want it on my dashboard, let's say I want this network one, I can simply click the pin option, and that pins it directly to the dashboard for me as well. Now, what if I want to start alerting on things like that? Well, again, we'll go to the monitoring view, so we'll select monitor, and we'll go in this time and click create alert. So slightly different screen here. What we need to do is create rules first of all. So if I want to create a rule for that virtual machine, perhaps when the CPU exceeds 90%, I will select that resource. So this is the resource I want to monitor first of all. Select to filter, so I can filter on virtual machines. I choose VM01. And I click done. So right now, that is my object that I care about right now. The condition is what do I want to signal on, basically. What signal do I want to alert on? So in my case, it's got some suggested ones for us. I want to choose %CPU, and then I can choose to show the history over a longer period of time if I want to. Right now, it's just showing the last 6 hours. And if I scroll down, so there's the metric graph, much like we saw if we created the metric monitor that we saw previously. But here is the alert condition. So the condition greater than the time aggregation, same options there as well. So we've got average, maximum, minimum, total for CPU. So I can average it out and say, okay, anytime it goes over 90%, so whenever the CPU is greater than 90% over the last 5 minutes and check every 1 minute, that's what I want to take an action on, basically. So now if I scroll further down and look at action groups, this is what I want to do with that alert. So let's say the alert is fired. Who do I want to notify? What do I want to do? And so I have to create an action group if I haven't got one already. If I already had an action group, I could select an existing one, but I'll create a new one for right now. And give it an action group name. Perhaps I want to email IT team as an example, and I'll just call this one email IT. And here I'm basically going to choose my resource group where I want to basically keep this action group. So I can choose to keep it in my default activity log alerts, which it will create for me. And then I need to choose the action. So let's say again, we want to email as our first action and choose the action type. And these are really important. And you can see there are a number of them here. So we've got email, SMS, push, voice. So if I select this one, this is where I would come in here and choose, okay, I want to email help@helpdesk.com, just a fake email I'm putting in there right now. I can choose to text message somebody, etc. All of those options are available there, and I'm just going to choose email for right now. But I could also go in and do other things. Let's say I wanted to cut a ServiceNow ticket. I want an incident ticket because this is a really important, alert for me. I want to make sure that we log that in our ITIL system. And so I would choose to use the ITSM connector in this example. And then I would go ahead and use my ITSM connection that I would have created separately as part of a ServiceNow, say, integration. So that's another option there. In addition, you also have the option of automation runbooks. And these are key. I often see a lot of people starting to use these now, where you can choose to run a runbook that you already have. And there's some already created for you now. So you've got restart VM, stop VM, scale up, scale down, remove VM. So, perhaps in this particular virtual machine by itself, I've hit the CPU alarm. I want to change it to a higher instance with more CPU. I could do that as well. So there's a lot of options here, in terms of the action group, not just send the email, but I can add multiple actions. I could email somebody, I could create a ticket, and I could say restart the VM if I wanted to as well. All of these things, you need to decide what you want to do based on your specific scenario, but lots of options available to you. In my case, I'm just going to choose the email option, so I'm going to click OK there. It's going to create that new resource group where it'll put those activity log alerts, and then we'll create that for you. Then I just need to give the alert rule name, so I can say, CPU over 90%. So I've got my group. In fact, I need to go back and select that group, which created it, but I haven't selected it yet. So now I've got the group selected, CPU over 90%. And got the percent in there, so CPU over 90 we'll call it, can't have that character in there, and choose a description for the alert. So the CPU went over 90%, help, whatever you want to put in the description for the incident. Obviously you'd be more professional in an enterprise scenario. Then you choose the severity, so this is how important it is to you. If it's a Sev 0, it's normally mission critical. If it's a Sev 4, perhaps it's not that critical for you. And once you've got all that created, go ahead and enable the rule upon creation and create alert rule. This will take a little bit of time. It's essentially going to continuously monitor that virtual machine anytime that metric is exceeded, it will fire off that email, and you can see it's actually already completed for that specific one. Others do take a little bit more time. And with that, that concludes alerting and metrics. The final thing we just need to cover is something called diagnostic login. So if we go into virtual machines again, click VM01, and we scroll down to monitoring and choose diagnostic settings. If we look in here, you can see that Azure Monitoring collects host level metrics by default, so CPU, disk, network. But what it doesn't show us is guest level metrics. So these are the metrics. If you open up just your Windows laptop and go to the performance monitor, or on a Windows server, you've got, application logs, you've got performance logs for your CPU that Windows is detecting, the Windows operating system. The host level metrics are what Azure sees from the hypervisor. The guest level metrics are what the operating system itself sees. So we can choose to enable these guest level monitoring metrics as well. You'll pick a storage account. There's probably one already created when you created your virtual machine. You may want to centralize all of the storage account login for guest level metrics. That's a decision you will need to make as part of a wider strategy for monitoring. But for right now, I'm going to select enable guest level monitoring. And what that does, it updates the settings for that specific VM, so it can start to gather additional data from the virtual machine and report those logs in as well. And what will happen is you will get additional metrics once this piece completes. So when you go into the metrics section, when you scroll through here, you will see not just the host metrics, but also the guest level metrics as well. And you can start to choose if you just want to see what Azure's reporting or what the system is reporting as well. And with that, this concludes this demonstration. This hopefully gives you a great base in terms of monitoring. What you definitely need to know for the exam is how the metrics work, what are some of the options. So you can do averages, min, max, etc. How you can adjust, your time period to look at, and then make sure you know how action groups work. You'll probably get some questions around action groups and what's happening, maybe perhaps in a screenshot. You might need to know that it's sending an email or it's going to go over to the ITSM connector. All those things are, really important for you. But with that, this concludes this demonstration. To get started, let's take a look at some of the key features of Log Analytics. Well, the first one is that it plays the central role in monitoring. So it's not necessarily the tool that is doing all the metrics and performance data gathering. That's typically done on other systems, maybe the Azure PaaS services, maybe your Windows event logs, things like that. But everything is funneled into Log Analytics, and it's a central role that it plays in bringing all of this data together. The next thing is data sources, and we've also got other log analytics sources which we combine when we talk about this. And data sources are things you can connect log analytics to. So these could be virtual machines that you want to plug in and get data on. These could be system log events, Windows log events, performance events, etc. And then you've also got other log analytics sources, so things like Security Center and App Insights, which use their own sort of log analytics under the covers as well. And so these are two sets of sources that you can use, whether you're manually saying, hey, I want to get data from this machine, or I want to ingest data from other log analytics sources native to Azure. Then we've got the concept of search queries, which you'll see a lot of in the demonstration. So again, I encourage you to check that out because this will talk everything through. But once you've got all that data in there, we do queries on it to then output the data. And there's a variety of output options available to us, as you'll see. In fact, if we look at the log search use cases, and if we look on the left-hand side, first of all, we've got things like Azure Monitor, Virtual Machines, Operations Manager, that's SCOM. If you're using that on-premises, that System Center Operations Manager is what that stands for. You've got Application Insights, Azure Security Center, PowerShell Data Collector, all these different sources of data that come in. The incoming data is automatically indexed, data types and tables are automatically created, and then the data is available for log searching and smart analytics to multiple channels, and those channels you see on the right hand side. So we can design and test queries in the log analytics engine, we can visualize data in the Azure portal, we can send a log analytics search query and design it so that it triggers a logic app, or perhaps sends an alert, or perhaps goes to Power BI and we've got a whole visualization there. So you can kind of see the role it's starting to play. It's kind of that middle piece that we have here, and it brings all of this together. If we look then at the architecture, on the left-hand side, to kind of expand upon that, we have our data sources. We also have the concept of solutions. So solutions are third-party solutions that you can plug into Log Analytics. In fact, it's kind of a marketplace for them, where you can go in and say, add things like Network Watcher and other services that are out there. And then all that data comes in, it creates these records, and then you perform your log searches against these records and then say, okay, I want to alert on that. I want a dashboard for that log search. Or I want Power BI, etc. In fact, if we go a little bit further and we look at things like the data sources and break them out, you've got logs and performance there, plus those third-party solutions, and you can see that data comes in and creates those records, but they're in a series of tables. In fact, if you look at it again another layer deeper, and we say, look, Windows event log comes in, it goes into the event log table. Syslog goes into syslog. Agents might go into heartbeat if it's something where we're just checking if something's online or not, like up-down type alerting. Custom logs, alert rules. You can see they've got all these tables there. And what you will notice, and this will be expanded upon when you go through the demonstration, but you've got this concept in the query. You see where it says event and then union syslog. So you can query across multiple tables. And again, that'll become more important a little bit later on, but worth noting for right now.
If we look at those data sources, this is a summary of the ones that are available to you. So you've got the concept of custom logs, first of all. Those are text files on Windows or Linux agents containing log information, and they go in the event type log name _CL. We've got Windows event logs, which are event type event, Windows performance counters, which are under perf, Linux performance counters, also under perf, IIS logs, which are W3C, IIS log, and syslog, which are under syslog, which are syslog events on Windows or Linux computers. The last thing we'll leave you with in this lecture are some search query fundamentals, which I encourage you to write down and just make sure you've committed these to memory, as they will help you tremendously when you're getting started with log analytics. To begin with, start with the source table that you're focused on. So if you're focused on event logs, let's start with the event table. Then follow on with a series of operators. So perhaps I'm doing a query where I want events on a specific computer. That would be my first operator to set the condition to be that computer. Then perhaps I want a specific event ID on that computer. I use pipe to separate out additional operations. So now I'm starting to narrow down my search in particular for that event table. But now if I want to join other tables and workspaces, I just need to use that union command that I showed you in the example earlier, and then I can search across multiple tables. So perhaps I'm looking at errors in IIS on systems that are showing a high CPU performance metric. So the performance metric will come from the perf table. The application insights table will provide perhaps my transaction times for my users that are accessing my website. But I can combine these using union, so I can get a query that says, okay, when the transactions hit a certain threshold and the CPU is this high, I've got a correlation here that I can work with. And with that, this concludes this lecture series, and hopefully this gives you the fundamentals you need. There's definitely questions starting to appear for log analytics on the exam, so definitely make sure you know how to query around, especially as you hit the upcoming demonstration. In this demonstration, we're now going to take a look at log analytics in the Azure portal. And if you're not too familiar, log analytics has undergone a number of changes recently. So if you looked at this maybe a few months ago, basically early in January 2019, Microsoft ultimately changed everything around, and log analytics, ran through something called the OMS portal primarily. And now things have all been migrated and blended into the Azure portal as a whole, which makes it a lot easier to get to. So let's head over to the Azure portal and we can show you how to get started there. Now in the Azure portal, a couple of things to be aware of. As you probably saw from when you looked at the monitoring earlier on, we can go to monitor and there is a section here called logs. And this is essentially where we can query and analyze all the logs coming in using log analytics. If I click logs straight away, what you'll see on the right hand side as it loads up here is the workspace for log analytics that opens up. Now you might already have a default workspace in there. In my case, I've moved over and actually told it to look at the log analytics workspace I've created. I'm going to show you how to create one of those in just a second. If you're unsure, just go ahead and click the little settings, select workspace option here, and this is where you can change the subscription and workspace that you're connected to if you so desire. But with that said, let's go ahead and create a brand new log analytics workspace, and this is where you'll connect data sources to. This is where your logs and data come into, and then you can query them and create graphs and nice charts and everything else from there. So let's go ahead and do that. So we'll go to create a resource and we'll type in log analytics. That comes up and we'll click create. And you can see here, first thing it says create new or link existing. So if we want to, we can link to an existing log analytics workspace that we have out there. I don't have one in my case, so I'm just going to go in and create a new one. But if I click create new, we'll be prompted for the name. So I'm going to call this AZ demo temp, because I actually already created one which we'll use for the demo, but I want to show you how this gets created. So I'm just making this one temporary in my demonstration. I choose my subscription because I do get charged for log analytics, as you'll see in a second. And then I choose the resource group, or just give it a new one. So let's call this temp log analytics RG. Choose the location where all the data is going to be stored. So I'll just use East US, and then my pricing tier. Now, historically, there were a number of pricing tiers, but the new arrangement is basically per GB. So you just pay for the storage utilized. It's a simple pay-as-you-go model that you basically have now. With that said, we'll just click OK. And that goes ahead and initiates that deployment, and that'll take maybe a minute or so. Now, while that one's deploying, let's go ahead and look at one that I've already got created. So I'm going to go over to resources. I'm going to scroll up to resource groups, and you'll see I've got a resource group here called AZ Log Analytics. If I click into that one, you'll see what I've got inside here, which is a couple of VMs. I've already pre-provisioned, so I've got a Linux VM, a Windows VM, which I'm going to use to show you some of the logs and performance reporting. And more specifically, if I scroll to the top, this is my workspace, AZ Demo Workspace, Log Analytics Workspace, which is in East US. So if I click into that, that'll take me to my Log Analytics Workspace. And on the right, before we begin, you'll see getting started with log analytics. It's got things like connect the data source, configure your monitoring solutions,
and then maximize your experience by searching and analyzing logs and managing alert rules. And we already covered alerts and action groups already, which is something you can link to log analytics, and search and analyze logs is where we're going to spend a bit of time in this demonstration. Now, before you can go ahead and search and analyze logs and get anything meaningful, you do have to connect data sources to log analytics. Basically, you've just created an empty workspace. There's no data being fed into log analytics. So if you scroll down, the first thing you want to do on the left-hand side, if we scroll all the way down, you'll see workspace data sources. And if I click virtual machines to begin with, and you'll see here I've got Linux VM 01 not connected, and I've got WinVM, my Windows VM, connected to this workspace. And if you have lots and lots of machines, you might connect them all to the same workspace, you might connect them to other workspaces. The good thing is you can query across workspaces, you just have to specify the other workspace when you get to that point. But the major point being here is that this is where the logs are being sent to. So this Windows VM, I've already configured it to send logs to this workspace. Now, how do we configure it? Well, let's do it for the Linux VM because that one's not connected yet. So if we click this one, and you'll see there's a simple item at the top here that says connect. See, it says not connected, status not connected, no workspace name, VM is not connected to log analytics. If I click connect, it will go about connecting that VM in here. And essentially there's an agent that runs on the machine that pushes the data up to log analytics. So we'll let that one go ahead. But the good thing is we've already got that Windows one connected, so we can start to pull data from it. Now there's a few other things we need to configure as well. So aside from saying, connect my VMs in, and you might not want to go in and click every one of these each time. So you can automate that in a couple of ways. You could do it using Azure Automation, or more specifically, a lot of people, one of the Azure Security Center settings is to make sure the VMs send their log data in as well. But with that, let's jump to the top a little bit now. So I'm going to go up to the advanced settings because it's one thing to say connect the VM to log analytics, and you can see here if I go to advanced settings, connected sources, Windows Server, one Windows computer connected. Linux should still say 0 because that one's not configured. Here are the manual steps to configure it as well. So you can download the agent, you can log into the machine, install the agent, and then use these keys to connect it in if you want to as well. Again, that's how we connect services in, and you can see that Linux VM1 has completed while we've been going through this demo already. Now if we go to data, next thing we can see here is the Windows event logs, Windows performance counters, Linux performance counters, etc. And we can go here and choose the log that we might want to send over. So perhaps we type in system, and we can send the system log from Windows across, and we can press the plus sign here, and now it's going to send the errors, warning, information logs from Windows across there as well. We could type application, and we could get all the application logs sent across as well. So just remember, this is the same as on a Windows server. If you log in and go to your event viewer, you'll see those logs there, and it's the same concept basically. Same for performance counters. If I click down, go to performance counters, remember we've got all that data from the hypervisor that Azure basically can monitor already there in our metrics section. But what if we want to get additional data like logical discounters, memory, etc.? These are all OS-based metrics that we want to get from inside the OS. We can simply click add the selected performance counters. Here they are. Choose the interval you want to collect in, and those will be added as well. If we go down to Linux performance counters, same concept. We click this little box at the top first of all, and here we've got a whole bunch of Linux counters here that we can add as well. And again, we can continue on for other counters and logs that we want to add. And when we're done, we simply click save, and then that will adjust those settings for us. And there we go. Configuration was saved successfully. If we scroll back over to the left all the way now, I'm going to drop all the way back down on the left-hand side. I know we're sort of jumping around a bit, but it's just the nature of the menu system here. So again, we've got VM as a data source, and that's connecting those VMs in. Where I just was now in advanced settings, that's the type of data I want to collect from those sources. But there's other sources we can have as well, like storage account logs, Azure activity log. This is a very common one. A lot of people use the activity log, and you can see here, here's my subscription. And if I want to get the activity log for that entire subscription, I can click this one here and connect that in as well. And now Azure is going to send those activity logs, all the things that happen in that subscription, up to log analytics as well. So you can see it's very powerful, but can get very, very large very quickly because you start connecting more and more data sources in. You can have custom data sources as well, and you've got a lot of data going into log analytics. So that's step one. And if you are doing this and trying to follow along from a demo perspective, make sure to do this. Connect a bunch of VMs, maybe run some performance, intensive application on them, so you get some data kind of sent in. Wait 30 minutes before you kind of proceed with kind of the next things that I'm going to show you here. So if we go back over to AZ Log Analytics and go into our workspace again, now what we'll do is go to the log section. So I'm going to go down and click logs. Now again, I can go to Azure Monitor on the left hand side, scroll down, click monitor, and I could click logs from in there. I'm ultimately getting to the same place. I just need to make sure I'm looking at the same workspace. But lots of ways to get to the same information, and that can be a little bit confusing at first. So don't worry, just make sure you're in the correct workspace to begin with. So here we are, and I'm going to scroll to the right a little bit, and you can see this is the query area where I can ultimately run queries. Now Microsoft does show you a bunch of them below. Select queries for heartbeat performance usage. Again, there's those tutorial sections on the right as well if you want to get more information. But I'm going to
to start you off with just some simple things to try, first of all, to get used to the platform. So I'm going to zoom out a little bit here, and then immediately let's go in and type a query. Let's start with a very basic query in this section, and we can go ahead and type perf if we just want to look at the perf logs, and you'll see the IntelliSense starts to complete that for you. But if I just type perf and click run, you'll see it's gathering the data, and here are all those different counters. So you can see logical disk on the Linux VM, disk transfers, 3 megabytes, performance, etc. Those are all there. I can also go in and just type in heartbeat as an example. Now the heartbeat tells us if the agent has ultimately checked in. So again, just heartbeat, nothing else after it. You will notice if you type in with IntelliSense and you tab through, it'll sort of fill it in for you and get you onto the next thing, which we'll come on to shortly. But if you're just trying to type heartbeat, make sure you don't have anything else there, just heartbeat, and then click run, and then you can see how it's putting in that data, and I can click into one of these, click through here, scroll down, and we can see what machine it came from. So we can see Windows VM01. Here's the IP address of that machine. Scroll further down again. We can see that type heartbeat. So that's our heartbeat data that we've got there. Well, that's not super useful just by itself. I mean, if you just want to get data of all the heartbeats, great, and you can certainly choose to put it in a table or other formatting if you want to, and you can filter by time range on the top here as well. But probably a little bit more useful. Let's say we just want the heartbeats from Windows VM01. So I'll do heartbeat, and I'll do pipe to where, so I can tab through that, where, computer, and I'll tab through. You do equals equals, so that means is equivalent to, and I can put quotes win VM 01, and let's actually just check the spelling of that. It is case sensitive, so yeah, win VM 01 looks correct, and click run, and now I'll get that data, and it'll just be all of the heartbeats for win VM 01. Okay, so we're starting to get something there, but what about if I say, okay, I just want the heartbeats where the time generated was in the last hour. So again, we can pipe that again, and I can say where. I can do time generated. Again, we can tab through because it does help you here. We can do greater than ago, and then we can put in there 1H for 1 hour, and click run again. And let's see what happened there. Oh, it should be a lowercase h. So we'll hit that and click run again. And we can see here's all our heartbeats, and if we look at the timestamps, they're all within the last hour. Okay, so that's heartbeats, useful if we're just trying to troubleshoot as an agent checking in and maybe troubleshooting the service itself. But something that's very common are events. So let's go to event. Again, we can type in just event, and actually I do this every time I'm trying to create new queries, is I just query the service I'm trying to get it from, just to make sure I've actually got data here. So as you can see, there's only one event ultimately, coming in right now from WinVM01. Well, it's a new machine, not too much has happened with that machine, but I do have an event ID that I can use to show you something, a little bit more advanced. So I can say, well, what if I just wanted events where event ID, so where event ID equals, and I can do that event ID 7036. And if you're not sure what that event ID is, it's a common one, just shows that a service has entered a run-in or stopped state. In this case, it's the WMI service in Windows itself. I can click run on that, and that will pull up that log. And again, I've only got one right now, but if you had lots and lots of events from Windows that were pulled in there, then those would come in, for you as well. Okay, so that's events, heartbeats. Let's go back to performance, because that gives us a little bit more data to actually play with. So if we go to performance now, so again, perf, I can do where, time generated, again, ago. So I can do, say, 1 hour, and I can do where counter name equals at quote percent space processor time and end quote. Again, make sure you got the space between the percent and processor and time, and then click run. And as you can see on the bottom, here are all of our counters for processor time. We've got counter values, the instance that's affecting. So you can see you've got Linux VM01 here, and we can tab through. Yeah, if we keep going, you'll see we've got some WinVM01 and Linux VM01. All with different kind of processor, CPU utilization. Now, that's not super easy to view in a table, so perhaps we want to render it as a time chart. So what you can do now, a little bit more advanced, you can basically pipe this to a summary. So summarize, and then we can do average. So we'll say the average, I can tab again here. I'll choose the counter value that I want to actually filter on. So this is the counter value. That's this column that you see here, which actually has the value of CPU time. Now I can do it by computer. So if I want to, I can say by computer, and then we can do with a bin size of, let's say we want to do every 15 minutes. So if time generated 15M, and then we can say, okay, we want to render a time chart out of all of this. So a few extra things we've added. We're summarizing by the counter value, by the computer, and we're using a 15-minute interval there. So let's give that a go and run that one. Okay, we've got a syntax error here, so let's see what that is. Okay, it looks like I just forgot to close a
bracket right here. So we'll put that one in and click run. And there we go, there's our visualization, and you can see right now it's got Linux VM 01. Not seeing much data for WinVM 01. You can see the little dot down here, and that might just be that it hasn't got enough data for it. Now we can also zoom in a little bit, so we could change this time generated to be just say 1 minute, and the graph will start to form a little bit better, as you can see, because now we're sort of breaking it down in 1 minute intervals, and we can see there's some, CPU activity within those thresholds, but there wasn't when we just kind of looked at the 15-minute bucket averages that were there as a whole. So with that, that's how you query logs. Now, you're not going to keep going through all logs here. This will definitely get you what you need for the exam. Just know how to kind of read these, understand how they work, and then you can basically go from there. Now let's move on to alert rules themselves. Now what you can do is you can take the query that you have and immediately go in here and click new alert rule. So any queries that are out there, anything you find out, on the web that, other people have created around log analytics and the queries, then you can basically go in here just like we did with alerts and action groups previously. The only difference being that your source now is going to be the workspace. You'll need to define the conditions that happen. So you can click in here and decide, what is your signal logic that you basically want to query on. So again, here right now, if you put your query in, it's going to take the last one that you had and actually put it right there. And then you would put your alert logic below. Now, just doing something off a query like a time shot isn't probably super useful. It would just be things like, okay, number of results. If there's a lot of results greater than X, then maybe set an alert. But you could do things like number of heartbeats received. You could use those queries, and then you would just carry on as normal. We're not going to revisit this right now because we already covered action groups. But you would choose your query, choose your conditions, and then choose your action groups just like you would everything else. And that's one of the beautiful things about Azure, is just the way that you can use the same concept from action groups to decide what to do with events, and events can come from different sources, whether that's something like we're looking at now in log analytics, or some of the metric monitors that we looked at in one of the earlier demonstrations as well. So we'll come back out of this now. I'm going to come out of action groups and rules here and go back to our workspace. And here we are back in the workspace. And the last thing I want to show you are the solutions area. So if you are coming from a previous OMS, background, solutions used to be in the OMS portal. They've all changed now. They've embedded solutions directly in now on the left-hand side. Now, to get solutions in here, you no longer have the menu inside of log analytics. You go to the marketplace for them. So if we go up to the top left and click create a resource, up comes our marketplace. And if we scroll down on the left-hand side, you've got management tools. And on the right-hand side, if I expand the featured list here, you'll start to see all those plugins that previously existed. Again, if you're familiar, with log analytics before. Common ones, security and compliance, patching through update management. This is a common one. A lot of people are looking at this now to even replace services that perhaps they had on premises before, like even Blade Logic and things like that. So if I click in update management and say I want to add this pack in, this comes with a whole bunch of dashboards, a whole bunch of queries, a whole bunch of additional things that you can utilize. This one actually uses Azure Automation to do a lot of patching and things like that. And you simply click create. I'm going to zoom back in a little bit here now. Choose our log analytics workspace that we want to use. I'll do AZ demo workspace. And then you'll see there's some additional settings that you sometimes have to utilize. In my case, this particular marketplace edition requires that we have an automation account as well. So in our case, you'd create an automation account. This is Azure Automation, covered in a different lecture entirely, that I could create here and now, or if I had one already created, I would simply select it. But I don't need to go and set that one up now. I'll show you a couple others. So if we go back to the management tools section, one common one is this security and compliance one. So if we click this one and click create, similar concept, select your workspace and recommended solutions I might want to add as well. Click create, and that one's going to go ahead and deploy, and we'll fast forward here while that completes. Okay, and that's completed, so we'll go to that resource, and to access it, we go to the workspace and then into solutions, and then we would select, in our case, this anti-malware solution there. Now again, just to remind you where to get to that, we can go back to the workspace, log analytics workspace. Sometimes you get a few blades deep and it's hard to find. If you're in the workspace, scroll down, go to solutions, and there you'll see that security and anti-malware solution that's in place. I can click the security one now as well, and you'll see on the right hand side some of these dashboards that are already now created for us. And you can also basically get the queries as well. So any of the kind of pre-created little widgets that you like, you can go ahead and gain the queries from those as well, just like Security Center. Now again, if we go back one more time, the last thing I want to show you in the section, this is a pretty big demonstration, is the View Designer as well. So if I click the View Designer, this is a place where I can take queries and start to design my own little widgets based on queries as well. Now some pre-canned, it'll show
show you how to do it. So if you click the donut as a common one and put this on, this is the overview tile. So this would be the overview that you would then, click into to drill down and get more information. And then you've got the view dashboard where you can put additional things in there. Maybe it's lists of queries, maybe it's number lists. It's information you want to show. Maybe it's stacks of line charts of performance. Maybe your favorite application that you're troubleshooting, that you work on day in, day out, and you admin, you want to create your own dashboard for that. This is where you essentially would do that. If I go back to the overview tile for a second, you'll see when I click the donut, in my case, it's pre-filled some things for me already because we've got perf logs, heartbeat, and Azure activity. Those were those data sources that I was connecting in previously. And I can give a name for this view. So we'll call this Nick's view. Give it a description if you want to. And if you scroll down here, you can see those queries. So here's the search. It's summarizing the aggregate value, and it's purely just a count of those particular logs of perf, heartbeat, and Azure activity. If I scroll further down again, you can see we can modify the colors and things like that as well, and do any data flow verification that we want to, which is not in scope for what we want to do right now. But with that, once I'm done, I can simply click save. And then now I've essentially created my own view. So you can see Nick's view here, and then I can click into there. There won't be anything there because we didn't create anything in that second section. But if I want to, I can continue to create more and more views inside of that major view. So again, I'm drilling down deeper and deeper as I go, but I do have to facilitate that with a query at every single level. And then if I want to, if I go back to my overview, if I want to, I can pin this to my dashboard. So I can say, okay, I want this on my main dashboard in Azure. Now it's pinned. I can click the dashboard, takes me to my main section, and I can rearrange this just like any other dashboard widget I've got. But now I've essentially got it here, and I can put it in, any dashboard I want. So a lot of power, a lot of things to cover in log analytics. Key things to remember: know the basics of the query language, know how to read queries, know about the view designer and the solutions that have ultimately been moved, because that did go through a lot of change. And last but not least, just again, remember the alerts and the action groups, just like you had from the previous demonstrations. And with that, that concludes this demonstration. One of the items that Microsoft expects you to know about around subscriptions is billing alerts, and to access these, we'll head over to the Azure portal and then over to the account screen. Okay, so here I am back in my Azure portal, and the first thing I'll do is go over to my subscriptions, which I can access from services, or if you favorited it in the previous demo where we walked through a trial subscription, simply click subscriptions at the bottom in your favorites panel. Click our subscription. In my case right now I'm on the free trial subscription, so I'll select that one. And then I'll go ahead and click manage, which will take me to the account screen now. Okay, and once I'm in my account screen, you can see I've got my subscription status as we discussed when you created the free trial. But if I go ahead and click preview features, and you'll see an option for the billing alert service. Now right now it is a preview feature, so by the time you take the exam it may just no longer be in preview and be a standard service, but they do call it out as a preview feature currently. The billing alert service, if you want to activate it, you simply have to click try it now, and that enables the preview service for you. So we'll go ahead and select that, and that turns it on for us, and it takes a few minutes sometimes for this to activate. After a short while, you'll see that that is activated and it says you are active. So at this point, if we refresh and go back to subscriptions, we should now be able to enable billing alerts on our specific subscription. So there is our free trial subscription if we select it. And now on the top under summary for free trial, you see it says overview, billing history. We also have alerts, which is that preview feature that we activated. And if we click alerts, it takes us in there and you can see that we can add up to 5 alerts. If we click Add Alert, the alert screen will pop up. We can give a name to our first alert. So we'll say, this is when we've spent, say, $10. And this is an alert for the billing total. You'll see there's other alert options we can do as well, such as monetary credits. So if you've got a credit from, say, a MSDN subscription, you could select this one, and when you hit a certain amount remaining, it can alert you. But otherwise, we'll simply select the billing total. You choose the amount spent, so when the billing total hits $10, we can send it to an email recipient, and that is basically all there is to it. If you want another recipient, you can add an extra one there, but we simply click save, and all that's going to happen is when we hit that $10 billing total for the month, it will send us a billing alert via email to let us know. And if you want to see if the alert's sent, you can come back here and you can go to your summary section again of your subscription, and if you look under alerts, you'll see if we expand this out, this is the specific alert. We can edit it if we want, and we can see that it hasn't sent a notification, and that's because we just haven't provisioned anything yet in the subscription. But if we exceeded the $10, then it would send that out to us. Now if we say we're done with this alert and we don't want to keep getting alerted for the $10 spend, we'll simply click delete, and this will clear it out for us, and we no longer have that billing alert. But that's one of the key ways where you can just get notified in the event that a certain amount of spend is exceeded. In this demonstration, we're now going to take a look at Network Watcher. So to begin with, let's head over to the Azure portal.
Okay, and here we are on the Azure portal, and the first thing I've done, I'm just showing you that I've deployed 3 virtual machines already. I've got VM test 01, 02, and 03, and they're all in the resource group SL-network watcher, which I've already created. Now, one thing to note first of all, in order to use network watcher, you do have to install a network watcher agent in the machines that you might want to use the connection monitor feature with. So here's an example. If I go to VM test 02 and scroll down on the left hand side, you'll see the section called extensions, which if you did the AZ100 exam or other Azure training, you will probably be aware of. And this is where you can add different extensions, agents, chef agents, things like that. But one in particular is that network watcher extension. You can see it's already installed on this one, and this is a Windows machine. If I go over to VM test 03, this is a Linux machine where we've also installed, then you can see it's operating system Linux here. And if we go to extensions, and you can see again the network watcher agent is there. But just to show you how to install that, I'm going to go to test 01 where I haven't installed it yet. This is also a Windows machine. And we'll go down to extensions, click add, scroll down the left hand side, and you will see network watcher agent for Windows. And when you're building your virtual machines for the first time, you can also do it during provisioning. But we'll click network watcher agent for Windows, click create on the right hand side, click OK, and you can see it's initializing that deployment and it's now deploying that agent. So it's logging into the machine and actually setting up that agent service to run inside the machine. So at this point we can come out of the virtual machines and let's focus now on network watcher itself. To access it, click all services, type in network watcher, and you'll see it there. It's probably worth favoriting it because you'll probably come back to it periodically. Click network watcher, and this takes you into the network watcher overview section first of all. Now on the right you'll see your subscriptions and you'll see the regions that are supported by those subscriptions. So in my case I've got Skylines Primary is the one I want to use. If I expand this out I can see the regions and whether network watcher is enabled or not in that particular region. So I've deployed these machines in North Central. I've already actually enabled network watcher in that region. Let's say I had deployed them in South Central. Well, I would just go over to South Central US, click these 3 little dots on the right for the context menu and click enable network watcher, and that will deploy the network watcher to that specific region as well. So just be aware of that. That's how you enable it, and you may get some questions on this on the exam itself. So with those enabled, let's take a look first of all at the topology view. So I can click this. This is under the monitoring section, choose my subscription, Skylines Primary, select my resource group, SL Network Watcher, and immediately it will actually load up and show me, okay, I've got my VNet, my subnet, I've got 3 network interfaces in there, and those are the network interfaces associated with those 3 VMs respectively. So it's quite a nice way to just get a viewpoint of what's going on in your environment, and you can also download that topology if you want to as well. Next, we'll take a look at Connection Monitor. So let's click Connection Monitor on the left-hand side. And what we can do with Connection Monitor is basically track the connection between, say, 2 of our virtual machines for latency, can they reach each other, etc. So we click the Add button here to create a new monitor. And we'll say from VM Test 02 to VM Test 03. And we choose our subscription and the virtual machine. So we'll choose VM Test 02. And our target machine, VM Test 03. And we'll say port 22, which is our SSH port that we want to connect over. Again, we're connecting from the Windows machine to the Linux machine. We'll click Add at this point, and that will set up the connection monitor for us. Okay, and after a little while, that should complete. If you don't see it, just change the subscription to the one you created the monitor in, and then it should show up for you there. And here you can see the monitor, and if you click the context menu, you can start, stop, or delete that monitor from there. Now, to get the details, you need to click this details pane on the bottom, expand it out, and you might just need to move it up ever so slightly. Then you can scroll down and now you can see details from that monitor. So we can see if we scroll down, average round trip time 1 millisecond, so we know everything's working great there. No probes have failed at this point. We can also get some more information, so we can see that VM Test 02 is connected on 10.0.0.5. Its next hop IP address to reach that machine is 10.0.0.6, which is actually the IP of VM Test 03. If we scroll back up as well, you could get metrics on this. You can see the graph, you can sort of change the time, look at the data. And if you scroll down again, you can also create a topology view to kind of look at the connection between those 2 machines. So in this case, nothing big there. VMTest02 is going to basically, as its next hop, go into that VNet, which VMTest03 is in, and it's basically going to connect over 10.0.0.6. So just a great, area for just monitoring connections between machines and just checking the overall health of them as well. So now we've covered connection monitor. Let's scroll back over to the left. You'll notice you now have a link for network performance monitor. They recently added this. We're not going to cover details of NPM in this course. We sort of mentioned it in the lecture section, so you need to know what all the NPM monitors are for, but this is where you would add your NPM monitors that are as part of your log analytics workspace at this point. What you do need to know, however, is these things around IP flow verify, next hop, and security group view. So if we start with IP flow verify, this is a way to check if a packet is allowed or denied from a virtual machine. So again, we can sort of go in here, choose our subscription, pick our resource groups, already got it there, SL Network Watcher, pick our virtual machine. We'll take VMTest01 at this point. It'll automatically select this interface once you've selected the virtual machine, and say, okay, well, what about an outbound flow? So let's say we want to go from VMTest01. Let's say we want to ping the Bing address as an example. Let's go ahead and type the information in for that. So local port will have 60,000. We'll just put just a random local port there. And for our remote address, this is the Bing IP, which is 13.107.21.200. You could use any favorite website that you have there. And remote port, we know this is going to be on port 80, which is the web port that we want to check against. And at this point, we click check. It'll take a second. If you scroll down, you'll see it says load in. And a minute later, maybe not even, you'll be able to scroll down even further. There we go, it's actually already done, and you can see access allowed and the security rule that's allowed, and that is the allow internet outbound rule. So very simple way to kind of check things, are working from a connectivity standpoint, and if it's denied, it's going to tell you which rule basically denies it. And at that point, I'm just going to hop over to security group view, click OK to, we don't need to save anything there, and basically same concept. I can click in here, click say Skylines primary, choose my resource group, choose my network interface. Go select our virtual machine first of all, so we'll click VMTest01, choose that network interface, and same thing here, you're going to get a list of all the effective rules that are in effect for that particular network interface and where they're coming from. You could, if you want, isolate them down by subnet rules and network interface rules. So you can see there, these are the network interface rules, these are the subnet rules, but these are the, ultimately the effective rules themselves. And you can click in on one of these rules if you want to, like deny internet outbound. If there's any additional information, it would be there. If we scroll to the right hand side, you can also see the protocol and whether it's denied or allowed here as well. So just a overall viewpoint, instead of going back into the NSG to kind of look at things one at a time, you can just come in here, select the interface you want, and download this rule set if you want to as well. Last but not least, next hop is quite useful as well. You actually get some of this from that connection monitor that you may have seen earlier on, but same thing here. I can click my subscription, I've got my resource group there, I've got my machine, go VMTest01 again, I've got my network interface, source IP address, and let's say, that next destination, let's say it was the Bing server again. This just tells you what the next hop will be for that particular, website or whatever IP you're trying to get to. So we click next hop after typing that in. Won't take too long, just probably about 10 seconds again, just like before. And as soon as that's done, you can see results, next hop type internet, IP address doesn't really have one there, it's going straight out to the internet itself. Now, if we do 10.0.0.5, which is one of the other machines in that subnet, click next hop, you'll notice again, we're not going to have a next hop specific IP because it's a machine that's in the same VNet, so you should get a virtual network as your next hop. Next hop type, yep, virtual network, no specific IP there, and you can see this is coming from the route table, the system route, the built-in routes that exist in the subnet, itself. Now, if we had something like a Palo Alto or a checkpoint firewall, and we put user-defined routes in that were redirecting the traffic through a firewall like an IDS IPS device, then we would see that IP address there because we've redirected the traffic into that IP, and then the rule sets would be applied on one of those network virtual appliances. A few other quick things just so to round out the knowledge there. We've got VPN troubleshoot itself. If we're trying to troubleshoot any site-to-site VPN type connections, we can basically do that here. We've got packet capture as well. This is quite useful. You click add, and essentially you can do the same thing. You can select the resource group. We'll select our subscription first. Choose the resource group, choose the machine, give it a test capture. Basically what it will do is capture, whether you want it maximum or minimum is up to you, and how long you want to capture for and any filters you want to put on. But this is essentially a packet capture that will output as a .cap file and store that in a storage account for you. Probably won't get asked anything on the exam around packet capturing, just know that this is where you would go to do it. And then we also have connection troubleshoot as well. Similar, framework here. You've got your subscription, resource group, VM, destination. But here as your probe settings that you would basically put in place. So for a destination port, a specific one, you could use this also as a way to kind of check a TCP connection from a VM to either an FQDN or another IPv4 address. But somewhat redundant in some cases to some of the other checks you've got there. It just depends what you're trying to do. For connection monitor, you do have to have, again, those agents running on both those machines. Some of the other services you don't, basically. So just try to understand what it is you're trying to achieve. If you're trying to monitor the connection between two machines, connection monitor is where you want to go. If you're trying to understand if traffic is allowed and what might be denying it, IP flow verifier is where you would go. If you're just trying to figure out, okay, what's the next hop? What has it got to go to next? The next hop view would be where you'd want to go. And then these others kind of support you as well for other specific things like packet captures, VPN troubleshooting, etc. So just definitely know for the exam the type of diagnostic tool or monitor you would basically use, because those are the kinds of questions you're likely to see out there. And with that, this concludes this demonstration. In this demonstration, we're now going to take a look at quotas, cost analysis, and tagging on our subscription. So let's head over to the Azure portal to begin. Okay, in the Azure portal, the very first thing to note is if we scroll down on the left-hand side, you'll see a section called cost analysis. Simply select that first. And on the right-hand side, you'll see here the option to go ahead and download a copy of this analysis, and it shows you below the total cost. Like, here's a summary, here's all the items. So you can see this is obviously a demo account, so there's only a few things in here that are generating cost. But on the right-hand side, you will note something called tags, and I can have up to 15 tags per resource or resource group in Azure, and tags allow us to really, drill down and identify and filter that bill more easily when I get it. But I can take this period of time and go ahead and download. So again, you can choose the time span, so past 30 days, current period, past 90 days, custom, period of time, but we'll just do, past 30 days for the moment. Hit apply. You can see the cost went up there because we're going 30 days back now. And now I'll go ahead and click download, and this will download an Excel or CSV file for me that I can then open up. And once it's opened up, you can see, in fact, I'll expand out some of these columns, and you'll see it'll list out the SKU, unique identifier that's being used, the SKU for specific virtual machines, any data transfer in and out that I might have used. But it's a pretty large, spreadsheet just of stuff that you've done and when you've done it, etc. So if I scroll back to the top and I scroll over to the right, one of the key things I can do is filter on tags. So you can see this particular machine has an owner, it's got its total cost there for that machine, and these are all the sub costs associated with it. But I might have other resources. If I scroll all the way down, here's another one with owner Nick Collier. Scrolling further down, you can see here like Cloud Shell, is an owner of that one, because that's something that's used for when we do PowerShell in Azure. But the biggest problem you might find is if you don't start tagging early on, you will get a lot of resources like a storage account here that perhaps I don't know who actually owns it or what they're doing with it. So it's very, very important to build a tagging structure very, very early for your resources. Well, in the subsequent module here, what you'll see is an artifact we've created, which is a tagging spreadsheet. And essentially, because you're only allowed up to 15 tags, if I scroll down in the sheet, we'll see we've listed up to 12 tags here with room for 3 more, but you can obviously repurpose these as much as you want. But these are some examples of what I see in the industry that people need. Some clear examples are technical tags like environment. Is this dev stage prod? Do I have a maintenance window for my virtual machines? Am I doing some automation based on expiration date or a time window associated with services I deploy? These are common ones. We've divided them up into technical tags, automation tags, business tags, and security tags as well for things like data classification and regulatory compliance. Another really good one is cost center. If you have a cost center, the way your organization is structured, everybody's different, but if you have cost centers there, having that ID is a really good one to have. Then you can decide, are these tags mandatory or optional? And if they're mandatory, you could certainly, put some policy around them, which you'll hear more about shortly. But if they're optional, you could say, okay, this is something, people can choose to enter or not to enter, up to them, maybe some just optional description text, things like that. The next thing is to decide what format you want that tag in. Tags follow a key value pair situation by default. So you've got your tag name, and then the value, which could be a string or could be JSON as well. We do a lot of automation around tags sometimes. So a time window, for a server to be shut off and turned on could just be a large JSON syntax that you put in there. In addition, then decide things like who's responsible for it. Is it applied to the resource group? Is it applied to other resources? Again, you can apply tags to resource groups or individual resources wherever possible. If you've grouped everything together properly in a resource group, just assign it to the resource group. Don't go to the, the headache of tagging every individual nick and everything inside there. Ideally, you can just tag everything at the resource group, but I realize that doesn't work for everyone. And then is there any automation via Azure policy to perhaps enforce the tag? So we give you the spreadsheet as part of the course. I would say first thing is just, get in a room with the people you need to, plan out your tagging strategy, and then that will help you immensely when it comes to getting your bill. So going back to the
portal, here is, again, the tags, and you can kind of see them here. They would show up, when you kind of download that bill. If we scroll further down now, the other thing you need to be aware of is usage and quotas for the exam. And this is important because by default, when you create a new account, various things are limited. So, total regional vCPUs is limited, what type of vCPUs from which families you can deploy, how many virtual machines is your maximum. You've got 10,000 there, but you'll be capped by the vCPUs. Now, if you want to increase any of these quotas, all you need to do is simply select request increase, and this will require you to put in a support ticket, and depending on your support level will determine the response you get to that. But you'll basically choose the subscription you want to increase, choose the quota type, so perhaps compute services, pretty common one, choose your support plan, as I mentioned, basic support, and then just kind of type in your problem as you kind of go through here. So we can choose East US2, SKU family. I can choose, okay, I want the A series as an example, and I can say, okay, my current limit is 10, I want a new limit of 20. I can save and continue. I don't need to upload a file with additional details, but I could if I wanted to. And then if there's severity, at the top here, minimal impact, moderate, critical, will also determine, how quickly, Microsoft responds to that. On the next page, I'm not going to go any further than this, but you'll simply enter your contact details so they know who to contact. They'll send you an email, and you will converse with a support engineer from Microsoft to get the quota increased. So that's kind of usage and quotas for you there. Finally, the last thing to bring up here is naming standards as well, because we talked about tagging a lot. So let's take a look at another spreadsheet that we give you, which is naming standards. And this has, all the different categories like resource group, compute, storage, etc., and the different naming standards associated with them. So you can see like some of them have different length limitations. There's different patterns for actually filling them out that we recommend. So you might use like your company identifier, the region it's in, the environment, the team, the purpose. Really up to you how you come up with these patterns, but these are just examples for you. So you'll typically come up with your company identifier. You'll come up with like 3-letter acronyms for your server roles. So like some people use like SQL at the end for SQL, app, web, you decide, what you want to call it. And then you kind of whatever little, additional pieces you want to put there so that, every time somebody builds something, they're following, a standard naming convention there as well. And with that concludes this demonstration and should get you up and running with quotas, cost analysis, and tagging for the exam. One of the questions I get a lot from customers and anybody using Azure in general is just around governance and how do they restrict things? How do we make sure people can't make mistakes in the environment? And Azure policies are really a tool that allow us to enforce governance. We can say this is our policy around Azure and we want to enforce so nobody can go out of the boundaries we've set in the portal or just via their ARM templates as well. And so Azure policies allow us to do that. They are either built-in or custom coded. So you'll see in the demonstration there's a number of built-in policies you can simply apply, or you can go ahead and custom code one yourself, or just look on GitHub and look at what the community has to offer. Now they can be assigned to subscriptions as a whole, so they'll affect everything in the subscription, or they can be more granularly assigned to specific resource groups. So if we've only given somebody permissions in a resource group and we want to put some policy around that specific resource group, we can do that as well. And finally, the way we do this is we first create the policy and then we assign it. So when you look in the Azure portal, or if you're doing it via PowerShell, you'll create the policy first and then you'll scope it to those specific subscriptions or resource groups. In this demonstration, we're now going to take a look at subscription policies, which is a way to enforce what you can do in your subscriptions. In this demonstration, we're now going to shift our attention to subscription policies, which is a mechanism to control what people can do inside of your subscription. So to begin, we're going to head over to the Azure portal. Okay, and here I'm in the Azure portal, and one of the things to note, first of all, in the previous demonstrations, I was using a trial account to kind of show you everything. At this point, I have shifted over to one of my other accounts, so don't worry, everything will still proceed as normal, but you will see from time to time that I'm in different Azure accounts as I'm trying to demo things, but nothing to be alarmed at. You should be able to do everything you want to do in your current account. To begin, though, I'm going to go over to subscriptions, just like you saw when you created your trial account, but in my case right now, I've got Visual Studio Enterprise, and in some other demos, you'll see I have other subscriptions as well. But for right now, I'm going to use my Visual Studio Enterprise account. And I'm going to go in here, and if we scroll down on the left-hand side, you'll see a section called Policies, and this is where we want to focus this demonstration on. If we click Policies, on the right-hand side, you'll see that currently everything is 100% in compliance, and that's ultimately because I don't have a lot of policies and a lot of resources right now in the subscription. But the key thing at the top here is you can see that I can assign policies. So if I click this box, Assign Policy,
will prompt me in the next screen to choose my scope. So this is where do I want to assign the policy. In my case, I just want to choose the subscription. I don't need to exclude any specific resources from this assignment. So I'm saying everything in this subscription called Visual Studio Enterprise, I want to apply policy to. Well, again, what is our policy? And this is where you create a definition for your policy, or you use one that's already built in. So you can click the little box to the right, and this will open up all the different policy definitions. In fact, there's 144 right now available to you. You can create these as JSON templates and put them in here as well. This is where Microsoft has massively expanded policies because they've taken all the best practices from lots of enterprises out there. But in your case, let's look at a few of these real quickly. Well, what if I wanted to set a policy on deploy log analytics agent for Linux VMs, making sure that, it's a well, let's look at a few of these very quickly. If we scroll down, you'll see things like audit VMs that do not use managed disk, something you'll find out about in the virtual machine section, making sure you have log analytics agents for your Windows and Linux VMs, and so on and so on. Things like disk encryption are in here as well for storage accounts, and audit transparent data encryption status for PaaS services like SQL databases. These are all good examples. But if I go back to the top of this and search, if I filter with built-in, and then choose allowed, you can see a number of policy definitions that are actually quite common. Things like not allowed resource types, allowed storage account SKUs, allowed resource types, and these two are really popular, allowed virtual machine SKUs, and allowed locations. So I can say, for example, I only want to allow specific virtual machine SKUs. I don't want to perhaps allow very, very large virtual machines because they could be very costly. So I can choose here, allowed virtual machine SKUs, and click select. The policy definition is filled in. You can see the assignment name, allowed virtual machine SKUs. You can change that if you want to. And if I scroll further down, you can see the description, assigned by, and here is where I put in the parameters for that policy template. So right now, 0 selected. If I click the drop down, I can now choose the virtual machine SKUs that I want to allow in the subscription. So I could choose, just the basic A0, A1, whatever I want. Maybe I want to choose all the D series. Again, you'll learn more about these in virtual machine section if you haven't already jumped ahead and covered that. But I could choose, D series, which are common, A series, etc. So just go ahead and select the ones that you would want to allow. I can choose also to use a managed identity, which you'll learn more about in the identity section later on as well. But with that, if I'm happy with everything there, I can go ahead and click assign. And now that creates that policy, and now it will only allow me to deploy machines in the subscription that match that specific SKU type. And you'll see later on when you build virtual machines, if I tried to then go and build a virtual machine that was perhaps, F series or G series, it would simply error out during the build process. And if I wanted to fix it, I would need to go back in here to this allowed virtual machines policy and basically delete that assignment if I wanted to get rid of it, or edit it if I want to just add additional SKU types. Now this is very important because in the enterprise, you probably want to start off with a certain amount of SKUs that you allow, particularly if you're early on in your Azure journey. Again, maybe the A series, D series, etc. And then as needed, you might allow certain teams access to those very, very large, perhaps the M series giant memory virtual machines. You could have then allowed them access to them by assigning a policy that allowed them access to them. Perhaps you assign that policy to a specific resource group. Perhaps you don't assign it to a whole subscription. So you get kind of creative as you work through these. The last thing to mention, which isn't strictly covered on the exam scope yet, is the concept of management groups. And all that means is you can take policies that you've assigned to different subscriptions, and instead of going to every single subscription and creating the policy and assigning it, you can essentially assign it to a management group that contains multiple subscriptions. So if you said, okay, I've got 100 subscriptions across my enterprise, and I want the same policy applied, I would then go ahead and use a management group for that and assign the policy that way. So that's future discussion, but just something you need to be aware of as well. And with that, this concludes this demonstration. I highly encourage you to go in here and play with these and then try to provision things against the rules that you have. But just make sure if you don't need that permanently, go ahead and delete that assignment. Otherwise, you'll run into various problems later on. One of the features Azure provides to prevent accidental resource deletion is the use of resource locks. And these are essentially just a mechanism for locking down resources that we want to have that extra layer of protection before they can be deleted. So for example, when we delete in resource groups and storage accounts, etc., we've just gone in and deleted them. Often we have to type in a name or something to actually delete it. But a resource lock creates this additional layer that we have to kind of remove first before we can delete the resource group. And there's two options available. One is cannot delete, and this is authorized users can read and modify but not delete the resources, so they can make changes to them but not actually delete anything. Read only, authorized users can read the resource but cannot update or delete. So the one that's actually most restrictive is read only, because it's read only. You can't modify any of the resources in there or delete them. Cannot delete, you can't delete them, but you could still make modifications to them. So a lot of people often think cannot delete is the most restrictive, or no, it's actually read only. So if you just want to make sure no one touches it at all and modifies it, use the read only resource lock, and you'll see how to configure these in the upcoming demo. In this demonstration, we're now going to implement a resource lock in Azure on a particular resource group. And this is to help in case we had something like shared services infrastructure or some particular data services we wanted to make sure nobody could delete. So we'll head over to the Azure portal, and in there we're just going to pick a resource group. So in my case, I'm using sl-arm counts. This is one from a previous demo that we're going to delete eventually, but for now we're going to test it out with a lock, and you can see that this resource group has 5 storage accounts in it, so we don't want it to get deleted just yet. We'll hit the lock section, and we'll go in and click Add, give the lock a name, and choose the lock type. Now if you remember from the tutorial, read only is the most restrictive, but in my case I'm just going to use the delete lock for this occasion. Select OK, and you can see that lock is now available on the resource group. If we scroll back up to the top, and I attempt to delete this resource group, so I'll type in the name that it prompts me as per normal, and I hit delete, immediately we get that error saying the resource group SL arm counts is locked and can't be deleted. And if I go back in and remove that lock, the resource has no locks now. Go back to the overview, delete the resource group, and at this point it's going to delete, hopefully if all goes well, all of those storage accounts in there, and you can see it didn't come up with an error this time, so it's now in the process of simply deleting that resource group and everything that was inside it. And with that, it concludes this demonstration, and hopefully that gives you a quick insight into resource locks and how easily you can just put them on your resources in Azure that you want to protect. You'll probably get 1 or 2 questions on the exam on this, just how would I protect resources, and there's obviously different mechanisms we've covered so far in this module. Now that we have a base understanding of all of the technologies involved, let's take a look at some more real-world examples. And first of all, let's focus on a subscription design example. So perhaps we have our enterprise with an EA, and we just have an information technology department to begin with. You'd have more departments that scale out, and you have an account with an owner. In this case, the owner is me. I've got various subscriptions that I'm now designing. So I've got a shared infrastructure subscription. That's the subscription for all the shared services that other teams may use, but I ultimately want to keep that as a boundary, a resource and an identity RBAC boundary to use to restrict that to the infrastructure team. And within that shared infrastructure, perhaps I've got some subnets that I start out with, some /16s that I can further carve out as needed, and perhaps we start US East 2 and US Central in this example, where I've got a 10.10.00/16 in US East 2 and a 10.11.00/16 in US Central. Often we do this in the real world. We sort of take the even numbers and we put them in one region, and we put odd numbers in another region as a way to kind of easily identify what we're dealing with. Then perhaps I've got additional subscriptions. I've got a production subscription that I have much more restricted access to. Perhaps I'm requiring all my development teams to, do all their work in testing in non-prod, and then perhaps they deploy using their CI/CD tool with a service principal to the production environment. And again, I have some /16 networks that I'll start with and further carve out in from a subnetting exercise later on. Then I've got my non-prod, and then finally perhaps I have a DR subscription as well. And I could have many, many more subscriptions. Perhaps I give subscriptions out for each particular business unit. Perhaps I put everybody in the prod subscription and the non-prod subscriptions, and I create resource groups, and that's how I do my controls. There's multiple ways we can really focus on this, and really it's going to come down to, am I going to hit any subscription limits, and where do I want those boundaries to be? So here we have an example for cross-premises connectivity, and in this case we have a customer that has an on-premises data center in Colorado. They have chosen the North Central region in Chicago as their primary Azure region, and the South Central region in Dallas as the failover region for DR, or just when they want to put other workloads there to be closer to their specific customers. But in this case, what you can see is the client will use site-to-site VPN tunnels and an express route to connect the on-premises site to Azure, and by connecting through express route to the North Central region, they can then go across the Microsoft backbone when they want to talk from North Central to South Central. We can use cross VNet peering across regions, so you can see we've got VNet peer in there, and we've got site-to-site VPN connections as well. So there will be a dedicated VPN gateway for the prod and a dev UAT subscription in each Azure region. So if you look there, the subscriptions, we've got that prod subscription, that dev subscription, and they've got their own VPN gateways inside of each of them, and so they're completely isolated. We can test things out in dev before we push maybe VPN changes to the production production subscription if we want to. If you look at this, just the colors there in green, we've got production traffic. So you can see, on premises, Colorado data center, we'll talk up to North Central over that green express route circuit once it comes online. And then there's, express route. We can do VNet peering from North Central to South Central as we need to when we want to talk across there. And then the purple, we've got those failover connections as well. And we also have a test kind of sandbox option available too. The client will use 650 megabits a second gateway speed as the starting point. That's the SKU they're going to use. They will add that express route. Remember, that can take some time. If you remember from the networking section, it takes time for those circuits to be made available. But once that's online, that will become the primary, but they can simply get started and use the site-to-site VPN connection until such time as that is available. And lastly, there will be 4 total gateways and 5 total VPN tunnels, as you can see in the diagram here. And so that's an example of a typical, initial foundational environment that you might see. And you might get some questions around this, around, hey, I've got express route as my primary, site-to-site as my failover, and cost considerations will be something to look out for in the case studies specifically. In addition, here is a little bit more detail around a secure hybrid connectivity setup that you often see. And on the left-hand side here, you can see we've got a data center with an express route circuit of private WAN connectivity. And then they also have that site-to-site VPN over the internet as backup. Again, the express route circuit is always preferred, more reliable. We know the kind of throughput we're going to get at our dedicated circuit. As soon as we go over the internet, things start to become, more unreliable. If we look then in this network that I've got in the middle here, this is our shared services VNet in this example. And you can see coming in from on-premises, we've got the express route gateway and a VPN gateway. I've also got an application gateway subnet here for public IPs, and I might stamp out more application gateway subnets specifically for individual application teams, and maybe they're in separate VNets, but this is just an example to show you. And the benefit of the application gateway, again, is I've got 8443, and I can do, layer 7 inspection on those app gateways for anything I need to have publicly accessible there. Then perhaps I've got an untrust subnet that comes in, and then an internal load balancer in front of some network virtual appliances. These could be Palo Alto, Checkpoint, see a lot of those out in the industry today. And then I start to get into my trust zone after that. So I've got my trust subnet, I've got my load balancer there, so traffic coming back through that maybe wants to hit on premises would also go through those Palo Altos. And then perhaps I've got identity front end, back end, as needed there. So that's like a typical shared services subnet there. Then what you see is we've got VNet peering on the right hand side to specific VNets that I might have. These could be on an application basis. These could be shared VNets that we use. In this example, I've got some shared ones. We've got a front end VNet, which is going to house virtual machines. I've got a prod internal VNet. I've got a PaaS VNet. Maybe I've got some separate PaaS services that have endpoints in there. All different ways to configure this, obviously. You would need to design it for your specific application. But one important thing you notice there, in some cases I've got VNet peering, where I'm peering from the shared services VNet. This is the hub and spoke model. I've got my hub in the middle, and then I've got these spokes coming off through VNet peering. And so those, VMs in those peered VNets can talk back through the hub and then can talk back through to on-premises as needed, providing there's no overlap in address space. And it's important to watch out for overlap in address space type questions, on the exam, because if you're going to have a subnet out in Azure and you've got that same address space on premises, they're obviously not going to be able to route to each other without any kind of NAT-in technologies in between. In addition, we've got UDRs going on throughout as well. So the user-defined routes will force everything back through into that trust subnet, which is where that load balancer is, and that's going to force the traffic ultimately through the Palo Alto. So the user-defined route will explicitly say that the next hop when we're trying to reach on premises is going to go through those Palo Altos or Checkpoint network virtual appliances. So I get that layer 7 additional security, requirements there as well. So all of that, really to show you that's typically what we would see in an environment. And key things to watch out for here are user-defined routes, VNet peering, overlap in address space, and knowing the ability to use network virtual appliances if you need an additional layer of security. Azure Firewall also just went GA and is available. It's still a very new product. A lot of customers are still preferring, Palo Alto, Checkpoint, etc. But using an NVA network virtual appliance is a common method to make sure you get that additional security requirements met. Last but not least, from the example section, let's look at a highly available application across 2 regions. And if we look here at the top, we've got Traffic Manager coming in. So we're going to redirect our traffic now through Traffic Manager, and that's going to decide which region we hit. So perhaps it's somebody coming, users in North Central will hit the North Central region. Users that are closer to South Central will be directed to the South Central region. And Traffic Manager will help decide that. Essentially, once it decides where they do go directly to the public IP address in that region. But to begin with, they would, hit Traffic Manager first, which would tell them where to go, and then they go direct. So Traffic Manager isn't in the way of the traffic. It's just telling them which region they need to go to. If we also look there, we've got the DevOps user in the middle there. This could be somebody that needs to jump into the region to actually do some maintenance. So perhaps we put a jump box or something, in a subnet, a secured management subnet there, and we can use Azure Security Center to temporarily, do just-in-time access or something on that subnet as well. Once we're in the region itself, we've got high availability now because we've got availability sets or availability zones for every one of our applications there. As you can see, I've got a bunch of VMs, that are in there, 3 VMs there, so they would be an availability set with 3 fault domains if the region supported it. it, and then we go into load balancers as we sort of connect down, through the stack down to the SQL services, in the SQL Server layer itself. We also have that gateway subnet as well, so you've got the site-to-site VPN gateway between those regions. So if anything did need to talk across, or if we have to do any kind of replication of data, that can happen there as well. The great thing about this is a highly available application as opposed to the one we looked at when we did Azure Site Recovery, where the region was on standby. In this case, I'm saying, okay, you can come in, you can hit either region depending on where you're coming from, and if one of the regions goes down, I'm still up and running, just all my traffic is hitting, one of the regions as opposed to two. Now, when that happens, the things to look out for are, well, what is the impact to application performance? Suddenly, I'm in a situation now where 3 VMs in the web tier are supporting all the traffic because one region went down. So do I use scale sets? Do I scale out automatically? What are the options to scale in the event that happens? Because by default, maybe I've got users in North Central, go to North Central, hitting 3 VMs, South Central, go to South Central, hitting 3 VMs, I've got 6 VMs supporting that traffic. Suddenly I'm down to 3, all the users are coming into one region. How do I scale that out? So look at this, think through these scenarios, and really, the questions are about answering and making sure that you understand the requirements, in order to meet the availability requirements for the user. As we've talked about throughout this course, pricing, and we've gone through various pricing tiers for identity services, for VMs, etc. And hopefully by now, you know that there's so many toggles that we have available. And cost is just something that we need to think about throughout all of our architectures, and how do we truly manage that and optimize it. And so what I thought I'd do here is go through an example that I created with a client when they were trying to make decisions around a shared infrastructure that was expanded to their users to onboard SQL services for their clients, and some of the decisions involved with that. Before I go into the specific calculator I've got, make sure you're aware of the pricing calculator on the Microsoft website. If you just search pricing calculator, just Google it in, you'll come across this website here, and you'll see, various things that you can look at. So these are all the Azure services that you have. If we go in and we take a VM, first of all, it'll pop up here any second. It says virtual machine added, we'll click to view that. And here you'll choose things like the region it goes in. So let's say we choose East US 2, the operating system, Windows or Linux. In fact, we'll choose Windows here because I want to show you the hybrid use benefit, different tiers, and then our different instance sizes. It goes without saying, more CPUs, more memory, we pay more. In addition, we have those options of using reserved instances to get discounts. So 1 year, 3 year reserved. Watch out for this on the exam specifically, because that will help you, say if they're going to use the workload for a long period of time, using reserved instances can help save money if it's a predictable workload. In addition, if you've got Windows licenses, there's something called the hybrid use benefit, which you can toggle, and that saves additional money because you bring your Windows licenses, and that's something to look out for as well. But multiple options. You'll also choose your disks, your storage, storage transactions. So you do need to understand, transactions per unit, how many disks you have, what size of disk you have, if you're going to use standard SSD, standard HDD, premium disks, etc., support programs, all of that goes into it. In fact, I'm just going to show one other because storage decisions does come up a lot as well. And if we go down to storage and we choose, say, blob storage, we've got a lot of options here that we can choose between. But let's assume for the moment we've got a general purpose V2 account. Choosing the different redundancy options, if we go from locally redundant storage in the data center to GRS, more than doubles our cost there. So look out for things of geographic redundancy is required. That will impact the cost of the service itself. A lot of questions are going to ask you how to minimize the cost for the particular use case, and this is something to keep in mind. Write operations also increase your cost as well, so make sure you know how this affects things. In addition, you absolutely will probably get questions on the access tier. The hot tier is there. If we go down to cool storage, we pay less, but then we pay additional fees when we want to access. If we go down to archive storage, significantly cheap, but we are going to pay penalties as soon as we try to access that data. So again, look at the use case, look at how long you're trying to keep it for. General rule of thumb here, as you probably remember from the storage section, is hot tier frequently used, 30 days or less, cold if it's over 30 days, and archive if it's really long term. So definitely make sure you know about storage options and how they affect cost. Yeah. But with that, let's jump over to my spreadsheet. All right, so in this example in my spreadsheet, I basically created a sheet to determine the costs associated when a customer chooses between IaaS SQL or SQL managed instances and various additional things that they add on top of that. So first of all, to begin, if I scroll down, I've got some SQL instance sizing where they can choose to go full PaaS with SQL managed instance, or they can choose SQL IaaS. They can put in different data sizes that they want, so 4 terabytes as an example of data warehouse size that they're going to add in here, and how long they're doing backup retention for. But if I go ahead and choose the IaaS option to begin with, because then then I've got no price for managed instances, but I do need to go down here and start to calculate my IaaS costs. And all these costs are essentially coming from the pricing calculator. I've done an export from the pricing calculator, imported it into Excel, so then I can add up my costs as I kind of move things around. So now we've got SQL IaaS, I've got a single instance option, so if I just choose one node, but perhaps I need more availability, so I do an always on availability group. That's now going to provision additional SQL servers plus the cloud witness, and that adds additional costs for me. So now I have my compute costs, my SQL IaaS data prices, and my backup prices all there. That's now my SQL instance that I'm basically going to build. In addition, if I scroll down, I now want an additional node. Perhaps the business is using SSIS, SSAS, a separate VM next to the SQL server. Perhaps they use Azure Data Factory. You could do some of the pricing around that, or Azure Analytical Services for the SSAS replacement. But essentially now I need another VM, and I need more sizing associated. So again, it all comes down to compute and storage here. So the disks associated, if you remember from the VM section, I pay for the the price of that disk itself. So if I'm going to a P40 managed disk, then that's what I'm going to go up to. And now I've got additional pricing here. So these are the things you need to start thinking through for the exam, particularly as you work through the use cases. If I go down further on, I've got licensing costs. Perhaps I've got Azure Security Center costs I need to add in as well. And then I've got additional costs for storage. So for blob storage, maybe I'm ingesting data into a blob store. Maybe I'm transferring storage around from one blob to another. I've got to pay for that. In addition, I've got identity costs. If you remember from Azure AD, if I'm adding on users that are going to use the service and they need to authenticate with Azure AD, well, I've got P2 premium license costs that I might need to be adding in there, particularly if I want services like identity protection as well. Additional networking variables, note that you will pay for any additional networking activity that you may be transferring around, inbound or outbound, depending on the rules of the network you're in, where you're transferring from and to, but typically you'll pay for egress of any data transfers. And then there's other costs as well, something again, going back to storage accounts and knowing what that costs and keeping the costs down, you do need to create storage for diagnostics as well. Typically VMs, you're going to store diagnostic logs, you might keep those in a blob store as well, perhaps use an Azure Key Vault, very cheap service, but you need to add these things in. And all of that keep in mind, because as you have shared services as well, in my case, working with this customer, we were using a Meraki connectivity in addition for networking, but we had a core of Palo Alto and everything going on in the hub, and this comes up time and time again in our customers, and depending on how many of your customers are using that core, price could go down. So you can see the share of the core, depending if we go from 10 users to say 100 customers of IT, the shared services price essentially goes down, and you'll need to decide how much you can scale that up and down in your hub, as we discussed in one of the other examples. And then you've got your networking costs, your IaaS costs, licensing costs, storage account costs, identity costs, etc. And all of that adds up to say, hey, for this application, these are my total fixed monthly costs. And that's how I would encourage you to think about, architecting as you go through. And then you can play around and toggle, and, as you change the architecture and you add some more storage or remove something or change the workflow in terms of how the data comes in and out of the system, that will ultimately affect your pricing. So definitely take a look through the pricing calculator. I would look through the VMs, storage, app services, identity services at its core, and just play around with the calculator with those. And then just think about it in the context of what I've shown you here, and certainly encourage you to build your own spreadsheets like this, as you work on specific applications.
Hello Cloud Gurus. First of all, just a huge congratulations for completing the course. There is so much information to cover and it's always changing, so just a big well done to you. You've now learned everything you need to now move on and take the exam. Make sure to follow up with the study guides included, get some experience in Azure, and I wish you the best of luck. When you are done, check out the other Azure courses available to continue your journey in becoming a master in Microsoft Azure. Keep being awesome, Cloud Gurus.